world oceans into the Lake Erie, Great Lakes, and of course we don't have time to discuss that one. The third problem that you are faced with the water quality deterioration in the nearshore waters, and the Great Lakes is the home for nearly 60 million people, and 40 million people in Lake Ontario alone in Canada depend on the drinking water supplies from these lakes, and maintaining the water quality of this one is a very important, very utmost important for the in terms of managing these lakes. So just to give you an idea of this one, you already see this picture that Ram presented in this one. Just to give you a historical or a geographical this one, Lake Superior that you see at the top is the largest lake in terms of the surface area in the world, and the deepest lake is of course in Russia, which you will hear from the next presenter, next presentation by Dr. Filatov. And these lakes are all interconnected hydraulically. In other words, there is a continuous flow of water from the north, from Lake Superior down to the lower lakes, Lake Erie and Lake Ontario. And so this hydraulic gradient is very essential for the water, because from the northern latitudes where there is a lot of snow melt from the Arctic region, that all that precipitation in terms of snow, rain, everything drains into these lakes and then eventually flows out through the St. Lawrence River into the Atlantic Ocean. So this is how it looks in terms of, if I take a cross section from Lake Superior here down to the Atlantic Ocean, roughly about almost 1,000 kilometers. So it's a natural hydraulic gradient. The water flows from one lake to the other through a system of rivers. You see this St. Mary's River draining from Lake Superior to Lake Huron. Then you have St. Clair River and draining from Lake Huron to Lake Erie, which is the shallowest of the lakes and the mostly highly vulnerable for environmental problems, which we just discussed by Ram. Then you have the Niagara River, which has the biggest drop of 100 meters. So you know the famous Niagara Falls that is located here. So then from there drains into Lake Ontario, and then through the St. Lawrence River it goes through the Gulf of St. Lawrence and into the Atlantic Ocean. Of course, because of this hydraulic gradient, there is a tremendous potential for power generation. But of course, these are freshwater lakes that are used for many, not only exploiting the fisheries, drinking water issues, and various other human. So what I would like to give you here is some basic facts. Since this water's hydraulic gradient, the water flows from one lake to another lake, one would be interested in knowing what is known as the residence time or the flushing time, how long that a water mass remains in each lake, which is essentially determined by long-term average storage volume of the lake divided by how much of water goes. Average residence time is a very important parameter in order to look at the water quality, because of these lakes are so huge, both in terms of volume as well as any substance that gets into the system would remain there for a very long time. So this hydraulic residence time is a very important indicator in terms of trying to assess this one. So I give here some of the calculations that we have done for the all the 5 Great Lakes. Lake Erie, which Ram discussed just now, has a flushing time of 2.7 years. So anything that goes into this one, although it's a hydraulic system, still it is a very slow hydraulic system. So Lake Ontario, the next one, which is 7.5 years. Lake Huron, which is somewhat bigger, has 21 years, and Michigan has 62, and the biggest lake has 173 years. In other words, you know the complexity that is involved in it. Any contaminant, particularly the toxic contaminants, microplastics and those type of things are going to remain in the system for that many longer period of time. So in terms of managing the water quality, we follow fundamental approaches. I don't have time to discuss in greater detail. We follow what is known as the integrated watershed management that includes multi-barrier approaches, and also some of the things that I already mentioned yesterday in terms of the new chemicals are introduced using the precautionary principle, and we adopt the best available technology to treat the water, and all those aspects that are in the watershed. And then we also follow this ecosystem approach for sustainable living of the ecosystem, because this ecosystem is home to many biological diversity, particularly fisheries. So we have to make sure that is also protected, and we do that by doing environmental monitoring, continuous environmental monitoring and assessment and evaluation to what management actions are required to achieve the sustainable benefits, some of which already was mentioned in the previous presentation. Explore important opportunities for trade-offs in terms of treatment choices, including essential treatment choices, including choices for resources management. So the Great Lakes Restoration Initiative is something that we incorporated almost 30 years ago to protect and restore the world's largest surface water system. This is, as you have seen, is the largest surface water system, and also to strategically target the biggest threats, such as the one which we saw in the previous presentation about excessive phosphorus leading to eutrophication and algal blooms. And the second problem that I am going to discuss is this cleaning of the coastal areas of concern. In other words, many coastal areas are very heavily polluted because of major cities are located around the Great Lakes, and there is also excessive use of fertilizers for agricultural practices, which also drains into this one. So all this causes the near shore, that means very close to the shore, within the first 2 kilometers of the shore of the lakes being polluted, and that's where we have to draw water for drinking purposes. So much of the exchange of water for human activities takes place within these 2 kilometers, and therefore it is a major area of concern to protect it. That's what I am going to discuss in the later this one. Restore habitats to protect the native species. I mentioned to you about the alien species which are migrated from through the navigation system from the great oceans, from St. Lawrence. You know, I showed these lakes are also used for navigation purposes. They are connected with through the St. Lawrence system into to the Atlantic Ocean. So we have an order of precedence in protection of the water quality. Domestic and sanitary purposes, of course, occupies the major this one, number one, and also navigation, including use of canals for the purposes of navigation, which also is important, and the power and irrigation. I mentioned to you, because of the large very hydraulic system, there is very large potential for hydroelectric generation on both sides of the border, both from the American side as well as the Canadian side. It's all negotiated in terms of sharing the water, both for power generation as well as for agricultural purposes. No use shall be permitted which tends to materially conflict with or restrain any other use which is given over it in this order of preference. So these are some of the areas that I am going to talk about. I will pick one of them for Lake Ontario. So as you've seen here, these two are the lower lakes. This is Lake Erie, where we had the intense phosphorus loading causing eutrophication, and this Lake Ontario, which is lowermost Great Lakes, also very heavily populated because the city of Toronto is located. This whole area has a population of about 1/3 of the population of Canada, and as a consequence, of course, we have serious water quality issues for drinking water quality issues. So these are the areas which we call areas of concern. That is, this is where the water quality in all these areas has been compromised already. Therefore, we have to take action to see that they are remedied. So coming to this last lake, you see the Lake Erie is connected through this is the city of Buffalo. Niagara Falls is located here, and then of course through the Niagara Falls it enters into Lake Ontario. This western Lake Ontario, what we call, is the most populated area. City of Toronto is there, city of Hamilton, and there are many small cities, and this area has been almost 3 million people live in this, and they depend on this lake for drinking water purposes. And I am going to talk in most of my presentation is going to concentrate on this area to protect the water quality and issues for drinking, and how we have approached it from the beginning. This is the lake, just to give a brief background, and because these lakes, we live in the temperate climate, and as a consequence this lakes goes through this annual thermal cycle, because in the winter time the water cools down to almost close to temperature of maximum density. Some of you probably know the temperature of maximum density for fresh water is 4 degrees centigrade, and as soon as the water reaches 4 degrees it sinks. So these are complications that are introduced in trying to manage this water quality in these areas, because there are several physical processes which come into picture. We have to take into consideration to make sure that the water quality is preserved. So this annual thermal cycle, particularly in the beginning of now the temperature is going down in the winter time in Canada. Now most of the coastal water is all almost close to 4 degrees centigrade, and there is a big downwelling, we will call it, because the water, once it reaches 4 degrees it sinks because of the maximum density because of the maximum density at 4 degrees. So then this annual cycle completes, and then eventually, of course, by May, June, July, the lake is completely warmed up at the top, but the bottom layer is still at 4 degrees, because so it is 2-layer system where you have water up to about 20 meters deep is above 4 degrees centigrade, and below that depth is at 4 degrees centigrade. Of course, much of the drinking water is drawn from at the bottom of the lake at 4 degrees centigrade. So when the water comes into the domestic use, it is already fairly cold water, so around 5 to 6 degrees centigrade. So this is the picture it looks in major part of the season. From May to June, you have a mixed layer up to this depth. Mixed layer in the sense the temperature is above 4 degrees centigrade. That is above the temperature of maximum density, and then you have below that is the temperature of is the 4 degrees centigrade. This is the temperature structure. So why I am presenting this one is it is not so simple as to draw water from the lake and treat it and then supply it, but we have to take into consideration many of the processes that takes place due to the climatic changes, or the annual the weather cycle. So these are some of the complex processes. I have no time to discuss any one of them because it's a fairly complex environment if you look at it. Not only the temperature structure changes, the water movement also is controlled by the prevailing weather conditions, and complicated by that one of course is the because these lakes are so huge, they practically behave like oceans. Because Lake Ontario, this is the smallest lake that I showed you, is roughly about 250 kilometers wide and 80 kilometers width. So they behave like oceans, and there is complex water movements that is taking place in addition to the thermal changes which we have to take into consideration in drawing water for drinking purposes, which is done. So these are the western end of Lake Ontario. These are the cities which are draw water for drinking water purposes from the lake. You can see that there are, but at the same time, the wastewater that is generated after use also goes back into the lake. So we have to make sure that the drinking water supply is protected and it is not having impact of this discharge of the wastewater. But this discharge of the wastewater is also treated water, and we have a fundamental policy that anybody who takes water from the Great Lakes for any purpose, including the cities or agricultural practices, they have the obligation to put it back to this almost the same water quality as they have taken from the lake. So that puts a lot of pressure in terms of technologies that is available to treat the wastewater, as well as the making sure that they would not have impact on the drinking water source. So these are the what we call areas of concern. They have all around the 5 Great Lakes. I am only showing the western part of Lake Ontario. This is where we have the threats for drinking water systems, and there we have to protect them. So how we are going to protect them is what we are going to discuss. So we just a general this one, because management of the water quality is very important, because as I mentioned, the coastal resources, not only drinking water but also fisheries and other recreational uses, because these lakes are used during the summer months for various recreational activities in the beaches and all. So we have to have a policy in terms of how we make sure that the coastal areas are maintained in a environmentally safe way, so that people can interact intensively. Many times when we have very serious problems because they are monitored continuously 24 hours a day. If there is any particular problem, this one often you will see that they will have precautionary boards where say that not for human contact. That means that you have to, that doesn't happen very often, but once in a way it does happen, and in terms of that one there is precautionary announcements to see that you stay away from that area. That never really happens, as I have seen in the last 30 or 40 years. So the pollution prevention abatement control problems, municipal sources, of course, as you know, industrial sources, agriculture and forestry, contaminated sediments that is going from discharge of, you see there was a practice for many years, the very toxic and heavy metals were disposed of through burying in land disposal sites. And these contaminated contaminants are now gradually seeping through the groundwater system into the lakes. So there is many sources of pollutants that's coming, not only direct discharge from the wastewater, but also these contaminated sediments and seeping through the historical disposal of these sediments all around the lake through the underground groundwater system and reaching into the lake. So there is also some source of radioactive materials, which because of these there are several nuclear power plants located on these Great Lakes because they draw water for cooling purposes for these thermal plants. So there is a lot of interaction between the lake and the population, and there was also inevitably you will have very challenging environmental problems to deal with. So the reducing municipal water and stormwater pollution, these are some of the environmental challenges you can see there. And then the question that we always ask is our drinking water at risk? Because that's a fundamental question. All the population around the Great Lakes keep raising this one, and of course it's a very important aspect. There is in the US, of course, the Center for Disease Control has this about 1 million Americans get sick due to contaminated drinking water. Of course, Great Lakes is one of the major this one for Americans also. So there is a tremendous interaction between the lake's water as well as the human population, and so as a consequence, of course, many chemicals get into the lake. So the laws that are placed in place to protect the drinking water, the Americans have this Safe Drinking Water Act, and designed to ensure the quality of US drinking water. And in Canada, we have this Clean Water Act, protects the water quality. They are more or less similar in terms of this one. So for most of the drinking water, we generally draw from many streams because of fresh water, draw it from lakes and rivers, aquifers, groundwater. So there's several sources. One of the fundamental things that we have to make sure is to protect the source water. Source water protection is the first fundamental principle that you have to make. There is no point in degrading the natural water system and then trying to create this one. So as you have seen that we take tremendous effort to make sure that sources are well protected. Then of course treating and all of course becomes relatively easy. So we use this multi-barrier approach, which you also see that means, in other words, in every stage we put restriction on pollutants that getting into the lake, as well as at the same time positive actions that you have to take in terms of treatment of this water. So many of them are of course are water based and locally driven program because of the complexities that are involved. So we already mentioned to you, we use the tremendous application of science and technology. We continuously keep studying these waters. Also we use the state of the art technology. As I mentioned to you, best available technology. We mentioned some of the things like we have developed the membrane technology for treating, which was extensively used throughout the world, including in Singapore. And we also have the precautionary principle. We do not put any chemical which is considered to be harmful. So unless and until the chemical has been proved to be safe, it will not be allowed to go into the system. So there is a lot of checks and balances which is followed. So we have this multi-barrier approach that essentially says the up-to-date water system, water distribution system, and all this one. So this is how it looks like. Eventually the clean, safe water, drinking water is here after several barriers imposed on its quality. So we identify the area from which the drinking water is drawn. We create an inventory of the actual pollution sources, whether it is wastewater or runoff, agricultural runoff or industrial sources. So and determine how susceptible your drinking water supply is to contamination from these activities, particularly specific contamination sources. We will make finding widely available to these findings are available. So in terms of the concern that we have also the water cycle, the water cycle in the Great Lakes for human consumption, particularly for the drinking water. We know that this climate change also has posted, which you saw in previous presentation, also some of the issues that we are challenges, I would say, that we have to face in terms of adopting to the new scenario of impacts of climate change. The carbon cycle, climate change mitigation, and the water cycle adaptation are interlinked, because with the water cycle, hydrological cycle, and the climatic this carbon cycle are interrelated. If you look at it, whether it is through the agricultural practices or any other this one. So we have to deal with this in this one. So some of the climate change impacts that you have seen, we have seen not only in this part of the world, but also in Canada. We had a very serious impacts in the west coast of Canada, where these atmospheric rivers, the large amount of water drawn from the Pacific Ocean when meet the coastal mountain range, very heavy precipitation in a very short period of time, 200 to 300 millimeters of water fell. As a consequence, we had flooding, and all the infrastructure was washed out, and the temperature reached almost 50 degrees centigrade. So we have episodes of that type, and of course that would have significant impact in managing the resources. Increasing frequency and severity of weather events associated with natural results such as floods. Almost 250,000. Canada's population is very low. 250,000 people have to be evacuated from this zone because of the flooding, as well as the impact of the very high temperature. As I said, 50 degrees centigrade is this is a heat dome. It's unexpected, and it is caused as a consequence of these atmospheric rivers, which are atmospheric rivers essentially means a large system of air drawn from the Pacific Ocean with very high moisture content, and when this atmospheric river hits the shoreline, it all condenses, and then very heavy rainfall takes place. So we have serious problems of that type that we have to deal with. Determine what is practical and achievable municipal water systems, more resilient to storms and extreme weather. We have to manage the stormwater management. Stormwater management is the wastewater that is waste, as well as the stormwater from the land-based activities. Of course, that goes into the system. And understanding what innovations can achieve the performance and for future challenges. We also have, because these lakes are this one, we have these big storm surges, just like what you see in the oceans, big waves coming along the coastal. So all these have impact on managing the coastal resources. Yeah, so that's probably, yeah, okay. So essentially, resilience to the climate change. What is practical, how we can manage this one, because this is not something, it's a new normal beyond what we were dealing with before the climate change actions were non-existent. But of course now it has become a reality in the last at least 4 to 5 years, and no part of the globe is exempted, whether it is Canada or India or any this one, because it doesn't discriminate. Climate change doesn't discriminate this one. So understanding what innovations we can incorporate in trying to manage the water quality is of paramount importance. Thank you.
Thank you, Professor Murthy. Any questions? Yeah. You will give that?
Okay.
Yeah,
you translate it. Yeah.
Thank you, sir, for the wonderful presentation. My question is, as the lakes are flowing from one lake to other, the water is flowing. So, is these, if we control the external factors, so these lakes have some self reservating value, like they can control the pollution themselves, like they can reserve their life cycle and everything by themselves, as it happens in rivers.
Okay, as you rightly said, when the water flows, because of the aeration, the treatment happens. So that is what we have to make sure. And if you can reduce the external load, that's a wonderful situation. So what should happen in any region, whether it's a Canada or in Bangalore, we should allow the water to move, flow in an interconnected system. Second is we should treat the wastewater, and only treated wastewater should go to the thing. I have no problem in treated wastewater getting into the lake, but unfortunately all this lethargy in treatment and inefficient system, we see that untreated sewage is getting in. That's where the eutrophication is happening.
I think just to add, we would not allow the source to be degraded first. That is the fundamental this one, because once you degrade it, both in terms of quantity and quality is lost. Water is not any use to this one. So that's why that multi-barrier approach that we use to protect the sources first.
Okay, any other questions? Okay, there are no questions. Thank you, Professor Murthy. Now we will move to the next presentation by Nikolov, okay, from Russia. And before we start the next presentation, the students are from ISBR have joined us today. So I welcome you all to this forum, and I want you to take part in the deliberation actively. This is not a place to sit and eat groundnut and chat, and I was so disappointed when I saw some of you doing that. This is a place where discipline is required. This is a premier institution. You have got an opportunity to enter the campus today. Please do not misuse that opportunity. And if you want to shine in your life, this is the organization where you can shine. So please keep this in mind. I have come to your institution. When I came to your institution, I kept IISC flag there, and I maintained the discipline. You have come here, please maintain the ISBR this one, decorum here. So however this one, I don't, the three of you, I am really pointing it out, and I want you to behave properly. Okay? Please do not make me to make this statement again. I know the young age, you want to chat and kill time, but this is not the place for such youngsters to come and kill their time and my time. Okay? Sure. Sorry. Yeah, now it will be. So, Professor Pilar, Nikolai, so you can share the slides. Yes. You click on, yeah, wonderful, it is visible. Can you put it on the projection mode?
This is my slide.
Yes, yes.
This is not my.
Go to slideshow mode. There's a slideshow on the top panel. Okay, yeah, wonderful.
This is not mine. I don't understand what is this.
It's not working. Okay. So don't worry. I think we can see the slides. So go to the first slide and start. Okay.
Okay, I can start.
Yeah.
Greetings from Karelin, dear colleagues. Greetings from Karelin Research Center from Petrozavodsk, Russia. I present Karelin Research Center. We are working 7 institutes and about 700 engineer and scientists work. Outlines of my presentation. Do you see my presentation now?
Just a minute. There is a slight the transmission problem is there. We are rectifying that.
Outlines of my presentation. Briefly about Northern Water Problem Institute, water resources and their use in Russia, distribution of lakes on the territory, water quality and water quality shortly, some main modern problems of Russian lakes, eutrophication, land species, water pollution and new actors, microplastic, fish farming, anthropogenic and climatic changes, impact, estimation of possible nutrient loading and water supply. The Russian Federation, with an area of about 17 million square kilometers, is situated just a moment. In the Arctic, subarctic, temperate, and partly in the subtropical climatic zones of the northern part of Eurasia, included around of 12 seas of the basin and 3 oceans. Size and geographical position of Russia explains the great variety of water bodies and their dependence from climate. Russia is very rich by waters. Total volume is 26,500 cubic kilometer of water, and renewable water resources about 4,270 cubic kilometers. And on this picture you can see main research center of investigation of water resources in Russia. In the north part, I represent north part, and the south part in the Rostov, in Baikal, in Novosibirsk, and far east of our country. Of water resources in Russia, rather complicated situation on the south of part of Russian Federation with waters. Strongly uneven distribution of water resources in Russian territory. Water scarcity exists on the south and central region of European part of Russia. As a result, only 8% of the renewable water is in areas with 80% of population and industry of Russian Federation. Seasonal uneven distribution of river runoff, availability of transboundary water with 18 countries, strong differentiation of subjects of the Federation in terms of economic development and investment potential. On this picture, you can see changes of water runoff change and average value of Russia from 2007 till now, 2020. You can see only fluctuation. But dynamic of wastewater discharge into surface water bodies decrease about 40% till 10 years. Look in our some years. Let's remember some lesson of 20th century and beginning of this century. And what happened in the fast degradation of ecosystem of numerous lakes in Eurasia, Africa and North America due to human influence and natural factors. There are Aral Sea, Balkhash Lake, Sevan Lake in Eurasia, and numerous lakes and reservoirs. Lake Aral, this is a dramatical situation for the 30 years. You can see in the 70s and nowadays only a few basins instead of this lake. At the bottom in many places look like desert. Water level decreased dramatically. It connected with water withdrawal for the irrigation and climatic warming during the last 30 years. Sevan Lake, situated in Armenia, in the mountain lake, ecosystem changes when water level drops 8 meters for the hydropower station. Process of anthropogenic eutrophication and water pollution has begun. In order to stop this process of water quality deterioration, it is necessary to increase water level on 6 meters up, as shown in results of 3D modeling and measuring. I worked on this lake many years ago. Balkhash Lake in Kazakhstan, it's a former Soviet Union territory. Anthropogenic changes are due to irrigation. There is a strong degradation of ecosystem of Balkhash Lake and salinization of eastern part. Baikal, this is the biggest lake in the world. And since 1960s, Lake Baikal became a reservoir. A rise conflicting demands of different users of various resources of like this hydropower, energetic, drinking and industrial water supply, transportation, and tourism. About 1 million tourists visited Lake Baikal per year, and lots of dirties, and it's problem with water treatment system, and alga blooms on a littoral zone, and spirogyra. It's a problem in the Baikal. Caspian Sea, huge biological gas, oil, and other resources, and watershed is about 3 million square kilometers, and serious problem with forecasting of water level fluctuation, which does not allow economic activities. Modern state with lakes of the world. 2 years ago, it was published a paper with 40 scientists, Jenny et al. And science is the title of this publication, Scientists Warming to Humanity, Rapid Degradation of World's Largest Lake. Main reason is climate warming and increased pressure to the ecosystem with population growth and also water management problem and climate changes. Russian lakes. In Russia, about 2.8 million lakes, and very rich region in northwest where I work, and rather poor region with lakes in the south, Lake Baikal, and very rich region in the north part, but not so many population here. Northwest parts of Russia, a region of water where incident water problem responsibility, Lake Ladoga, Onega, this is the largest lake of Europe. Lake Ladoga is comparable with Lake Ontario and White Sea that's connected with Arctic region. This is Lake Ladoga, largest lake of Europe. It's a dimensional of a lake. It's comparable with Lake Ontario, I told about it. And these lakes, Ladoga and Onega, are tremendous reservoirs of high quality potable water, which is a great value of northwest part of Russia. Lake Ladoga is a singular, non-alternative source of drinking water supply for the St. Petersburg region and some cities of Republic of Karelia. Lake Ladoga and Onega, importance of drinking water supply for Republic of Karelia and some other regions. On this picture, you can see main points, sources, anthropogenic loading, especially of industrial centers, pulp and mill industry, some enterprises situated in Lake Onega and Lake Ladoga. And another is a resource of water pollution. Main current problems, nutrient loading from industrial centers around lakes and eutrophication problem. Absence of modern treatment wastewater, not enough wastewater and some settlements at shore and at lakes. Alien species, microplastic, fish farming activities, climatic warming. Lake Ladoga ecosystem dynamic, you can see here, from 70s it was clear water oligotrophic status, but nowadays it's oligotrophic, but in some bays, in some littoral zone, it's weakly mesotrophic. This is loading of phosphorus and nitrogen to the lake. It's decreased dramatically for 30 years from 7,000 tons of phosphorus per year. Nowadays, about 2-3 loading. This lake, Onega, a dimension of lake. Lake is second lake in Europe. It's rather big. Areas of water surface about 10 square kilometers, 10,000. And Lake Onega dynamic. In the 70s, 80s was oligotrophic, but in the 80s, it's still meso in some places, mesotrophic in some places, especially in some bays. Presently, the average phosphorus concentration is 8-10 microgram per liter. Lake Onega is oligotrophic, but some bays in initial phase of eutrophication for example, Kondopoga Bay in the north part of lake. Due to fish farming activities, climatic changes, unlike Lake Ladoga, Lake Onega has semi-closed base in which considerable amounts of allochtonic organic matters enters the with sewage, water, and river discharge. As a result, together with intensive phytoplankton growth, bacterioplankton development very rapidly. The bacterioplankton decompose allochthonous organics and release mineralization phosphorus. This intensifies the phytoplankton growth, and hence the rate of eutrophication in lake increase. This is the main reason of slow restoration of water ecosystem to oligotrophic status. Another problem, anthropogenic influence of large lakes, Ladoga and Onega, by invasions. About 90 years ago, from Baikal, with feed fish amphipoda were transported to the upper Volga, is several thousand kilometers. But from upper Volga, amphipoda to put to Lake Onega and Ladoga. This is a ways, these are main pathways of species invasion to Onega Lake and to Ladoga Lake from different basins were associated with human activities. This is a Baltic Sea connected with Lake Ladoga, Onega, and Caspian by channel, and with White Sea, Arctic. This is a lot of transportation here. This is a reason of pathways of invasion. Modern important anthropogenic action in Lake Ladoga, Onega, and other lakes, freshwater in Karelia. This is White Sea, Ladoga, and Onega. And lots of enterprises with producing trouts farm. Karelia occupied only 1% of territory of Russian Federation, but produce 80% of trouts. And nutrient loading from trout farms and displacement in endangered species or by invasion species are serious factor change the lake ecosystem. Climatic changes. On this picture, you can see higher temperature on several points around Lake Ladoga and Onega. You can see strong trends increasing of air temperature for the last 30 years. From average temperature 2 centigrades per year, now about 4. It's serious influence to the water ecosystem, to the warming of waters of lakes of the territory. The present of positive trend you can see here. The warming has not been uniform in time and space. Analysis of seasonal air temperature shows positive and negative trends, and only spring temperature have stable positive trends. This is a seasonal variability of air temperature in the around of Lake Ladoga and Onega. You can see increased temperature in winter time. It is important to the influence to the water ecosystem. Surface water temperature in Lake Ladoga and Onega increase. You can see a visible trend of the territory. It influences to the water ecosystem. There are water level fluctuations, Lake Ladoga and Onega. You can see this is natural Lake Onega, water level regulated by hydropower station from in the end of 50s, in 1950. You can see at Lake Ladoga and Onega. You can see some trend. This is natural fluctuation and Lake Onega. On this picture, you can see water level fluctuation in Lake Ladoga and Onega. Lake Baikal. Lake Baikal, it was built hydropower station in the end of 50s, and water level regulated Lake Baikal, and water level fluctuation of Caspian Sea, situated on the south of our country. You can see dramatically dropped level in the 70s, and unpredictable water level fluctuation of Caspian Sea. Economical situation, it's rather complicated connected with water level fluctuation, because it depends in unpredictable water level fluctuation. You can see, if you compare this picture, no common modes in water level fluctuation, absent synchronicity. no clear global signal in the water level. Regional climate changes and watershed play important role to the hydrological regime. On this picture, we compare water level fluctuation of Great Lakes of America and Eurasia. This is Eurasian, Lake Baikal, Lake Onega, Lake Ladoga, and Caspian Sea. In the same scale, American Great Lakes, Superior, Ontario area, and no visible signal, no synchronicity in water level fluctuation. Very important regional aspects, regional climate. And the climate warming, noted with mild winters, an increase in the number of thaws, wet precipitation in winter time, and strong rains contribute in watering of soil and leaching on humus. You can see total iron, total phosphorus, and CO2. Its influence to the water ecosystem very strong to the biota of the lake. Special distribution of microplastics. Last several years we investigate microplastic in Lake Onega and Ladoga. High microplastic contamination in Lake Onega indicates a large rate accumulation in this freshwater body, comparing with Baltic Sea. On the Baltic Sea lives about a million people, not so strong, but problem connected with not very strong water exchange, and incomparable with even higher than abundant water bodies in some areas in China and India. On this picture, you can see estimation of microplastic in Lake Ladoga at the bottom. The highest content of microplastic was observed near the urban areas, industrial areas, pulp mill industries. The size range of the particles is about 60 or 5,000. The most abundant size fraction microplastic was about this one. Results: Onega and Ladoga Lake now retain its lithotrophic or weak mesotrophic status from 1991. Under climate warming, noted mild winters or decrease of the number of thaws, wet precipitation in winter, its increase humus, a significant increase of some base watercolor, content of suspended matter, iron, phosphorus, and concentration of carbon dioxide for the last 3 decades, and water brownification of the lake, and microplastic increase. This process can lead to the water quality changes and habitat of biota in water sediments. Modeling of possible changes, estimation of possible changes for the ecosystem. It was developed several 3D-dimensional model. For example, about the model developed together with the Institute of St. Petersburg Institute of Economic Mathematics. This is a scheme of this model. This is a three-dimensional mathematical model of the hydrodynamics, developing this together with colleagues from Institute of Mathematics from St. Petersburg. On this picture, you can see mean perennial Lake Onega water mass transport temperature for the period of 1950, 1999, and future possible temperature. These are scenarios, Max Planck modeling. You can see a strong increasing of RMS temperature. This is a 3D ecosystem model, includes aggregated biomass, phytoplankton, zooplankton, minerals, phosphorus, nitrogen, and so on. You can see on this picture. And these results of modeling, they show some changes connected with increasing of phosphorus input and with climate warming. And results of the modeling at 1991, 2012. The main important conclusion of numerical experiments lies in the fact that K factor which determines the state of lakes Ladoga Onega is level of anthropogenic loading. The Lake Ladoga retained to weak anisotrophic status, and this comes from performing numerical experiment. The anthropogenic load should be limited to 4,000 tons phosphorus per year in Lake Ladoga, and 800 tons phosphorus per year, and 15,000 tons nitrogen per year, not more. It should be, now it's sometimes more. Unfortunately, this kind of development models had obvious weakness. There's an atmospheric forcing weakness with ice model, and exchange with bottom sediments were not taken into account in the model. And last years, we developed new model for reproduction of ecosystem changes under possible climate warming and anthropogenic load. You can see the scheme of this model, and we use model it applied before for the Baltic Sea, developed in Stockholm University together with Russians. Alex Savchuk take part in the development of this model for Lake Onega and Lake Ladoga. In contrast of previous models, these 3D models describes nutrient dynamics both in water body and bottom sediments. You can find publications here. I included many here. Some results. This is calibration of the model with about temperature. This is estimated annual river runoff and full external inputs of total nitrogen and phosphorus. On this picture, you can see simulated long-term annual primary production. It's produced, and we compare with data with observation. Its model reproduced very good. On this picture, you can see balance of phosphorus and nitrogen in Lake Onega ecosystem during 1985 2015, and it's exchange with atmosphere and loading from rivers, from watershed territory, and with sediments. And the very important result to the decision maker and to the development of decision maker system. And the numerical experience shows that the model can use the projection of biochemical cycles that could occur in a ecosystem of large stratified lakes under climate changes and human impact. A comparison with available information from Lake Onega and other lake or boreal lakes, that is enhanced is possible enough to be used as a form of reanalysis, look like atmospheric analysis. This model will be used as a form included to this decision support system. We developed now a decision support system, and we use now the Baltic Nest system, the decision support system, because we use the same ecological model, and we apply, we develop model for the watershed territory. It will include together the joint system. This is a water management strategy scenario, recommend lake model, ecosystem, watershed model, result of modeling, and recommendation to the decision making. Now you can find some publication about it. In the last 5 years, we have developed cognitive models for the social, ecological, economic system of water body and watershed territory. The idea of creating cognitive models is to try to transfer the methods of human thinking to the construction of models in the specific subject area. In this approach, we can use application method of the theory of fusion logic. You find publications are there. And you can find our publication about it. And on this picture, you can see schema's cognitive model for social ecological system for the region, for the OWLE. It included 5 submodels: water ecosystem, agriculture, forestry, economy, and socio-economic system. It's our publication. And it was applied to methods for fusion logic, linguistics, and cognitive model, and natural natures. In Russia, more than 2 million lakes, and studied much less than 1%. The important problem is to estimate water and biological resources and study unstudied or poor studied lakes. It was applied methods of fusion logic, linguistic, and cognitive models. For estimation of resources of lake, it was applied theory of artificial intelligence method based on the database and data knowledge. You can find this publication. On this picture, you can see some publication about our investigations, like Vladik Onega published in Springer, and another one in the Encyclopedia of Lake and Reservoirs. You can find our publication here. The author expressed gratitude to organizer to the invitation part of this symposium, Lake 2022. Thank you very much for invitation, and I hope our cooperation. Thank you. Are you hearing me, dear colleagues?
Yeah, thank you.
Hello.
Thank you, Professor Nikolai. Any questions?
Hello.
Any question from audience? Thank you, Professor Nikolai. So, any
Thank you.
question from the audience? Okay, looks like everyone has understood your presentation. Thank you very
Thank
much. So, Professor Murthy, you want to have any comments? We have 5 minutes, you can do that.
Thank you, Nikolai.
Thank you, Raj, for invitation. Thank you for your help.
Okay, we'll see you.
I'm very glad to see you, to hear you.
Okay, we'll keep in touch. Okay, bye.
Bye.
Okay, you have one more opportunity to ask a question if there is a question, otherwise we have, yes. Yeah. Yes, go on.
Hello sir, could you elaborate how eutrophication is caused by fish farming activities?
Okay, you know the, I will answer. Fish farming, this one involves addition of nutrients. You know, you have to feed the organism the nutrient, so that nutrient get leached into the water body. That's how the eutrophication happens. Eutrophication is the excess accumulation of the nutrient. So this aquaculture or the fish or anything has that side effects also.
Okay, sir.
That
Thank
means
you.
the right dosage you have to give. And see, normally when you do the aquaculture, the best option is to have a barrier of plants, so that you know when it passes through the plants, the nutrients are uptaken by the plants, so that the water doesn't get contaminated. That's where earlier, if you look at, we had riparian vegetation along the river course in the buffer zone. You know, when the water moves from the catchment towards the river, you know, all the nutrient from the catchment, you know, would have taken by the plants, so that river never used to get polluted. But unfortunately today we are cutting the vegetation in the name of development, and we are concretizing the thing. So, and we invite Chinese Prime Minister to enjoy the day there. Okay. So those are the things we are doing which are unscientific. Okay. So I have been telling the government both at the state as well as the center to stop such this one. But anyway, that involves concretization, involves a lot of money expenditure, and people want money to be spent. Then only GDP goes up. Their GDP also goes up, the nation's GDP also goes up.
Yeah, see, another problem is we can control the nutrients, phosphates and nitrates from point sources. Point sources, I mean big sewage treatment plants from cities. You remember the wastewater? Because the wastewater contains lots of nutrients, phosphates and nitrates, because you use the detergents, you know, these detergents that you use in household, this one. So we have technology to control those nutrients, because we have introduced this phosphate free detergents available in the market. But the land-based activities, because all around the Greats there is a lot of agricultural land, they use fertilizers. That non-point sources we cannot control. You understand what I mean? Of course, in what Dr. Ramachandra once mentioned, we can't do those plantation along the lake because they're all built up area.
Well, but in India, still that buffer zones are there. You know, we can still do it. That's what I am trying to see that happens in Bangalore. In some other lake, I am trying to do that. Okay. See, surrounding the last year, about a year or 15 months back, NGT came up with a thing saying buffer zone, there should not be any construction activities. That means even if you are a owner of that buffer zone, you are not permitted to construct, but you can do the cultivation. So that's a good sign. Okay. So we are suggesting them to go for the agroforestry where less external inputs are involved. Okay. So and in Bangalore, some of the lakes we have been successful in doing that. Okay. So any other question from this side? Okay. Thank you all. So what we will do is we will take a break. So now today we are ahead of our time. So 10:25, 10:30 we are supposed to wind up the session. So see, that's how people from other part of the country, other part of the globe maintain the time. We Indians have to learn. When we come to the forum like this, if we maintain time as well as the discipline, we can do the job. Okay. So now what we'll do is we'll take a break for about 20 minutes. The tea is arranged on the back side. You can go and have tea and come back to the auditorium latest by 10:52. Okay. So you all have to come back to the auditorium by 10:52. Okay. Where's our Karthik? He was here. Karthik ಎಲ್ಲಿ? Yeah, good morning, Dr. Mayama. Hello, please unmute and yeah, hello. Yeah, this session is on aquatic ecosystems, and Dr. Karthik will be chairing. Karthik, can you, and Asulabha, you can sit there, okay? So, careful, you have pulled it back too much. Okay, Professor Mayama, you know, you have taken diatom to school, whereas we have taken lakes itself to the school. Here I have students who work on lakes, water quality, algae, then zooplankton, fish, and we have the about 60 youngsters from schools taking active part in the symposium, and today they are doing the presentation. And also we have about 150 graduate students from various institutions in Bangalore. They have come here to learn. So they are looking forward for your presentation so that they can take this idea forward and they can work on the lakes in the neighborhood. Okay. So now with this I request Karthik to say a few words and start the session. Yes, Karthik.
Yes. Very good morning to all. I welcome all to this session, and in this session we have total 5 talks. The first will be by Professor Segiki Mayama from Tokyo Gakkai University, and then subsequently we have 4 talks on 4 different organisms in aquatic ecosystems. So with the short introduction, we will give the this session to Professor Mayama. Professor Mayama is a Professor Emeritus at Tokyo Gakkai University. He works on half of his time he works on diatom, taxonomy and ecology, and rest of his training teachers for environmental related activities. Professor Mayama have developed a online free program called Simulated River, and which helps school students to understand how our today activities changes the riverine environment with help of diatoms. And this program is available almost around 20 language, and it's freely available for school students. And I with Mayama we have developed for 4 Indian languages. So with this introduction I will leave this session to Professor Mayama.
Okay. Can you show my slide, Karthik?
Yeah.
Okay. Oh, thank you very much, Dr. Karthik, for your invitation to this symposium and introduction. So I'm very happy to have a chance to talk about my educational efforts in this session. Well, so first I'm talking about diatoms, very short. So diatoms is one of the most diversely evolved microorganisms living in aquatic ecology, aquatic environment. And there are 30,000 species which are already described. Well, just one moment. Well, and then diatoms live every aquatic environment. So lakes, pond, river, and ocean, Antarctic, Arctic, and high mountains, hypersaline waters, acidic lake, alkaline lake, and polluted waters. So the biomass of diatoms are so huge, then 20 to 25% of global photosynthesis is carried by diatoms. So diatoms generate oxygen every day and also absorbs carbon dioxide too. And diatoms is known as a good bioindicator for water quality assessment. And then in many countries, people use diatoms as a bioindicator for water management. Well, so diatoms can be classified into three types of pollution tolerance. And this is sensitive diatoms. Sensitive diatoms can occur only in clean waters. And however, most tolerant diatoms can even occur heavily polluted waters. And there are a third group, moderately tolerant diatoms. This shows the intermediate nature between sensitive and most tolerant species. So I show one example for the changing the abundance of three diatoms groups due to changes in river water quality. Well, this vertical axis, horizontal axis mean river length. So this is very short river, only 11 kilometer length. So this area is uppermost stream located in low mountain area. And this is lower stream located in urban area. So there are many houses. So this blue line is sensitive diatoms. So in upstream, the sensitive diatoms dominant. However, it decreases the abundance due to inflow of sewage. Contrary, moderately tolerant diatom and most tolerant diatoms step-by-step increase. And in this point, because of much amount of inflow of main sewage water, moderately tolerant and sensitive diatom decrease very much. Contrary, the most tolerant species occur. Yeah. So now I'm talking about river water pollution. This is a river. Yeah. Which river do you know? Or which country do you guess? This is not India. Not China. This is Japan, but not present. 1960s in the past. So this river is named Tama River, running through in Tokyo area. This is a video from Tama rivers. In this era, the surface of Tama River was covered with much amount of detergent forms. So sometimes this thickness become over 1 meter height, very huge amount. And in this era, Tama River smells so bad. And people called this river dead river or ill river. The reason of pollution is abrupt urbanization in this era, in this river basins. People built many buildings for residents. Yeah. And also in this era, people began to use electric washing machine. From this machine, many detergent thrown into the river, and Tama River became very polluted. And in this era, many organisms did not disappear. Well, these photographs are taken from the same era. So not only Also, other local cities have are suffered from water pollutions. But this is a present Tama rivers. We have overcome such a severe environmental condition by a variety of efforts. Yeah, it looks very clean. However, in the past time, many countries, which were called today developed country, suffered from water pollution. So this is the United States, and this is German river, and this is Canadian river. And this picture was drawn in 19th centuries in England. This time, this era, England have early development of industry. So much amount of sewage flow into River Thames, and Thames River die. Well, so look around the world river today. So this is Brazilian river, China, Philippines, Thailand, Malaysia, and India. This river flowing from Lake Bassa. So it's this river have much amount of detergent foam. So it looks like very similar as past Japanese river. Well, so as you watched, the history of water pollution in river is repeated in the world. So my question was whether the items could be used to foster the student mind to improve the river environment worldwide. I have a research career for more than 40 years, maybe near 50 years. During this period, I had many diatom samples from various degree of water pollution rivers. So using this, I thought to develop a simulator using diatoms for students. So I and my colleague made SimRiver. SimRiver is educational online simulator for understanding the relationship between human activity, water quality, and diatom community. Using SimRiver, students can manipulate various parameters in river basin, such as land use, human population, year season, and sewage treatment plants. Based on the environmental parameters selected, diatom species community are produced. Students evaluate these species communities quantitatively and qualitatively to measure water quality. Environmental variables can be adjusted, producing a new simulated species community. So this is a SimRiver. So we can create environment along this river from upstream to downstream. So let's run. Now I'm creating environment around the river and choose season and collect sample. This time, so upon it, I collected the diatom samples. And now SimRiver generating the diatom community. And I identify diatoms to make a species table for calculating saprobic index. Yeah. In this point, saprobic index is 1.43. Oh, very good condition. And then we move to another place to collect another samples. So go to down. Yeah, generating diatoms appearance is very different from previous diatom communities. And generally, diatom identification is very difficult for beginners. However, SimRiver has some assisted program for to make identification easy. So even beginner, they can identify the items so easily. Now I collected another samples. Well, so go to middle stream and to collect the items. Well, yeah, it looks like very different. And then make worksheet. And the last station, yeah, the item community looks very different again. And the subrobic index are very different from upstream to downstreams. Index 4 is the maximum, so this area is heavily polluted. And this bar chart showing the ratio of three diatom groups. This blue is sensitive diatom group, and the yellow is moderately tolerant group, and red is most tolerant diatoms. Well, so advantage. Simulation have some advantages. A student can experiment with matters that do not exist there, spatially or time-wise, and verify a hypothesis in a short time. And student examine repeatedly till finding the rule or tendency of the causal relationship. And the student learn the inquiry process efficiently. So inquiry process is one of the most important knowledge or competency in science. Well, so we started SimRiver project in 2001 with some colleagues. And the SimRiver simulator has been revised every year based on user feedback. So we have many collaborators from 22 countries. And then the latest version of SimRiver is supported in 22 languages. SimRiver is completely free. Everybody can use it anytime if they have a internet connection. And SimRiver has a link in Diatom project website with other online modules for learning river environment. So we have first class activity in 2002, 20 years ago. At that time, a teacher tell to students, so please set up your own river basin environment with SimRiver for understanding the relationship between the environmental disturbance and its resultant water quality. After the lesson, students back their feedback. Oh, this is their feedback. Well, it was good experience for me to create my own environment. Learning like a game was easy and fun. I felt the class time was shorter than usual. I think school would be more fun if there were more classes like this. Yes, their feedbacks are so positive. But descriptions about the lesson purpose were not so much. So, this pie chart shows almost 0.5% of students only described about software or device. They do not describe about lesson purpose. This was our story. So we need some improvement in our lesson. So we introduce group work. So we make students discuss for hypothesis formation before simulation. And after simulation, students share their result simulation. And also, teacher had some other instructions. So please examine the ratio of 3 categories of diatom species which are different with pollution tolerance. And please examine the species diversity change according to pollution levels. So teachers' question become much more practical. And we also introduce new learning material, that is worksheet, for filling in hypotheses and results. So after this introduction, student feedback become much more better. So many students were interested in the relationship between anthropogenic impact and water quality via diatom communities. Well, so then we try to expand our project to the world. So for this purpose, we made a web page named Diatom Project, available in 25 languages. In this Diatom Project web page, we include SimRiver and 3 videos introducing diatoms, and many river photographs showing polluted rivers around the world, and a report system. So using this educational module, we have a lesson in 6 language groups in 5 Asian countries, namely Japan, Korea, Thailand, Indonesia, and 2 schools from India. Before and after class activity, teacher asked the same question: what thought do you have about river today? And the student showed their descriptive answer, and we had 803 answer. And then so we made text mining, and then we searched what language, what word were how often used in student sentence. And then we conduct correspondence analysis. Well, this is the diagrammatic summary of the analysis. This arrow shows the shift of student awareness from before lesson to after. Well, and this red means Japanese, gray is Korean, and the yellow is Thai student. And these 3 student awareness directed to the improvement of environment after lesson. However, these 3 students, so Kannada class in India and Marathi class in India and the Indonesian student, their awareness after the lesson directed only diatom and SimRiver. They do not describe about improvement of environment. So I assume why. Yeah, maybe different. This time, so I didn't visit each countries. I just showed the rough lesson instruction for teachers. Well, so maybe in each country, teacher have their own instructions. Maybe this is the most reason, I think so. However, so we need some improvement in lesson plan and learning material. So we introduced 2 things in the website. One is river video showing pollution, and second one is diatom specimens. Of course, it is impossible to upload real specimen. So we took photographs from the specimen, and then we upload these photographs. So using this material, we have a lesson in 5 language group in 3 countries, namely America and India, 3 language classes, and Japan. Yeah, this is Indian class activity. Well, so in this cross activity, we used past collection, past diatom sample and the present diatom samples. And in each country, we collected diatoms from the same rivers. Well, so for Indian students, first, we show two Indian, first, we show these two photographs without saying which is past or present. And we ask students to make similar diatom community using same river. And students began to manipulate environmental factor setting to get the virtual community similar to the real community. And at last, students find the lower photographs is present rivers diatoms. And students can know, could know in the past, Indian river was clean. And then, so we show Japanese diatom photographs. And soon, students can understand and surprised because in the past time, Japanese river was so polluted like current Indian rivers because diatoms is very similar. And Indian students know present Japanese river are clean. This is very similar to Indian past river. This finding encouraged Indian students to make action, to take action for river restoration. Well, then for the Japanese student, we show these two photographs, and then ask the same thing as Indian student. Well, anyway, before and after the class activity, this time, so we visit every school. Yeah, I ask, what thoughts do you have about river today? Before and after class activity. Well, and then make a correspondence analysis. These three arrows indicate the shift of Indian students, English school, Kannada school, and Marathi school. Their awareness shift is very similar. Before the lesson, their awareness concentrated into daily life concerning rivers. However, after lesson, their awareness directed into improving river water quality based on comparison between the environmental history of the rivers in India and other countries. So what are Japanese? Well, before the lesson, their awareness concentrated to conceptual image of rivers. And after the lesson, their awareness directed into understanding the current status of Indian rivers and need for improvement. So this is original descriptive answer. So left is written by Indian students. So there are many houses along the nearby river, and the residents threw garbage into the river. But Japanese and Americans are conscious of not doing so. Dumping garbage into rivers affects the organisms that live in the river. we should also create a clean and rich natural environment. When I go home, I will tell my parents not to throw rubbish into the river. While Japanese students answered something different. I could learn about the polluted environment in developing countries. I think it is necessary to improve the river water quality. Technology development and assistance are needed. Developing countries need to raise awareness about the river environment. Well, Japanese student response are less concrete and realistic than those of Indian students and do not lead to action on their own. Well, the lesson brought the expected result to the Indian student, but left problems to be solved for Japanese students. United Nations established 17 goals of sustainable development. Goal 6 is clean water and sanitation. And the United Nations emphasize the necessity of global cooperations. Our project fit with their goal, and the Indian student is okay. However, Japanese students' awareness is not so well fit with the achieving process of the goal. So we need some improvement. So this scheme is lesson scheme used the previous activities, previous lesson. And we have 4 improvement. Yeah, therefore, in this year, so we had 3 classes in 3 schools. And then using this new lesson scheme, we have activities. And now we are analyzing their feedbacks. But tentative result I get now, and it shows very good achievement even in Japanese students. Especially the 4th one, exchange of student opinions among 3 schools via Zoom. This is very effective. This activity resulted in promotion of student motivation to act for river restoration. So now I'm thinking next year. So I want to have this student exchange activity between Japanese and Indian school students. Well, so I'd like to introduce my project members. Dr. Kato, Omori, Seino, Osaki, Satomi, so from Japan, and Dr. Ari. He lives in now Japan, but originally he's from Chunye. And Matthew and American, Lee and Chen from Korea, Lobo from Brazil, Nina from Denmark, Athena from Greece, Angel from Poland, Latanapon, Putwumpon from Thailand, Regina from Germany, Somei from Iran, Jonathan from South Africa, Maximus Elena from Russia, Paul from Canada, Gao from China, Elena from Ukraine, Boze from Nigeria, Luke from Luxembourg, Turi from Indonesia, and 4 Indian colleagues, Karthik, Alkananda, Spriya, Lakina. So they give us a very great contribution. Well, and Junet from Turkey, Yako from New Zealand, Edward from Philippines. Well, so lastly, I can say diatoms foster the student minds of the river cleaning and global collaboration. Thank you very much.
Thank you, Mayama-san. The session is open for discussion. Maybe we can have a couple of questions. Any questions? Yeah.
How were the schools selected, or was there any kind of advertisement or this thing?
So, Mayama-san, the question is like,
Yeah.
how are the schools are selected?
Were they next to the river, or some kind of criteria was put?
How are the schools selected? Any criteria for selection, whether the schools are located next to a river?
But Japan or India, which?
In India.
I have no idea to select schools. So Dr. Karthik introduced me the school.
So I will answer that question. So schools
Yeah.
which are in our network. So we selected those schools. Yeah. No. Any other question? Yes, please.
Thank you so much, Mr. Mayama, for the wonderful presentation of yours. My question is in regards to will the diatom communities will also help out with potassium and nitrate minerals getting increase in the water bodies other than helping out with BOD?
Dr. Karthik, so the quality of voice is not so good. So please repeat again
I'll
our question.
repeat. No problem, I'll repeat. So my question is, will diatom community technique will also help out with controlling potassium and nitrate problems in the water bodies other than helping out with BOD problem?
So her question is whether diatoms can help in reducing
Potassium and nitrate
potassium
minerals.
and nitrate level in the river condition.
Yes, sir.
So of course, diatom is algae, and to grow algae, they need some nutrition. So they can absorb nitrogen and phosphorus. However, especially they do not have such an ability to purify water quality. Yeah.
Thank you so
I
much.
try to answer this. There is something called phycoremediation. We use algae for doing the remediation of the water. Okay. Now, second thing, when you look at the natural water bodies or even the lakes, there are pollution tolerant species. You know, diatoms which are tolerant to that, they will come there. Why they are there? Because the nutrients are there. So when they are there, they will take up some nutrient, but we are overloading this N and P so much, you know, still we will have the eutrophication. Okay. But if you want in a controlled environment, if you try it, there are some species on Isia, etc., that does the job of this one. They take away the nutrient. Okay. So that's where you should look at the species which have what kind of affinity they have. You know, there are some species, if carbon is high, they will come there. If N is high, then they will thrive there. That is the thing. Where when you design the phycoremediation experiment, you can choose the species and do that. Okay. But in the nature does a wonderful job as long as we don't cross the carrying capacity of the ecosystem.
Thank you, sir. Thank you.
Yeah.
Thank you, Mayama Sensei.
Yeah.
So we'll move on to the next speaker. But you are welcome
Okay.
to stay and listen to the next speaker.
Yeah. So I enjoy this symposium. Yeah.
Thank you.
Yeah.
So I invite our next speaker, Dr. Mihir Kulkarni, to introduce us with the copy ports. Thanks.
Am I audible? Okay. Am I audible? Yeah, great. Thank you and for this wonderful opportunity to present some of this work. Okay. Is there some issue? Yeah. Cool. Yeah. Okay. Thanks. So thank you for giving me this opportunity to present some of the work which I do on something called temporary water. So it's a very different kind of ecosystem from lakes and rivers which we have been discussing about in this wonderful symposium. And I would like to introduce this habitat type and try to sort of share the amount of diversity which these habitats hold. So we know that freshwater ecosystems are extremely diverse, and although they cover a very small portion of the Earth's surface, they do hold a very high amount of its diversity. And it has also been seen in, especially in case of many vertebrate species, that there have been very high declines in their numbers over the past 5 decades or so. So this also highlights that freshwater ecosystems themselves are quite threatened with lots of climate change or even lots of human activities. Now I'll come to a group of organisms which is not so commonly studied. It remains much understudied, and these are the invertebrates. So very common examples of invertebrates include insects, which most of us are aware of. So other than insects, we do have so many different groups of invertebrate organisms which inhabit a lot of different freshwater bodies, and I guess in this session we are going to hear talks about many of these different groups of organisms. So my work mainly relates with two groups, that is the crustaceans and the insects. So crustaceans are relatives of crabs and lobsters, but much smaller animals which occur in different freshwater habitats, and mostly microscopic ones. Second ones are insects, which are not so microscopic, but you still can have very high diversity in these groups. So although these invertebrate groups are, we know that they have a tremendous diversity, and in most of the freshwater habitats they are not very well studied. Also, many of these invertebrate groups are very important for functioning of ecosystems, be it a river, a lake, or even a small pool. So you see that this is a very typical food web of a pond, and you see that most of the secondary and tertiary consumers are invertebrates. So if these basically highlight that these taxa are quite important for the functioning of this whole food web to be smooth, and it should be healthy basically. Despite this importance, invertebrates are quite understudied on a global scale. So this basically just shows you as a comparison with fish, which is one of the very important taxa which is quite well studied. You have very less number of studies on many invertebrate groups, and one of the main reasons, main sort of fallouts of this is that we have very less knowledge about the baseline taxonomic and distribution data from many regions across the world about most of these invertebrate groups, and this can have a very direct influence on how we plan conservation measures. Now, while invertebrates themselves as a group of animals are understudied, so are temporary water bodies. So you have way more studies happening on lakes and rivers, obviously because they have a much stronger connection with human life, but we have very less studies on temporary habitats such as ponds and pools. So in my talk I am going to sort of bring your attention slightly to this habitat type, which itself is understudied, and look at invertebrates in this particular habitat type. So, temporary waters are standing waters, or they can even be flowing waters like streams, but the main feature of this type of habitat is that they are characterized by a cyclical dry phase. So, the habitat dries up periodically during its particular say a particular year. So, this dry phase is actually defining feature of these temporary habitats, and this is something which is very unique about this entire ecosystem type. You have very different types of habitats which can be temporary. They can be pools or ponds, and there can be even streams which are seasonal. So, this seasonality is quite important, and you find such habitats across the world. So, that is another very useful thing where you can actually have studies on comparable ecosystems across the world. So, to get a better understanding of how these ecosystems are structured. Ecologically speaking, one of the most important features of these habitats, like we said, is the cyclical dry phase. So, this is sort of technically called as hydro regime. This sort of relates to the duration and frequency of this wetting and drying cycles. So, this is actually the same temporary pool which I have photographed slightly from different angles in 2 seasons. And this is a seasonal pool. It holds water for around 4 months of a year. So, during monsoon it fills up and it immediately dries up around October. So, this type of cyclicity in the environment is actually the main driver for the communities of organisms which inhabit this environment. It is a defining sort of feature of the habitat. And in addition to this frequency, you have certain physical characters of the habitat like substratum or area. So, by substratum I mean what is the substrate on which that pool is formed. So, here you can see that it is sort of formed in soil, but you can have pools formed in a rock substratum which are called rock pools, or you can have something like streams which have silt as a substratum. So, this can also directly affect how long the water stays in this habitat, and that itself is one of the main sort of features. Additionally, you have the chemistry of the water which keeps changing very frequently due to the conditions which keep fluctuating. So, since these habitats are quite shallow, most of them are less than a meter deep. So, any fluctuations in temperature can very quickly lead to changes in the water temperature. You can also have very fast changes in other parameters like salinity of the water, and all these constitute the very dynamic environment of these habitats. Now, when I basically looked at some of the aspects of diversity of these habitats in the Western Ghats. So, this is one of the typical landscape in Western Ghats where you have small pools forming on the top of the mountain ridge, and I basically looked at some groups of crustaceans and insects in these habitats to understand the diversity of these habitats. So, the most important thing here is that you have these pools occurring across space. So, you have this kind of situation. So, this is a satellite view of one of the study sites, and all these red circles are individual pools which are forming there. So, you see that the pools can form and they have very like classic sort of spatial structure, that is, you have some pools which are close by, some of them are more scattered in space, and so on. And this type of spatial structure also has a strong sort of influence on what kind of organisms and what communities exist in these habitats, in addition to the time, that is the temporal factions which we have seen due to the cyclical environment. The communities in this sort of habitat can be broadly classified into 2 sort of groups of organisms. One is the resident or passive dispersers. So, these organisms, they stay in the pond, they grow there and they die in the same pond, but they cannot actively move from one pond to the other. So, these are passive dispersers. So, they need some sort of vector for, that is sort of vehicle which will transport them from one habitat to the other. So, this is a very interesting feature of some of these organisms. I will sort of try to give some names of these as well, but one of the main features of this group of organisms is the formation of resting eggs. So, since the ponds, we know that they dry up and the organisms, they need water to survive, how do they actually manage it? So, once the pond fills up, these eggs which they form, these are present in the sediment at the bottom of the ponds, and these eggs, they hatch out and they give rise to the community of organisms which mature, produce another batch of eggs, lay it in the sediment, and then they die as the pond dries up. So this is one of the very crucial adaptations which you see in these taxa or passive dispersers, for which enables them to survive in these habitats. And this also makes the communities of passive dispersers in temporary habitats extremely unique. So you often have species which occur in single sites in the Western Ghats and not anywhere else. So that is actually one of the most sort of valuable component of the diversity in these habitats. So this is how the vectors can move the eggs of the animals from one pond to the other, and they can establish their community in other ponds. The other group of animals are the insects. So they are active, they are capable of active flight, as we generally know. So they can actually colonize a pool or pond from outside, and they can actually move from between pools on their own. So this is another way in which the communities can be structured over space. So for example, if you have two pools which are very close to each other, eggs of the passive dispersers can easily move into the next pool, right? So you might have similar communities in both pools as compared to pools which are very far apart. So this kind of mechanisms actually structure their communities, and all of them are centered along the sort of dynamic environment of these habitats. So these are some of the key taxa which you find in some of these pools. So these are all crustaceans except these two, these are insects. So these are called tadpole shrimps, and these are fairy shrimps. So all these are brachiopods, so that is a group of crustaceans. You also have something called as seed shrimps or ostracods. So these are again very microscopic crustaceans. These are copepods, and these are cladocerans. So all of these are crustaceans groups which are often microscopic, except maybe these three which you can quite easily see with your naked eyes. So and these are some examples of insects. So these are some of the typical members which you find in temporary habitats. And again, they show very important adaptations, like I mentioned, that they form the resting eggs. They have a very rapid development in order to sort of mature before the pool dries up, and so on. Now, when we looked at the copepod diversity in the Western Ghats, so I basically found that in the Western Ghats alone, and only in temporary habitats, I find roughly 40% of the known diversity of freshwater copepods in India. So in entire India. So this actually tells us that the temporary habitats are very valuable, and they actually support a much sort of high diversity than we normally appreciate. We don't appreciate the value of these habitats much. Most of these copepod species were range restricted, that is, they occurred in very specific regions in the Western Ghats. Some of them were also new species which we are still describing, and they also have very diverse biogeographic origins, that is, they have different affinities from the historical biogeography perspective. So this is sort of a very broad comparison between number of species of copepods found in different habitat types. So you see that although streams and rivers and reservoirs, they are quite large and quite sort of more permanent in nature, you have a much higher diversity in ponds and pools which are very temporary. So this tells us that the temporary habitat themselves can be important reserves for biodiversity. And this bottom graph shows us the hydro period, that is the duration of water in the habitat. You see that there is a high diversity in habitats which have water for a smaller duration. So that basically illustrates the point that you have a very important role of temporary habitats in sort of as biodiversity reserves. Now when we looked at a specific type of habitat called rock pools, so these are pools which have a rocky substratum, and here you find that on a global scale you find most of them are again arthropods, and crustacean and insects are the dominant taxa in these rock pools. They also have very different evolutionary origins. So you have these crustaceans and these insects, so they come from very different evolutionary relations. So this also sort of highlights why these habitats are valuable, because they support taxa which have very different evolutionary histories. When you look at the communities of, so I basically monitored 32 pools in the Western Ghats region over a period of 6 months or something, and we found that actually diversity shows a lot of variation. It does peak in sort of middle of the monsoons, where you see most of the taxa are highly diverse, and this 32 pools who held around 68 species only of crustaceans and insects, and this is very high when you compare it with fauna of other rock pools in other continents. Like for example, in Africa, all taxa other than arthropods, even when you are including them, you have a diversity of about 70 species. So this is only crustacean and insects in a collection of small pools. So this tells us why these pools are actually important and why we need to sort of focus on conserving these habitats. So individual pools also show a lot of variation in number of species which they can hold. So each of these bars represent a single of those 32 pools, and you can see there is a very wide variation in the number of species that a pool can hold. So this actually illustrates the fact that you cannot protect just one pool. You need to protect a landscape with multiple pools in order to sort of have a much better sort of conservation of the diversity which they hold. Now, when you look at these rocky outcrops which are characterizing the northern Western Ghats, you see that there are different types of outcrops. So you have high level, low level, and as well as basalt outcrops, and you see that the communities of different groups actually differ among these outcrops as well. So not all rock pools have the same type of organisms. So the organisms also themselves differ when you go from different geological outcrops. So same case with the large brachiopods, where you have very different communities, but it is not so not entirely true for some groups like cladocerans, where you have more species which are common across habitat types. So that again tells us that there can be differences in geological regions where you find these temporary habitats. How can you use all this information for conservation? So one very straightforward way is to sort of use species richness, that is how many species are present in a given habitat, and try to map it on the geographical sort of landscape. So here then you basically get to understand which areas have a higher species richness, and maybe you could sort of prioritize that area for conservation. Second aspect is you could use characteristics like biogeographic affinity or range, and you can actually use it to develop indices which sort of talk about conservation value. So for example, if one species is occurring across this entire landscape, the conservation value which that species will add will be less as compared to a species which occurs only in say 3 habitats here. So the rarer the species and you find it in a pond, it makes the value of that pond much higher. So it's sort of a counterintuitive sort of way. You can also, one of the main reasons for choosing this habitat type here is that we don't have any appreciation of these habitats. We have all gone on treks to very nice places like Savandurga, which is near Bangalore, and you have seen the temporary ponds occurring there, right? But we immediately, we don't think that there's much in that, but you actually have a large diversity in those habitats. So in Mediterranean regions, such temporary ponds are legally protected, but we do not have any sort of such system in India. We don't even have a basic idea of the diversity which they hold, so which makes studies on these habitats important. And like I mentioned, you need to include landscape level approaches for conservation instead of focusing on single pools, because actually all pools are connected through dispersal of different organisms between them. Now I'll just end with a short note that like this session is also has an important focus of using biomonitoring, using these taxa for biomonitoring. But can you use such small invertebrates for biomonitoring? So we have just heard how diatoms are an excellent model for this, and so are some of these crustaceans. So this need to move beyond using just abiotic parameters to understand the health of ecosystems can be supplemented with the studies on such smaller invertebrate groups, especially which are at the basal levels of the trophic pyramids. And you can actually integrate data on some of these traits and use it. So just as an example, this is data on a lake which was sort of rejuvenated. It was an urban lake, quite shallow. And what we found that when we looked at the cladoceran community, which was small crustaceans, we found that this is the community before they did the restoration, and this is the one which they did after it. Now you see that the number of species itself has reduced a lot, right? And cladocerans, as we have seen, they are important as the primary consumers. So this sort of situation could also be one of the causes which can lead to lot of algal blooms. There's no top-down control on it. There's no one eating the algae, which is getting produced by added nutrients. We also looked at what sort of ecosystem functions were lost. So this basically all these boxes tell us about different functions which these cladocerans perform, and this is before they did the whatever manipulations to the lake. And you see that there are so many different functions which have been performed by these cladocerans, and this is after that where you see only 3. So there are 3 major functions or groups of organisms which perform these functions. They were lost during this. So in some sense you can use these organisms to also assess how effective the sort of mitigation was to that particular habitat. And again, like all other aquatic habitats, we do have lots of threats which are faced by these temporary habitats, which include large scale destruction like mining. You also have dumping of lots of garbage and so on, and you also have conversion of landscapes. So entire landscapes are converted into, say, from a barren landscape to a plateau or a plantation. So these kind of things can have strong effects on these systems in addition to climate change. But the most important thing remains is the lack of awareness of their value. So I thank you all for your attention, and I thank the organizers for giving me this opportunity, and I will be happy to take any questions if there are. Thank you.
Now I'll take that question first. Yes, please. You.
Hi sir, I really enjoyed your presentation because I recently studied something about copepods.
Oh.
So my question is that if I'm not wrong, they can reproduce sexually as well as asexually.
Yes.
And it is decided by a signaling mechanism. So does that mechanism has any link or relation with the defining factors which make them perpetuate in these temporary waters?
Yeah. So basically copepods again is a very big group. There are different orders of copepods, and not all of them can reproduce by both ways. So the ones which I was talking about, they are like solely reproducing by sexual reproduction. And in temporary habitats you do have other taxa which can reproduce by both sexual and asexual ways. Cladocerans are one good example of that. And yes, so these switch between sexual and asexual reproduction usually happens by environmental cues, which is mostly related to salinity and temperature of the water. But yeah, we can maybe discuss about this later on. So I think if that's fine. Sure. Yes.
Do they come in this category?
Columbolans are actually a different group, so they are not the crustaceans, but yeah, so I actually have not studied columbolans per se.
No, but are they important for restoration or monitoring, pollution monitoring? Because they are red colored small worms.
Those are I think chironomids which you are seeing, red colored. Yeah. So chironomids are actually one of the indicators which are commonly used for presence of anoxic conditions. So the red color is like pigments which you find them in anoxic conditions, but yeah, you can definitely use them. Thank you.
I will stop here. People will be available for during the lunchtime
I'm here.
discuss because we are running out of time. I request Dr. TVR to felicitate Vijay for his wonderful talk. I request Vidya for our next talk on this session.
Well, thank you very much, Dr. Karthik and Dr. Ramachandra sir, for inviting me over here. Yeah. Thank you very much, everybody. So today I am going to talk about how two different rivers can be compared in terms of ecology. So this talk is about comparison between a free-flowing river and a dammed river. Let us understand how fish communities differ in these two river basins. So river ecology, so to speak, in India is emerging field, since last 4 to 5 years, and we lack substantial amount of data in terms of understanding how freshwater fishes respond to different anthropogenic activities. So what I am doing here is to compare Agnashini, which is free flowing river in Western Ghats, and comparing that with the Sharavati, which is a dammed river. As you perhaps know, during over the period of 2 days, that how important are our river systems, especially the freshwater ecosystems. We do have different dimensions of dams in the upstream areas. In the morning we heard that how headwaters region is an extremely important when it comes to the connectivity. What happens when the dams is in the upstream areas? You know, it have a different implications on the aquatic biota. The connectivity is depicted in this picture, plays an important role not just for the aquatic but also terrestrial large, you know, organisms like wild buffaloes and rhinos and tigers and things like that. And fisheries is one of the extremely important livelihood options that we have in many developing countries. And the role of you know, freshwater ecosystems or habitat plays in terms of providing cheapest protein to the local communities as well as multiple cultural services is really important. This is the schematic or the you know, interacting threats that we know of over the globe, how freshwater ecosystems are extremely vulnerable to human activities. We have lost the free flowing rivers on the globe, like overexploitation in terms of the, you know, overexploiting in terms of the fishes or aquatic resources is one of the long lasting problems we have been facing today. Of course, when it comes to urbanization, water pollution also deteriorate the quality of habitat, flow modification in terms of the dams, habitat degradation because of the repair and removal of the vegetation, that also forms an important you know, factor when it comes to shape the aquatic communities. And of course, of late, the introduction of invasive species of fish largely also deteriorate the native flora and fauna. Over the period of time, we have also observed the frequency of drought and floods have become very infrequent in recent times. That has led to, you know, the water conflicts between inter-regions or interstate or national or international scenarios. And of course, microplastic is our, you know, is a recent activity that largely because of the urbanization. When it comes to freshwater fishes, the remarkable report that came into 2021 or 2021 was found that more than 76% of the freshwater large migratory fishes, which basically more than 3 kg in length, weight, have diminished since 70s. And critically, more than 90% of mega fishes have been lost, largely because of the human activities. And this curves basically tells you the large number of freshwater fishes have diminished to a very you know, smaller proportion of the body sizes till date. And this bending curve needs to be you know, acknowledged, needs to be studied very well in order to take better conservation measures. So coming to the Western Ghats, we have been able to document more than 400 or approximately 400 species of freshwater fishes till date. And every year we do document new species in different pockets of the Western Ghats. So the Western Ghats biodiversity hotspots is also hotspots of the dams, also hotspots of the human density. And that has led to, you know, diminish the aquatic habitat more often than any time before. Let us take an example of free flowing river. This is the concept that was formulated by Ward and Stanford in '83, that they talked about the importance of free flowing river is nothing but river continuum concept, originally given by Vanot, aquatic biologists. So headwater plays an important role in the connectivity, and it brings the large amount of sediment flux and nutrients from the headwaters all the way to estuaries. On the evolutionary time scale, if you look at, it churns the different kinds of stream substratum from the headwaters all the way till estuary. And over the period of time, multiple organisms have been shaped because of the stream flow. And stream flow plays an important role as a part of a connectivity. Take one other examples. When a dam comes in the headwater region, what happens? It creates basically a couple of sequences, multiple consequences. The large amount of nutrient flux and water quality changes before the dam and immediately below the dam. The connectivity diminish the aquatic biota, dispersal of aquatic biota both upstream and downstreams. So the kind of impoundment that you have because of the dam changes the water chemistry drastically. And as soon as if you see below the dam, the connectivity disconnect between the pools and riffles. The headwater, the connectivity, what we have is runs, riffles are the free flowing habitat of the streams. And what you see here, the disconnected pools. This diminishes the dispersal or migration of many aquatic organisms. This is an example from a PhD. I compared 4 river basins in the Western Ghats, and the remarkable result that you can see from this figure is nothing but the dammed river basins had relatively lesser number of species composition in terms of the fish, whereas the undammed basins, they were Tunga and Bhadra in Kudremukh National Park, had a substantial like 34% of the endemic species were restricted towards the free flowing rivers. Why? Because of the habitat speciality. The run, riffles, the free flowing river stretches were able to harbor the very habitat specialist and endemic species that you don't see any longer in the dammed river basins, largely because of the human perturbation has modified the dammed basins. There were a couple of endemics that could find a refuge between these two river basins only in the headwater streams. What happens in the Malaprabha and Mahadi headwater, there was a interbasin river channel was being developed by the state government of Karnataka, and I tried to understand the impact of this interbasin transfer on the fish communities. What I found, the endemic and habitat specialists found in the headwaters were lost in that channel as compared to the Tunga and Bhadra in the similar stream orders and elevations, so to speak. So this tells us how and why important it is for us to conserve the free flowing river stretches in the country. When I looked at how water quality changes with respect to the different types of functional gills, here what we understand, surface dwellers are the fishes with the they have affinity to higher dissolved oxygens. They are found in the surface because of their morphometry. Mid columns are found in the middle column of the water, whereas the bottom dwellers are on the bottom. So substantially the surface dwelling richness of the fishes were higher relatively than in the non-regulated, that is Tunga and Bhadra, or free flowing rivers as compared to the regulated rivers. And so is the case with others. The bottom dweller community was highest in the regulated because of their adaptation over a period of time. The certain generalist species are very much adapted to the modified river quality. So you have most of the VD species dominating the modified river basins. And this is the remarkable results to compare how we have been doing how human activities have been affected to the river systems. Another remarkable study in the Central Western Ghats, where colleagues have identified different stream orders between dammed and undammed. And again, they show the similar results. What you see in the undammed river stream orders, of the 5th stream order, the species richness of the fishes are remarkably high. So is the composition. And this is again illustrated in another figure, where they found the dewater stretches, the community composition was largely affected due to the dams. So this is my study area. I compared Agnashini and Sharavati rivers in terms of their functional gills of fishes. I followed the typical sampling protocol of using traditional method called carcinating of different mesh sizes, and I measured the water quality and stream habitat variables to understand how freshwater fishes are responding to different abiotic factors. This is a documented comparison by previous lake symposium researchers, but they have looked at how important is the Agnashini, which is a free flowing river. And by simpler facts, you can compare how Agnashini is extremely productive and rich in terms of their fish biodiversity. Mind you, I haven't presented any data about the river birds, mollusks, or so-called invertebrates. They are relatively less understood. So dams have diminished the quality and quantity of fishes below the downstreams. So a lot of freshwater and marine and estuarine fishes do not have ability to migrate upstream because of these large structures. And we don't have any quantified basis in which we can understand how flow ecology relationship with respect to fishes is understood. So to give you a couple of objectives in this talk, wanted to understand and assess the fish diversity between Agnashini and Sharavati, and then try to document the relative responses of key fish gills. Gills are nothing but the group of organisms sharing the equitable resources. Here in this case, I will focus on a couple of gills to illustrate my objectives. So broadly speaking, 75 species we've documented on the whole in the 2 river basins, and of which 21 orders and 37 families were documented. And again, because of the free flowing nature and habitat that Agnashini gives, we have documented 62 species alone in the Agnashini as compared to 47 in the Sharavati. And there are a couple of gills like Rheophilic, which is a flow dependent gills, fishes which have affinity or evolved themselves to migrate with respect to flow, are called flow dependent or flow dependent gill. There are 3 different types of subgills called Rheophilic is flow dependent. Then Eurotopic is another. Eurotopic is basically fishes that have an ability to found in the stagnant water, and Limnophilic are the fishes which have affinity to move from stagnant to flow dependent habitats. Clearly we showed the distinction between how fish diversity, especially in the richness and abundance, vary between the regulated and unregulated river, which is Agnashini and Sharavati. What you can see, the species richness is quite high in non-regulated river, which is Agnashini as compared to the Sharavati, and so is the case in terms of the numerical abundance. However, there were 5 top dominant species that differ between 2 river systems. In Agnashini and Sharavati, this Ambasis ambasis, a common species, were dominated in all the habitats, whereas the species relative abundance was differ substantially in the Sharavati basins in terms of their 5 top fishes. When you looked at the richness in different types of habitat, mind you, I told the importance of the pool, run, riffles. So when I looked at the sequence of habitat in a river segment, what I found was pool run habitat gave the highest number of species diversity in terms of richness in terms of these habitat types. When I compared the water quality, again there were difference between regulated and non-regulated rivers. The average water temperature was quite higher in non-regulated, which is Agnashini, and in terms of salinity, dissolved oxygen and pH also relatively differ between these 2 rivers. So the distinction here I would want to make is that the abiotic variables such as water chemistry plays an important role in defining and shaping the fish communities. This is another guild like foraging guild, or we can call it as feeding guild, where I looked at the richness of different types of subguilds, that fishes which only feeds on other fishes or mollusks. So they are called carnivorous guild, and this I gathered based on the literature that was available in India, and I subcategorized them and looked at how well they represented in 2 river basins. What you can see is carnivore guild is very well represented in Agnashini as compared to Sharavati, and this pattern relatively follow for others guild also. So water position column guild, the highest was found in Sharavati. Surface dweller community was maximum Sharavati as compared to Agnashini. and so is the case with bottom dweller and mid column dwellers. So flow dependent category, I was talking about the fishes which show highest affinity to the flow, where here they are found in the rheophilic, and this tells us that the importance of the connectivity between habitats. So coming to end of this talk, so we know that freshwater habitats are extremely important, and it is for us to initiate some conservation measures to protect these free flowing stretches of the river. Fortunately, we have very few free flowing river stretches left in the country. No, a typical example of Agnashini, and it is for us, we need to really come forward to understand the ecological relationship of different taxa of these free flowing river systems, so that we can formulate some conservation actions. Clearly, we show that water chemistry regulates the the differences between different aquatic organisms, and key fish gills play an important role in terms of understanding how not just the richness but also the composition matters, and once we have the data on composition, we will be able to allocate our conservation implications in that manner. And as I was saying, that efforts needs to be restore some of the hydrologically modified river basin in order to understand how biological relationship can be established very well. So besides this, declaring the conservation reserve or biological heritage of the Agnashini river, that has been Dr. Ramachandra's pioneering idea since many years. Now it is for us to consolidate all this ecological information together and convince the government to come up with the better solutions. And with this, I would like to just acknowledge my colleagues from A-Tree who have led this project and helped me complete this project. Of course, Dr. Ramachandra has been a very well mentor and very long encouraging support at IISC. In 2008, I was invited to give a talk based on my master's work, and here I would conclude with my postdoctoral kind of a researchers here. And of course, Dr. Karthik Balasubramaniam has been a very good colleague and support. Thanks for invitation, and I would like to thanks with my other JRF, Mr. Aditya and Prashant, who collected the precious data, and of course the CS field stations at Kumta, including Vishnu and Vaman and Shankar really helped, and of course Dr. Subhash Chandran, who has been a guiding support at the Kumta field station. Thank you so much. Thanks, Vidya. One quick question. Yes.
It's a very appreciable presentation, especially regarding the kind of freshwater fishes in the rivers which have high degree of endemism. So the endemism part could have been little more highlighted, I felt.
Right.
And endemism in Sharavati, you have seen the downstream,
right,
not the upstream.
Correct.
But whether downstream or upstream, the catchment area vegetation has certain impact
True.
on the kind of fishes, the shading, the endemism in the tree vegetation. If what we find in Sharavati catchment upper is that when different streams are analyzed for fishery, the streams which are draining forest with high endemism in trees have high endemism in fishes.
Right.
So whereas the streams which are coming through common forest and acacia or teak plantations, they have the poorest endemism. There are fishes,
yes,
but they are common to India. So this is one factor if you can be inbuilt and inbuilt,
yes,
and one more analysis are done, we may get more valuable data also.
Certainly.
Yes.
We published this in Current Science.
Yes, sir.
Srikanth's paper.
Yes.
So I think at the time you are doing masters.
Yes. So I appreciate your question, sir. Thank you so much. So the reason that we couldn't sample upstream streams, largely because of the permission issue, we were not been able to get the permission on time. So we were end up sampling the stream stretches downstream of that. But I really like the idea, and once we have this ability to sample some more head streams, and the comparison would be aptly suitable. Thank you, sir. Yeah. Thanks. Yeah. Thank you so much. Thank you, sir. Thank you so much.
He was in earlier lake here. As a student.
Next.
Hi, am I audible?
Yes.
Okay, nice. Yeah. Okay. So students, previous sessions and discussions we heard from Dr. Ramachandra that some species do have tolerance to some nutrients. That is one point. Dr. Atkore told about species invasion. Specifically, he mentioned about fish invasion. I will be speaking about freshwater mollusk invasion. Then Dr. Mihir told about that there are some species we need some vectors to transport from one place to another, like one pool to another. They cannot travel. So that is one more point, and I think one more point is about there are some changes happens from Professor's Mayama slides. If you can remember, when the polluted water and clean water, you see different types of diatoms. So change in environment, change in species diversity. All of us things we will see in species invasion, and I would like to focus these things. So what are invasive species? If anyone has ever heard of invasive species from UG and PG students? No? Yes? Like hands up. Okay. Okay. So invasive species, these are the species, they are introduced from a new climate to another introduced regions, and they do establish, they do reproduce, and they have adverse effects on biodiversity, ecosystem services, or economy, or they spread diseases. So this is a meme: feral cats, lizards, rodents, native birds, amphibians, snakes, everyone are scared of feral cats because they are known as like one of the highly invaded invasive species, and recently Poland has officially declared that feral cats are invasive. So coming to our mollusk, I will give you one example, though there are 28 species I have included in my study. So this article says about Physalia acuta, which is also known as pond snails or bladder snails. So this is freshwater invasive mollusk, Physalia acuta. What it does accumulates. It accumulates heavy metals in water systems like zinc, copper, and lead, such heavy metals in water. So you see the water quality has been changed by the particular species. This invasive species, Physalia acuta. Now do we have in India? Yes, last year in November, I guess, the Hindu, December 2021, who had an article on Physalia acuta, highly invasive Physalia acuta found in Kerala. Where in Kerala? It was found in Edapalli Canal in Kochi. Anyone from Kochi, they can go and check for this particular species, and this is how it looks. So it also, there are also people they use as an aquarium because it's easily available. You can just get it and put in an aquarium also. It doesn't die so easily. So Physalia acuta. So I think there is a group of researchers from CUSAT, Cochin University of Science and Technology, I suppose. They studied that, they found that this species is also found in India, in Kerala, and they carry some specific worms, some specific bacteria which can cause skin diseases, which can cause some other human diseases. So here we are seeing, there in the first article we saw that it can just destroy, it can decline the water quality, but here it can cause disease. So at a single time, one species can have all 4 impacts on biodiversity, on health, and on economy as well as ecosystem services. So where does it belong from? I mean, from where it came? Faisal acuta. Any guesses? Any continent, country names? Any more? I just heard South America. Anything else? Okay. This is from North America. This is from North America, and it has been introduced in Europe, in Africa, in Asia. Since we are from India, I focused on that. We have also this particular species. So how do they spread? I mean, there has to be something. We cannot imagine that some little snail can travel across Atlantic or Pacific or through Suez Canal and coming to Kerala, right? It is not possible. We do need visa, but they don't need. So there are pathways. Like Dr. Mihir earlier told, there are some vectors. Here also there are some vectors. What are those? Pet trade, food, research, biocontrol, and accidental. So pet trade means you want to get one species as you want to keeping them as a pet. Like we see African grey, some birds, like, I mean a parrot species which is from Africa, we see in Bangalore. There are some Indian parakeets are in Europe or Australia. So these are as an example of pet trade. Then coming to food, do you eat snails? I mean, I am sure in Kalyan Nagar there are many hotels, they serve snails and calms as a food. So that could be one more reason that you introduced exotic foods. Then one more is research. In research, we haven't studied as a model organism, but we do transport other species like Genopus for African cloud frog for developmental biology. So that is one more reason we do transport these species. And biocontrol. Biocontrol is the best example I would like to give you. This common Indian myna. Every other day we do see. In 18th century, it got introduced in Australia. Just imagine 200 years back, they introduced to control insect population, and now it became invasive. So these are the different reasons we do introduce this species, but one more reason, that is accidental or unintentional. We don't intend to introduce, like most of the times it happens in case of invertebrates. Like who does want small snails for a pet or just to eat? I mean, it doesn't make sense more. So what I found in case of all invasive freshwater mollusks, so 45%, like as expected, 45% are introduction of accidental introductions. However, 37% belong to pet trade. That is quite surprising, because apple snails also you can see in aquariums, that is Pomacea, so that is also one of those invasive snails. And followed by food 9%, and research 5%, and biocontrol 4%. There are very less example where one snail has been introduced to control other snails and both became invasives later on. Now next, so introduction happened, can we track them? Where it can be else, like we know that Faisal acuta has come from let's say North America to India, and just also it introduced in 1909 in Kerala. Can it travel from Kerala to Karnataka, then Karnataka to Telangana and all over India? Can we track them? So yes, we can track them using species distribution models. This is predictive models techniques. Just want to explain how does it work. You have data collections. So first phase is you get data, species occurrence data or distribution data, where it is located, coordinates, longitudes, latitudes. Then you have environmental GIS maps. I mean environmental, let's say you have LULC maps, you have temperature maps, environmental maps, annual mean temperature, annual precipitations, such layers you have, those are called rastral layers. If I mean for each points, let's for example for Bangalore, what is the annual precipitation, what is the annual mean temperature. So for each data point, each coordinate, you get such those environmental values, variables, or they are also known as environmental predictors. Then we have algorithms, statistical algorithms. There are many algorithms, GLM, then maximum entropy, and genetic algorithm, GARP, and DIVA GIS. So there are many, and ensemble modeling. Recently also people are working on deep learning techniques, new techniques. Using those algorithms, you come up with spatial predictions. So you have data points, occurrence data, distribution data, you have layers. Raster layers means your PNG file, like JPEG, your photograph. You have small pixels. When you zoom in too much, you can see pixels, right? So those are raster layers, and the pixel is known as grids or resolutions. So the higher resolution, you get generally better results. For each grids, you have coordinate points, and according to coordinate points, you get environmental values. Use those data into algorithms. There are softwares, tools, and you get your outputs, spatial predictions. So what we found of our study in invasive freshwater mollusk. So I have mentioned their current scenario. So what I will say that we have considered it for now, what is happening, and in future, in end of 21st century, with respect to climate change. I will show in the next slides what are those two scenarios in climate change also. So what we found in current scenario, there you can see figure legend 0, 1 to 5, 5 to 10, and up to 25. So 0 means there would be no species of this particular invasive freshwater mollusk in that blue regions. These are the areas. There are highly less chance you get any species, and subsequently the red part, like in France you get, in east coast of US, then southern where Brazil and Argentina border, there you get red colors. So those are called hotspots of invasions. So there you are likely to have 20 to 25 of invasive freshwater mollusk. It doesn't necessarily mean that they are present, but those areas are vulnerable or susceptible to your 20 to 25 invasive freshwater mollusk. So if someone wants to work on invasive mollusk, and where you should focus your areas, so these are your primary areas. You should go for particular these localities. Next, coming to climate change, we have two scenarios. So one is written over the top one is SSP 1 2.6 and SSP 5 8.5. Just I'm making it very clear, don't go with the technical names. So first one is when this is under IPCC, the climate change scenarios. The first one is saying about when we follow sustainable growth, everyone is following, and the second is we are not going on sustainable, we are still going with the fueled, I mean biofueled commissions, like everything whatever is going, like you burning coals and going with the same economy. So what will happen? So there could be two options, where one you can go for solar energy, more sustainable with, I mean you are concerned about climate change. Another, you don't care about anything and you just go ahead whatever we have been traditionally doing it. So what happens? The distribution to based on climate change. As I said, when environmental changes, the species diversity also changes. It affects. So you can see in the up there are 21 species, but in down there are 16 to 18 species. So despite of higher carbon emissions, we get less number of species per unit area. But if you compare with the blue shaded, which is 0, you can clearly see that there are more blue regions in SSP 1 2.6 rather than in 8.5. That shows that if we are concerned about climate change and we are following more sustainable methods, then there are less area in overall are likely to be affected by the invasive mollusk, freshwater mollusk, compared to when there is we are not concerning and we are going with fossil fueled developments. So here the hotspots remains quite same in case of 2.6 scenario, but in case of 8.5 we see somewhere here in Africa, Central Africa. So that could be one of the reasons, because I found, I am not sure whether it has been proved, but my assumptions from this is because most of the population density also lies near that, and the upcoming development areas also are coming up in those areas in Africa. And so these are the changes you see from current scenario to future scenario, where it can invade, or what are the, how the distribution has been changed over the years. So what we got from the work is most of the invasive species, especially mollusk, freshwater mollusk, are introduction of accidental, followed by pet trade like aquarium trade, and species distribution models can help us predict where it can travel further now as well as in future, and what are those hotspots like Florida, east coast of the US, Western Europe, France we got, and the south coast, that Argentina and Brazil border. These are the hotspots of freshwater mollusk invasion. I would like to thank my A-Tree and my supervisor Dr. Arvind, and my fellow lab mates Nipu and Anusri, A-Tree, and my current organization NCBS. Thank you.
Thank you, Dr. Biswa.
Just Biswa.
Okay, fine. Maybe in future it is good. So, Biswa, you have explained SDM approach, and that's very good. I have two questions. One is that which algorithm did you use for SDM?
I did maximum entropy.
Okay.
Yes.
And another question is that how did you collect the species occurrence data for the present time?
Okay. So species occurrence data can be collected from various open source database like Global Biodiversity Information Facility. It's also known as GBIF.
Yeah.
For India, there are India Biodiversity Portal. If it's a birds data, then you can go for eBird. Grey litters are also there. I mean, you can go as many as resources.
Okay. So
but mainly you will get it from iNaturalist, GBIF, and some other. I mean, it depends on specific area and geographical area. I mean. Yeah.
So you didn't go for any ground truthing?
Since this was global study, so it was highly unlikely I can do ground truthing. But one of my friends, she is working on particular one species, which is the land snail Lecatina fulica. There she is studying about, since India, she is working on ground truthing and all. Yeah.
Okay. Thank you so much.
Thanks.
Thank you. Thank you very much. Thank you. Thanks, Vishwa. I request our next speaker, Girish and Rasika. Right. Am I audible? Yeah. Good afternoon. My name is Girish, and I'll be presenting this along with my colleague Rasika, who's here. She'll join in a bit. And we'll be talking about a collaborative project that had started in 2019 and is soon coming to a close. And we were from A-Tree. I am still with A-Tree. And our partner was is WWF. The idea was that A-Tree being the research partner, we take a river system and try to understand what the condition of the river is. And WWF being the implementing agency with a much larger ground presence, they can approach a policymaker or the community there to see what can be done about improving the condition of the river. We didn't end up choosing just one river because we chose the Noyal Bhavani Basin in Tamil Nadu because WWF had a significant presence there, and within the basin there are 3 rivers, all of which are sub-basins of the larger Kaveri river,
and it's a very interesting system because yeah, this is the for I go into each of the rivers, this is basically the entire basin. So on top you can see the Moyar river, and below that there is the Bhavani river, and then comes the Noyal river. Now you can see that there is other division that we have made. There is upper Bhavani, middle, lower, etc., which we've just done for our convenience, and also looking at a change in catchment area in these zones. But otherwise, river system. To give you an idea, upper Bhavani is roughly where Ooty town would be, and where Moyar joins Bhavani, there's a reservoir there. That's basically Satyamangalam town, and that's the Bhavani Sagar reservoir. And Noyal is basically the river that flows through Coimbatore and Tirupur. Now, this is a photo from Noyal soon after its source. So it looks fairly clean, fairly undisturbed, looks like there is a forest patch around it, and a few kilometers downstream, Coimbatore happens. Then after there is Tirupur. Tirupur is like a massive textile hub. So a lot of sort of effluence from the industries basically enter this river. So this is how the river looks after a bit. So this part is only for like a few kilometers in the beginning. For Bhavani, this is how it starts. It's mostly a forested catchment in the beginning. It looks pretty nice. Not as bad as Noyal, but then you can see a significant presence of people, of cities, a lot of farmland that's not clear from this picture. And then there's Moyar. I don't have any photograph here, but Moyar mostly flows throughout forest as its catchment. There are smaller towns like Gudalur and Masnagudi in between, but it's predominantly forest. So it's very interesting because these systems they go through a range of sort of conditions, especially Noyal, followed by Bhavani. And to understand how the condition of each of these river was, we had to have a term that was holistic in nature, that we could look at multiple parameters, and we thought river health would be a good sort of term to use. And we did some study, and this was the definition that we thought we can use for this study, which is basically a term used to arrive at the ecological integrity of the rivers, taking into consideration its biochemical, physical and hydrological parameters along with human values, which are the values placed by society on an ecosystem. And basically by that, our idea was that we'll compile a set of factors that can indicate the state of the river. And it shouldn't be uniparametric, or you just don't look at water quality or just don't look at the fish population, but a combination of factors. So it had to be multiparametric, and there should be sufficient information coming through across physical, chemical and biological conditions. And lastly, it had to be scalable. You do this study and that shouldn't be the end of it. You should be able to replicate this across other rivers, other systems, etc. And so we did some study on different river health parameters that we can use, and there are people have tried different criteria or set of criteria for this. Fairweather basically puts into 3. There is haphazard, where you just randomly choose some parameter, go and collect it based on your prejudice, based on your resources and your logistics, or a single perspective, which is what we mostly found in Indian studies, where we just look at a single parameter like water quality. The water quality is bad, you say the river health is not great, and vice versa. And the last is a synthetic approach or a multimetric approach, which is using a combination of parameters, which is what we ended up doing. And coming to the parameters that we chose for this study, first is water quality, and there is lab tested where we collected samples of the river and then tested, as well as what we observed as the quality of the river. Fish, information basically from fish, macroinvertebrates and diatoms. Dr. Vidyadhar and Dr. Mihir mentioned both fish and invertebrates in their studies, and I think Karthik sir will be mentioning it after this presentation, but we have collaborated with them for this particular study as well. And this is how we ended up choosing the sites. So on top of the Moyar, whatever is MO is Moyar, and after that there is MB, which is Middle Bhavani, LB is Lower Bhavani, and there is UN is Upper Noyal, then there is Middle Noyal. We chose study sites basically trying to cover the entire range of the river, at least the main arm of the river, without missing out on much. And now coming to each of these parameters, water quality, we followed this Indian pollution index, which was used in particularly for Indian conditions, where we used pH, TDS, EC, coliform phosphate, and dissolved oxygen. And the basic idea was that we go collect samples, get the result, and give certain values based on what you get. For example, the paper says if the pH is between, I don't know, 6.5 to 7.5, you will give 1, which is excellent. And pH between 5.5 to 6.5 or 7.5 to 8.5, you give 2. And subsequently, it goes into different conditions, from excellent to heavily polluted. And similarly, fish, we use this very popular paper of Index of Biotic Integrity by Carr, and a modification of this paper for Indian conditions. And the idea was that you give values like 1, 3 or 5 based on what value you get. And the parameters that we used were these. There were 8 of them. So to give an example, we just take Moyar system. There were 7 sites in Moyar, and we look at the number of native species for each of these sites. So you might get a range of values, like from one site you might have 10, another site will have maybe 40. So based on that range, you give a certain value for the site. And similarly, you do this for all these parameters, and in the end you will get a value. And similarly for macroinvertebrates, we used a combination of 3 papers, and we use the same 135 criteria as in Index of Biotic Integrity. And these were the parameters that we used for richness, and tolerance. And next is diatoms. Diatoms, already Dr. Mayama had spoken about this. Basically, planktons attached to substrates, and we can get a lot of information if you collect it. And once analyzed, you have to choose whatever parameter could be used for your case. So we had chosen percentage pollution tolerant diatoms, assuming that the higher the percentage of pollution tolerant diatoms, higher the chance of pollution history at that site. And again, we divide into 5 categories at the end. The last is what we observed. So in addition to water quality that we tested at the lab, when we went to a study area, we basically, for each of the site, we noted certain parameters like floating matter, eutrophication, oil sheen, odor, etc. And we tried to quantify it based on our perception. And that also we added into the mix. Now we come to the output. So we basically, what we did was, for all these sites, for 5 seasons across these 3 years, we've collected this data and we analyzed it, and we've got certain outputs which we would like to present to you, and I'll hand it over to Rasika right now.
Can you hear me? Thank you for your patience. As I was listening to the rest of the talks, I was thinking that each of the taxa with regard to freshwater systems was delved into deeply by each expert, and in some sense, it's all different cuisines, right? Now we're giving you intercontinental cuisine. So all of these taxa together, we collected information on, and we've organized it as levels of health, as he mentioned, as 1, 2, 3, 4, 5, ranging from excellent to very bad, for each taxon. This, just for your information, is the Moyar basin. This would be the Bhavani basin. MB refers to middle Bhavani sites, LB refers to lower Bhavani sites. And this is the Noyal basin. Upper Noyal is UN and middle Noyal is MN. Again, we've organized it into iconography. Just introducing the iconography here. Diatoms are that, macroinvertebrates is that insect icon, fish of course, water quality and visual parameters. The color scheme is as follows. Green is for excellent, and orange yellow is for very good, dark orange is for fair, grey is for bad, and black is for very bad. As is the case with most studies, the outcome was not straightforward or pretty. But that is the important part, that is the interesting part. I present to you the findings from the river Bhavani. So the thing is, what may seem all right in one set of parameters may not be telling the same story with regard to other sets of parameters. Which is why, although initially we were thinking about collapsing all of these parameters into a single index, we thought we're better off conserving the diversity of information by presenting what the story that each of these sets of parameters are telling us separately, which will also help us, inform us, to design interventions focused on the parameters that is performing badly or performing better than the rest of them for each site. So, for example, if I could draw your attention to LB4, everything is not so well off, right? That is a very clear picture. But on the other side of things, if you look at LB2, visually things are perfectly fine. This is the visual parameter list, right? Quality is not doing so great. Fish, the fish diversity, fish index isn't telling us a really good story. Macroinvertebrates are really bad. Diatoms, we couldn't even find enough diatoms to get proper information on diatoms. So, and on the other side of things, MB7 as well, right? Uniformly the same story. But the more interesting bits would be the ones that aren't telling you a uniform story. Here, visually all is well, the last bit. Diatoms are fair. Fish and macroinvertebrates aren't doing so well. Water quality could use some improvement. So we're trying to condense all this complex information site-wise and come up with contextual intervention design. That's where I go to. So similarly for Moyar, it's the same set of parameters. I just want to get back to the concept that all of these are intra-basin comparisons. With regard to interbasin, Moyar is pretty well off. But when we look at it within the basin, in terms of room for improvement, better forms of interventions like I mentioned before, all of these water quality wise are actually doing well by global and national standards. But within the basin, if you see MO3, that's probably the worst off. Can you tell just by the colors? Diatoms are black, macroinvertebrates are orange, fish are black, water quality is a darker orange, and visually also is not so great. MO3, as you can expect, is possibly one of the more disturbed sites. It's actually a tourism site on the river Moyar. Of course, this is not to say that tourism should not be promoted, but perhaps we can think of better ways to do tourism in these sites while talking about how much better these sites can be managed by comparing them with comparable better sites, contextually better sites within the same basin. So that's kind of the concept. Noyal presents the most interesting study because between upper Noyal and middle Noyal, like Girish had shown two photographs, just drawing your attention back to these photographs, this is the upper Noyal catchment and this is the middle Noyal catchment. So as you can see in the middle Noyal catchment, we couldn't even collect information for macroinvertebrates and fish because the water was so badly off. That is where we think about triaging and we think about prioritizing sets of parameters. So there's no question of focusing on the biodiversity for middle Noyal when it's water quality that is the most important set of parameters, right? That needs to be focused on in terms of interventions. So that's where we're at. And with regard to takeaways from this and future directions in which the study is going, the first thing is local context is extremely important for monitoring and goal setting. We cannot keep trying to compare our studies or our sites with global standards and global contexts without any context because our nutritional content that's leaching into the rivers here might be entirely different. Lohit is here from WWF who's helped us in the early parts of the study. And then also with regard to the local context, we have to set the baselines for each river and river basin, and then define the ranges of parameters in each of these parameter sets within the basin. And then over and above that, for interventions, we further arrange these parameters in order of importance and then of course design appropriate interventions. For example, like I mentioned before, for middle Noyal, in terms of the triage, the first set of parameters will be water quality. With regard to Moyar, the most important set of parameters that would need to be focused on would be the biodiversity. And then of course, we try and assign on like a shifting baseline on a scale, I will show you, how each of these sites or how much each of these sites are deviating from the best possible site within the basin. And then we try and push that the deviated sites towards the least disturbed sites by designing appropriate interventions, or shifting baselines methods, so to speak. Of course, in the future, larger scale and more fine monitoring is also possible by condensing these set of parameters into a simpler set of parameters and engaging with citizen science groups, grassroots organizations, and local communities, perhaps school-going children like you. I would have liked to do something like that when I was in school, right? And then, of course, what's also in the works is using this data for a Tamil and English language app-based citizen science monitoring tool, which is, in the works, like I said. So this is what we're trying to provide to the policymakers. For example, I'm taking Upper Noyal 2 as the least disturbed site within the Noyal Basin, and Middle Noyal 4 perhaps as the worst off site. Other sites will fall somewhere in between the scale. And then we try and think about where we should focus our interventions and design them accordingly. None of these studies would be possible without Dr. Jagdish, Dr. Karthik, Dr. Mihir here. In some sense, it's a reunion for all of us because we've been collaborating on this for all this while. Dr. Vidya, Soumya, Arun, Sanket from WWF, and as I mentioned before, Lohit is here. And the Tamil Nadu Forest Department for giving us permits and facilitating everything. And that's about it. Thank you for your patience. I'm looking forward to questions.
Thanks for the wonderful this presentation. I saw that actually the different basins, sub-basins you have marked, and you told about the different levels, quality of the fishes and those this thing. And also at last actually we were saying about how the remediation for the correction and all these things. But I never saw actually how you are correlating with the vegetation thing which is there. Why I'm saying vegetation which is there. Because why I'm saying is the habitat makes actually the species which are there. So if you also come up with actually what is the type of vegetation which is there, and of course you saw one sub-basin actually I think which is undisturbed site actually. Of course it has a very good vegetation and those things. And the one Mayar which doesn't have any more or less actually. So that is very much highest correlations actually you can see. Whether we are going to go back, how we are going to go back to that highest vegetation one, because that is what makes or breaks the many things apart from the anthropogenic pressure which is there. I think that should also be considered in this one.
True, sir, definitely. Thank you for that point. That is something that we're working on. We're trying to look at the vegetation and the buffer. But at this point, we're at least trying to characterize the buffer land cover types as forest, plantation, industrial or residential, and see how much information we can get out of that as well, and how much we can suggest in terms of intervening with regard to the buffer of the river itself. Yeah, that is something that we are exploring right now. Thank you.
Any other question?
Any more questions?
Thank you.
We started our journey in 1998. We should have come to the next symposium.
From now on.
Now the children are there in the third floor. You can also attend that.
Oh.
So they are doing a presentation. I find it very interesting.
Thank you, sir.
Thanks, Girish and Lucia. Good afternoon to everybody, and thanks to TVR and Lake team for putting us together, and a special thanks to WWF. Because of WWF we were all got together, like we started this using multiple organism based monitoring of river. So when TVR called and told me that you need to put together a team, then I don't have to do much, because I just have to tell all 5 of us that come, we will all present our data. That's it. So so we started the session with diatoms, and we end the session with diatoms. This is the team, my lab, and I thank them because they are the workforce behind all the work we do. And I also thank my institutions where I was, I'm affiliated, Agarkar Research Institute, my past institutions, and the funding agency. So with this, we'll move on. Already Mayama have given an introduction about diatoms, one of the very diverse and versatile organisms, and he showed a conservative estimation of 2 lakh, but the little bigger estimation goes to more than 20 lakh species are yet to be described. So that's the high diversity which we have in diatoms, and also they make almost 25% of oxygen, which roughly convert into every 4th breath which we take, also all other organisms. So diatoms are responsible for them. So we are not talking about some organism which are not visible, but we are talking about organisms which are very important to life. And imagine like diatoms start charging oxygen, we will not be able to afford to pay and take that oxygens. And considering the climate change, they also fix almost 20 to 25% of carbon. So it's we have to pay in double. So diatoms are used as a very unique and very reliable ecological proxy, because they always occur in high abundance and they are rich in diversity. Even when we take very polluted sites, we can get a species of something like 7, 8, and in a oligotrophic and clean sites we can get up to 60, 70 species in one sample. And they are sensitive to different environmental conditions. I don't want to elaborate more, like Mayama mentioned about clean, moderate and polluted diatoms, and they show very unique biogeographic patterns, which means the diatoms which we find in Western Ghats, we don't find them in Northeast or like other part of globe, particularly the endemic diatoms. And then their silica cell walls get preserved in the sediments, so we can also understand the past environment. I will come to that part in the later part of this talk. And because of all these characters, we use them to as a proxy to understand the past and present environmental condition. So my journey to diatom started, this boy small here, like it's me. I was very thin. This is our team. Vishnu is here, and Samir, Sudhira, Gururaj and Lakshminarayana. So this is how we start, and this is the time in 2004, almost like 18 years before, I was a student at TVR's lab, and this is my 6th lake symposium I am attending. So during this time I got introduced to this wonderful ecosystem called Myristica swamps. They are very unique in terms of environmental condition, in terms of the plant and animal community which we see there. So when we take a cross section of Western Ghats, if you look at that, this is the west side, Arabian Sea. They always, this is a schematic diagram, it's not like real. So they always occur in the mid elevation. So you have swampy conditions and these trees grows there, and they are present across the Western Ghats. So the large concentration of Myristica swamps occurs in Sendurni and close to the tip. There are good, very good swamps are here, and then intermittently there are some sporadic reports and not much is known. And then high concentration of swamps are in central Western Ghats, particularly in Shimoga and Uttara Kannada districts. And recently couple of swamps has been identified in Goa, and there is the northernmost swamps occur in the tri-junction of Karnataka, Goa and Maharashtra. And there are fossilized swamps has been recently identified from the Ratnagiri. So during the excavation we found a swamp which belongs to which got fossilized around 8 to 10,000 years ago. So the leaf impressions looks like a current Myristicaceae members family. So this is what is special in terms of adaptation? They have stilt-root nematophores, and in terms of this waters are acidic conditions. Typically the water goes from like 4.5 to up to 7. So this is how the inside swamps looks like. So we have two objectives here. What are So what are the present day diatom assemblage in the Myristica swamps, and how good they can tell about their environmental conditions. And then second objective is how diatom assemblages responded to climate change throughout the Holocene in last 11,700 years. What was the change in diatom communities? Based on that, how we can tell what was the change in the Myristica swamps in last 10,000 years. So what did we do? We went to the swamps and we collected, we looked at the various microhabitats where diatom thrives, diatom attached to stones, plants, sediments, and then also moss. So we collected all this collected diatom from these habitats, and then we also collected water chemistry parameters, and then we processed the diatom samples. We look at we count 600 individual diatom across these samples, and we try to identify anything which occurs more than 5%. We try to identify those diatom. Across the Western Ghats, we visited 28 swamps, 17 from Central Western Ghats and 10 from Southern, and then 1 from Northern Western Ghats. And altogether we had 123 diatom samples. So here I present the data in this format, like water chemistry, diatom assemblages, and diatom environmental relationship. And then we try to identify some of the indicator species which will be help us to reconstruct the past environmental condition. So in terms of water quality conditions, so we can see this Kerala swamps are still in acidic condition when compared to the Central Western Ghats swamps, just because of the all the Kerala swamps are occurring inside the protected area, where Karnataka swamps are not in protected area. They come in human influence, very human activities such as they alter the water flow, because the water above and below are used for paddy cultivation. So there is a huge change in the water chemistry. And in terms of nutrients like nitrates and phosphates, both the swamps show a very distinct condition, and they also harbors a very wide range of diatoms. So and even though they look both Central Western Ghats and Southern Western Ghats in terms of like plant composition and in terms of water quality, but they both harbors a very different set of diatoms altogether. So in Central Western Ghats we got altogether 91 diatom species, belongs to 27 genera, of which almost 44 are new to science. So that shows how unique these habitats are. And we started describing new species with, first one is, we described this a couple of years before, Germinella. We named it as Germinella chandrani, honoring Dr. M.D. Subhash Chandran for his contribution in locating these swamps. So he 30-40 years before, he went in cycle and located all these swamps, which made us very easy for us to go in a car and stop next to the swamp and collect the samples. So okay. Thanks for leaving it for us. So now that we started with one species, and now our monograph on diatoms of Myristica swamps of Western Ghats is on its way. So here we are describing almost close to 100 species. It will be a first monograph on this particular habitats. And with respect to Southern Western Ghats, we got around 64 species of diatoms, out of which like 19 are endemic only to southern Western Ghats, we didn't find, and then they are also novel species to this habitat. So when we try to see how these diatoms are related to environmental condition, we did principal component analysis to understand the water chemistry. So we found there are swamps within natural conditions, there is not much disturbance, very much away from human alteration. And then second one, these swamps are altered in terms of increased nitrate, increased pH. Swamps are supposed to be in a low pH, but here we are getting increased pH and increased phosphates value, mainly from the runoff from the agricultural field. And then finally these swamps are extremely polluted due to electrical conductivity because of human influence, such as the swamps which are on Hulikal, Asole, and these are next to roads and then next to temples. So there are huge anthropogenic pressure in this. So if at all we want to start conserving, and when we tell the forest department like conserve swamps, it is not possible for them to conserve all the swamps. We give the list, like if we give a 40 swamps, it will be very difficult for them, but we can start with these 3-4 swamps on priority, and we can move on to this and then to the next set of swamps. And in terms of diatom and environmental relationship, also we found like some of the these are increase in the pH scale, so these are extremely acidophilic to alkaline diatoms, and indicator of rich in phosphates and nitrates to dissolved oxygen, and these are the highly polluted swamps with high electrical conductivity and so on. So we need to find out some key species which can tell something, instead of we have a list of 100 species, 200 species. So we try to do find out we pulled all the data from across all the swamps, around 123 samples. So we try to find out the tolerance and optima for species in terms of pH. So we found some around 15 taxa. They are like they always they occurred in multiple sites, so we multiple data points. So we found these black dots are the optimum, and then this entire range is the tolerant. So we found some species which are indicator of pH. Likewise we did for the electrical conductivity. Why we selected pH? Because Myristica swamps are known to be alkaline as acidic conditions, so it can tell us whether they are in original condition to modified conditions. And we use electrical conductivity as a proxy to understand the human influence. Higher the electrical conductivity, higher the anthropogenic effects, like that. So we found from low conductivity indicator to the extremely high conductivity indicator. So these are the from the first part, and then now with this data sets we want to reconstruct the past condition. So for reconstructing the past condition, what we did, we took a core in the samples in the swamps. So it's around 2 meter core. Altogether we collected so using a Russian peat corer, we go and put we take out the sediments in the same sequence. So we collect the cores and then section the cores and get the carbon dating to understand the age of this cores, and then we do the geochemistry and then diatoms. So we did 8 cores and we failed at 7 cores because the amount of water flush in the Myristica swamps are extremely high. So we get sometime we get the 20 year, 30 year, 50 year old sediments in the bottom in 2 meters. So we cannot use that data because it's a extremely high energy level system. So luckily we got one core where sediments are 80 centimeter sediments in a sequential order. So that sediments we use to understand the grain size, and based on the grain size we find out they are like only these swamps are only this particular swamp it's called Sastanada swamp in Sindurni Wildlife Sanctuary. So only this swamp have sequence data set. So based on this we could identify this is a low, based on the grain size we can tell whether it's a high energy or low energy or moderate energy sites. So based on this grain size we could conclude that it's a low to moderate energy sites. That's why there is not much biodegradation to change in the sequence. And then we looked into the diatoms in this sediments. If you recollect, I have mentioned about diatoms are made up of silica. The dead cell diatom cells get deposited, so we can extract diatom from the sediments, and based on the diatom composition we can reconstruct the environmental condition. So this bottommost one correspond to around 4,800, 4,700 and 2,200 years. This is carbon date, C14 dated. So based on, so in these samples we found these many diatoms. Based on the diatom we could reconstruct the earlier around 4,000 years ago. It was a dry and arid condition was there for some time, and then intermittent wet condition, and then subsequently followed by the less rainfall and strong acidic condition. Based on this we conclude that, like, the acidic nature is the outcome of last 2,000-2,500 year process in these swamps. In terms of biodiversity, we found a lot of diatoms in the core, but the modern diatom and the past diatom, there is a huge almost more than 50% change in the diatom community structures were there. So we cannot categorize these diatoms as only Myristica swamp diatom. We found that 50% turnover was in the species, and we also found something, we don't know whether it is good news or bad news. Some of the diatom which occurred 4,000, 5,000 years ago in the swamps, they are not occurring today in many in any of the swamps. For example, this particular species, it's a Decusophycus. So this diatom is not even, it's not there in anywhere in Western Ghats. The nearest one we found is in Meghalaya. So we don't know what made, but these were very abundant in the past in Myristica swamps. We don't know the reason what made them to go extinct. So, and then the finally, oops, did I do something?
The HDMI cable is
Okay, came, yes, just one more slide then. So, and also there is a, there are some more studies in Myristica swamps or associated environment on identifying the diatom. There is an increasing trend of cosmopolitan. This could be a real cosmopolitan species increasing in this habitat, or it could be also a result of force fitting taxonomy. So when you don't have idea about the taxonomy, so you forcefully fit. So but it gives the idea that it gives the impression there is an increase in generalist, which is not true. So with this I conclude saying that if you can read, thank your if you can read, thank your teacher. If you can breathe, thank diatom. Here I would like to thank two teachers, Dr. TVRAMACHANDRA for mentoring me for all these years, and another one teacher, I think he is somewhere here, somewhere in the other hall, Mr. M.A. Khan. So he is the one inspired to go to schools all the time. Thank you. I am ready for the questions. Yes.
Thank you, Dr. Karthik. I have a small question. What was the rate of sedimentation of the core which you selected where there was no reversal of dates?
So it ranged from almost 2 to 12 mm per year, like.
Okay.
Kind.
From the base? Like
Yeah.
what was on the base?
So it varies based
Yes.
on the rainfall conditions.
Yeah.
Rate of sedimentation varies. There is no standard, like some year, like in arid condition, the sedimentation rate was very low.
Lower.
Where there was a high rainfall conditions, the sedimentation was very high.
Okay. Yes, it is in zones. So
Yeah.
it ranges from, like, the base would be having a lower sedimentation rate, and as we go towards the recent time, it will increase depending on the precipitation conditions. Yeah. Thank you. Thank you so much.
Yes.
I'm interested in finding this thing. How old the swamps may be? Your cores are not more than 4,000 years? Or?
Yeah, so we try to go as deep as possible. So the maximum depth we could go is like 1.5 meter. There is a lot of this roots and the sediments is really thick. So we need to go for a mechanized coring. And forest department didn't give us permission to take any mechanized. So maximum we could do is like the peat corer.
Because
but it is more than 4,000.
Yeah, the implication is that the diatom coring, if it goes more down, it is likely you may get unravel a picture of Western Ghats ecological history.
Yes.
From even drifting from Madagascar and all those ancestry.
Yes.
So, but it will be very exciting. Except you, it will be difficult for anyone to track this.
Sure.
So I hope you get a more deep going course and come out with more fascinating things in future. And diatoms are also the oldest what you can unravel from such a depth because of the silica shells and preserved through millions of years.
Sure.
Like that.
Yes.
Okay. Wish you all the best.
Yes.
Okay, thank you, Karthik.
Thank you, sir. Sir, I will summarize this session, and I need to thank my speakers. So, I thank Vidya, Mihir, Bhushan, Girish, Rasika, and Mayama. So, when TVR mentioned about this session, so these are the 5 people came to my mind, and they all accepted, and it was wonderful to have all these 5 topics in one session. Maybe I think it's one of the rarest event which can happen in India, and it happened today. From diatom to fish, mollusk, and study by Girish and Rasika, and combining everything and make a sensible results for the managers. Thank you, sir.
Okay, thank you very much. So you simplified my job. Okay. So, okay, now let us break for lunch and reassemble by latest by 2 o'clock. Okay. So, you have any questions, youngsters from ISBR? You have any question, madam? You seem to be very talkative. When you come to the auditorium of Indian Institute of Science, so you need to listen. I have been noticing, please follow the decorum, okay? When I invite people, I also with some purpose. You know, yesterday Karthik was a young student like you. Today, he is a stalwart in the field. So tomorrow, if you want to be like him, then we have to follow you have to follow the discipline, okay? Talking can happen at home, talking can happen in marriage hall, not in the classroom. Okay, thank you all. As a teacher, my job is to make the people refine their paths. I am doing that also. And second thing, you know, he talked about invasive species. You know, invasive materials also getting into our system. Today morning when I arranged the good food. We have taken precaution to have a very good quality food, pongal and good coffee, tea. But still I saw some youngsters having carbonated drinks. I don't know, which I use for toilet cleaning at my house too. You know, the youngsters of today are drinking that. They do not even understand the chemical composition of that, and they just, you know, these are the things you have to curtail. When the food is arranged, there is no point in having this junk food. So at least that part you have to learn, and I am very happy that boy who was taking that carbonated drink, he told me, I am not going to touch it from now onwards. He has assured me. That is what I wanted, and that is the sign of change. And we have to change everyone in the system. If that happens, that's good, and you will also succeed in life. if you cut down your talking in the classroom. Okay? 2 of you, 3 of you, left, right and center. Okay? Okay, let's break for lunch. Okay? No, I thought after food is taken, the mouth will be shut, huh? And sometime eyes are also shut, you know. So we don't want eyes and ears to be shut, but certainly mouth can be shut. Okay. So shall we start the session? Others have to join. Huh? You know, this suit put fellows will take some time. Don't, and they are the one not here. Huh? They must be having Coca-Cola or something still. So let us. Okay, now we have a session moderated by Professor Prasad and Chandan. So now I request Chandan to do the presentation, and I hand over the session to you so that you can coordinate the thing. You can come here and you are comfortable there. Okay.
Good afternoon. Voice. Good afternoon. Okay. Yeah, I definitely want them in the front. Please. Please come and occupy the front seats.
He wants, otherwise he will ask questions in the back only.
Yes, please come first. Meanwhile, while you settle down, my association with TVR sir is almost 10 years. 2013 when I first met him, even today he has the same energy. I think you should question TVR sir, what is his secret of the energy. You are still sitting there, come forward fast. Okay, so let's start this session. Very good afternoon to all of you. I am Dr. Chandan MC, Assistant Professor from National Institute of Engineering, Mysore. So today we will discuss about how do we develop a robust spatial decision support system for combating unplanned urban growth, specifically focusing on Indian cities. So from yesterday's presentation you all have picked up few things about urbanization, how it is happening and what are the key factors that are driving. I am not going to discuss much about how it is happening part. Let us go and understand what we can do part. So the need for understanding this rapid dynamics is, you already know that pre-existing metropolitan cities of India like Chennai or Mumbai, Delhi, they have all saturated in terms of resource utilization. And if you see the newer urban agglomerations like Ahmedabad, Hyderabad and Pune and lot of other cities, they are picking up the pace. Okay. And if we look at the unplanned urbanization, there is the land acquisition which is happening rapidly, urban sprawl, land degradation is happening. Yesterday we had a discussion about the land fragmentation. So it puts so much of focus on planning and visualization. This is one of the important key aspect. And the changes in environmental health and imbalance in natural ecosystem is also seen on the contrary. And if you look at the major thing which is driving all this, the word sustainability. Okay, the sustainability of resources, the natural resource, how we utilize, that comes into picture. And recently if you see in the UN General Assembly, there were 17 SDGs that were put up. Out of the 17 goals, the goal number 9, that is industry, innovation and infrastructure, and goal number 11, that is sustainable cities and communities. We are trying to focus on these two goals and how this can be achieved in the near future. So in Indian scenario, right now we have huge data sets, geospatial data sets, like spatial data set by the name, if you go, it's like map. All of you have used Google Earth, Google Maps, right? So they are called as geospatial maps. So we have already lot of maps, but the problem is retrieval of the existing maps. Suppose for example IISC has done one project and they have certain set of maps, IIT Kharagpur has done one project and they have certain maps, but these two never come together. So often as students
you go and search for one information and you try to do it by yourself. That means you are curating the data and it is taking time. So how do we put all these maps together in one platform? That is the question. So that is the major hindrance today that we are facing. So to combat this, we have something called as spatial decision support system for a good governance, that is called as e-governance through the data, which is the growing need. And if we look at certain definitions which define urban area and urbanization, of course it varies from parts to parts in the country and country to country altogether. But majority of the authors, they have defined urban area and urbanization based on the settlement pattern, how people tend to settle. In earlier days they used to settle adjacent to rivers, forming small colonies, then villages became towns, towns became cities, and today we are living in most complex urban ecosystems. So if you look at the urban ecosystem, the dominance of low density urban settlements and the change of previously monocentric compacted city into dispersed, discontinuous, fragmented, polycentric. Here the key term is monocentric and polycentric. What do you mean by monocentric? Earlier days city means it was just confined to a city. Now it is not like that. City means it can be going on towards a stretch and it can meet another city as well. That is what we call it as a corridor kind of growth. So there are three major types of urban sprawl. One is called as the low density urban sprawl. Then we have the ribbon sprawl and leapfrog sprawl. Other type include the edge expansion and spontaneous growth. I know visualizing this is a problem, so let us understand by an example. So when we look at 5 types, we have low density. Best example is Bangalore, wherein the urban area tries to reach to the outskirts. Then second one is called as the leapfrog. This happens when there is hindrance, natural topographic setting. There is, suppose there is a hill or a lake. So when you have these kinds of hindrance, then there is a leapfrog kind of a sprawl. Ribbon sprawl is mostly with respect to the corridors, like the urban networks, transportation networks. Edge expansion is another type wherein you have the new pockets on the edge of the cities, and the last one is called as I think spontaneous growth. Best example is Ahmedabad. When you look at Ahmedabad city is not only growing, but the rural pockets are also contributing to Ahmedabad city. Now for the analysis, we have taken 3 metropolitan cities and 7 conurbation cities. The metropolitan cities like Delhi, Kolkata, Mumbai, and other cities include Ahmedabad, Bangalore, Bhopal, etc. So this particular slide shows you the transition of urban growth from 1990s to 2018, how all the cities have changed during this time period. And if you see this slide, we have categorized the jump or the transition into 3 categories, that is gradual, moderate and rapid. Under gradual, we have cities like Ahmedabad, Bangalore, Chandigarh, etc. Under the moderate transition, we have Bhopal. Rapid transition, we have Chennai, Coimbatore, and these are the 2 cities. Chandigarh I think I have put in general. So when we look at, so far we have observed from 1990s to 2018 or 2020 how it has happened, but what is going to happen next and what we can contribute. So to do that, we have something called as urban growth models. So models have been adopted to predict future urban growth using simple transition rules. That is where the cellular automation comes into picture. But traditional approaches like cellular automata, they fail to predict complex urban pattern. What do you mean by complex urban pattern? Because nowadays we are not only sticking to one aspect of the growth, we are looking at multiple aspects of urban growth. So this multiple facets, the traditional model, they cannot predict that. So we need some kind of artificial intelligence or some kind of optimization process which can really improve the urbanization process itself in the future. So if you look at the broad categories, we have artificial life. The cellular automata, what I mentioned, is one just basic model for urban growth. Then we have agent based model, swarm intelligence. In this we have ant colony optimization, bee colony optimization. That means how this nature inspired techniques we call it. So, how it is going to help our urban growth modeling. And if you look at advanced intelligent stochastic optimization process, we have genetic algorithm, and we also have simulated annealing, and the other things include artificial networks, fuzzy logic, heuristic search, etc. So, in this we have picked up a model which is named as SLEUTH, S-L-E-U-T-H. It is an abbreviation for the layers which are used for the model. S stands for slope, land use, exclusion, urban, transportation and hillshade. Professor K.C. Clark has started this model, which is basically a cellular automata based model. And if you look at this model, the parameters which control, it has 5 different parameters: diffusion, breed, spread, slope resistance and road gravity. How these 5 are contributing to each city. And apart from these, we also have transition rules. Rules means you set certain rules. For example, let us say in Bangalore we have 5 lakes, Vartur Lake, Belandur Lake, ABC Lake, and you have picked up these lakes as one layer, one geospatial layer, and you are saying that no development is going to happen in and around 30 meter of the buffer zone from these lakes. So, this is a rule that you are giving to the model. Okay. So, those rules can be categorized into 4 types, that is spontaneous growth, new spreading growth, edge growth and road influence growth. So, combinedly the coefficients and the parameters, they will define the modeling process. So, what data do you need? As I mentioned, you need the slope layer and you need the land use for at least 2 different times. You need the urban layer for 4 different times, and here I have given an example of Chandigarh city for 1990, 1999, 2009 and 2017. Similarly, you need the road network for 4 different time periods, and of course, the excluded layer. Excluded layer is the one where you put the restriction so that no development happens there, and of course, the hillshade layer. So, this is the workflow of the SLEUTH model. So, you begin with the input layer standardization, you create some scenario files. I do not want to go into all these things, I will just highlight the calibration phase. So, it has 3 different phases of calibration: coarse calibration, fine calibration and final calibration. Why do we need this calibration? Is because each of the coefficient has a range of 0 to 100. In that 0 to 100, the coefficient can be anything, any number between 0 and 100. So, how do you define which number is best suited for your city? If you have breed coefficient as 18 for Chandigarh, that might not be true for Bangalore, because setting of Chandigarh and Bangalore is not the same. So, here in the calibration phase, what we do is, under these 3 different heads, we pick up the best suited number for each of these coefficients. So, once you do the calibration, we are set to predict with the optimized coefficients, and then you can get the modeled output. So, this has been implemented to Chandigarh, and this is the modeling output for the year 2025. So, here you can see spreading type of growth for Kharar region, wherein you have the NH95, which is passing from Chandigarh city towards Ludhiana. And if you see spontaneous growth, which connects the major region, that is Eco City, and you can also see the detached individual urban areas along Kurali Chandigarh highway road. So, this is the highway road. And another type of growth what we have observed here is organic growth. Here majorly the Pinjore and Kalka region, there is a lot of tourist attractive places here, and there is also a reservoir. So, there is one highway which is connecting to the reservoir. So, here we can observe organic type of development, and diffuse kind of growth. We can see this near the Zirakpur industrial area as well as the airport, Chandigarh International Airport. So, this is the major outcome from the SLEUTH model for Chandigarh region. The same thing was implemented for most of the cities of India, and we tried to predict what is going to happen in the near future. So, if we take up Bangalore, the total urban cover is 31.75 in 2017, which is going to be 57.72 in 2025. Similarly, for all the other cities it was conducted. There was a special case with Hyderabad, so we took up Hyderabad region and we demonstrated 3 different scenarios. The scenario number 1 being the business as usual scenario, that means we are absolutely fine with whatever is happening till date. However, the urbanization has happened and it is going to follow the same pattern. Scenario number 2, wherein we have given moderate restrictions like okay, you cannot allow some development around lake and all these things. Scenario number 3 is very high restriction, that means you cannot violate even 1% from the master plans. So, after conducting this exercise, we experienced certain types of growth in pockets under all the 3 scenarios, Himayat Sagar Lake in and around that, diffusive kind of growth. Then Shamshabad Airport, we saw spontaneous growth. Kaizipalli, we saw organic growth. Hakimpet, we saw spreading type of growth. So, of course, when we understood this in a better way, we saw that scenario works very well because it had very high restriction on the growth. So, similarly, the same thing was expanded to the recently debatable topic, which I can say, the Mysore-Bangalore infrastructure corridor. Of course, this study is still going on. One of my project students is still doing this project. So, the agenda was to see how the land use is going to change after the 10-lane expressway, which is coming from, joining Mysore and Bangalore. Earlier it was 4-lane, so now they have upgraded it to the 10-lane expressway. So, if you see the numbers, in 2018 the urban percentage was 20.27, 2021 it was 22.81. Of course, there is a slight difference, but our idea was not to see how much is the difference in urban. Of course, it will increase, but what is it going to do for the regional people there? And this is a part of socio-economic exercise. How many number of shops that are going to close, or they are going to face the problem with this expressway coming up, that part of the study is still going on. So, the types of urban growth along this highway, we conducted sub-regional analysis again. Biddi experienced breed kind of growth, which was predicted for 2030. Chanpatna experienced diffusion, Bangalore experienced spread type of growth, Bangalore and Mysore both. So, till now we spoke about how these cities are transitioning and how it is going to do in the future and all. But if you remember the first slide, I talked about what is the best way to put all this data into one particular source. So, we tried something called as web-based analytical resource for visualization and analysis of geospatial data. Basically, yesterday we discussed about GeoServer and all. So, this is also a part of it. Here we are trying to build a client server architecture, web-based SDSS system, and it was tested in local host 8080, and basic functionalities is already made available for this website, such as zoom in, zoom out, etc. And also we have included the geo processing part. That means you can upload your own data and you can see what is going to happen for a particular city. For example, if I take Chandigarh, you can select one of the modeling methods. Here I have given the example as BFM, that is brute force method, sleuth, and you can select a scenario that is best suited for your region, whether it is low restriction on growth, moderate restriction, or very high restriction. And also you can select the population growth, what would be the population. You can use logistic regression methods for finding out the population in future, and that population can be the input for your model. Then you can select 1 year for prediction. So, this will also be aided by many decision making factors like restriction type on urban growth and policy recommendations, how it is going to affect, and decision on environment, sustainability and implications, what are the factors that needs to be considered, decision on urban area, land use change and transition. These things can also be put into the model. So, in your free time you can just go through this called SWUT SWOT, that is Spatial Web Based Analysis of Urban Transition. As of now we have enabled only 2 cities, Chandigarh and Hyderabad, in that particular portal, but we have plans to upload the data of all the cities there. Of course, you don't have to create login option for just looking at the data, but if you want to analyze the data, you have to log in with our servers. So, this particular website swaut.co.in, currently we just checked before this session, somehow there is an error in the domain. I will try to fix it in another couple of days, then you can have a look at it. So, major research contribution is the analysis of land use and land cover dynamics. So, the knowledge contribution was development of unique urban growth indices were developed to understand how the growth has been happening, and historical data was analyzed for the last 3 decades. Geovisualization of urban growth using cellular automata model and improving the model for calibration using advanced methods like sleuth particle swarm optimization. How did it help? Because I insisted on scenario based study wherein we consider identifying the loopholes which are there in the city development plan and how this can be fixed to achieve sustainable development goals. And last part was to develop SDSS, that is spatial decision support system. So, this interface will cut down the time in terms of spatial data processing. You do not have to process the data again and again, directly you can download the data from this portal. So, once this portal is completely tested, you can also put your own data to analyze certain cities. I would like to thank Government of India because this was a funded project, RCG SIDM and SHRIC IIT Kharagpur, SERB DST, Government of West Bengal, NRSC ISRO, UCSB and USGS for providing the data, and I would like to thank convener Dr. TVRAMACHANDRA for providing me this opportunity. Thank you so much. Thank you, sir. Thank you.
I think it's fantastic what you're doing and need of the hour, especially the decision support system where you said we can put the sustainability aspects so that the growth can be modeled. How do we tackle these market trends and social issues? Is there something that really predicts that? Because many a times the market trends change so drastically without any clue.
That's correct.
And it's very difficult to predict that, especially when we look at these huge projects coming up in the private sector. Maybe predicting it may not be so important, but the main problem is when land use change happens and other income group or other livelihoods
that
get
is
affected.
exactly where right now what we are doing one project on Mysore-Bangalore Expressway. We are trying to get what is the impact on socio-economic aspect, like how many lives are dependent on that stretch of highway, and if we move to that particular expressway, there are small hotels or maybe some small shops, they lose their livelihood. So, how this is going to affect, that part is going to be handled, but we cannot see it in this aspect, you know, like we talk everything in terms of layers and data and everything, but that needs more of a ground exercise. We have to go to the ground to see the reality and how the people are facing that issue.
Mainly highway growth, because I am in a region where urban development is very common. It's that land cost will go up. Definitely. And those people are forced to convert, which slowly penetrates to a depth, but rest of the people also there is a negative part, is if you're next to the highway, every time highway expands you lose your property.
Yes.
And don't get the compensation equal to the market rate. So both sides are there. So all these are very complex social issues, and transformation is very much
to do
from
this
the
kind of
market
analysis.
trends.
We need a lot of inputs from humanities department. So we are in touch with humanities department and we are getting the inputs from them. So one major thing what they gave to us is you conduct ground reality. So we are making a team to do it. It might be in another 2 months. So yeah, thank you.
Have you considered a decentralization aspect? I mean, there is no reason why everything has to be located in Bangalore. I think this is a policy issue both from the federal level, that is the central level, as well as the state level and the local level.
Yes, sir.
Because the corollary or the adjoining difficulties, the economic loss by expanding the urban growth is enormous.
Yeah.
I don't think any calculation has been done for Bangalore, because if to go from one end of the city to another end of the city, if you have to spend an hour and a half, not only there is the impact on the human health, plus the economic loss. Is there any effect these type of taken?
Yeah, when we conduct scenario based analysis, that is where this comes into picture. We consider the topographic setting of that particular city and what are the possible
policy thing. We have told the government decongest Bangalore and no more further this one in Bangalore, but hardly few bureaucrats accept that view. So anyway, the success will happen after some time, so let us see. Okay, thank you.
Thank you, sir. Thank you, sir. Thank you.
Respected Chairman of the session, Dr. Prasad sir, convener of the symposium, Dr. TVRAMACHANDRA sir, my earlier speaker and other speakers of the session, and ladies and gentlemen, it's a very great pleasure for me to be part of this Lake Symposium, and in fact I am also associated with Dr. TVRAMACHANDRA sir. I think I attended 2010 Lake Symposium at IISC Bangalore. Seeing the symposium, I was enthused and requested TVR sir to give us an opportunity to host the symposium at Kottayam. I am from Kerala, Mahatma Gandhi University, Kottayam. So he was kind enough to agree, and then I got an opportunity to host the Lake 2012 symposium at Kottayam, Kerala. In fact, I got an enthusiasm that we should conduct the whole symposium floating on a lake called Vemanayar Lake, but that was not possible that time, but only one session we could arrange, the symposium on the cruise, having a cruise on the lake, and then we conducted the symposium one session. I think Dr. TVR also gave a lecture in that symposium. So that was a very, good memory, and then I thank Dr. TVR sir for giving me this opportunity also. Yeah, now in fact I started lecturing on microplastics from 2016 symposium and 20 symposium, and now also I saw a little difference. 2016 when I spoke about microplastics, I was the only speaker. 2020 also I was the only speaker. Now I think there are two more speakers, they are going to talk on microplastics. So I was very happy that the topic is gaining momentum and interest. In this talk I would like to take maximum part of my lecture on plastics and microplastics. Then a small study we have conducted on a lake called Vemanayar Lake, the one which I referred to you, and Cochin Estuary. So how the microplastic distribution is there in these two water bodies, and of course way forward I am just suggesting, or from the literature, not from my own this thing, whatever we experience. Let us see. Yeah, plastics, of course at the outset I say that we are not against plastics, but in fact plastics are one of the wonderful inventions of mankind, and we all know that we can't live a single day without plastics. We have day to day life we are having plastics right from beginning, morning till evening, right? So we are not against plastics, I am not against plastics, but the plastic waste management is a part which puts us in trouble. A lot to be done on that part. Let us see. So as I said, we keep using it. In fact, historically when we look at back the World War time, the plastic was used mostly towards the war, the ropes and then the helmet, that kind of things. Then slowly the production has gone up after the war. Actually, that it got into the domestic sector. Like, so the trend is, that's fine, but the trend now is that past 1 decade the production, it has increased, of course, but most of that it goes to the single use plastic type. Like the trend of use and throw away culture, that has come into picture. That has aggravated the problem more. So more single use plastics are being produced the past 1 decade, so we have a lot of troubles. So you can see that 2 million tons has gone up to 360 million tons of plastic production every year. So we can see the growth of it. This quote I would like to say that the single use plastics, it takes only 5 seconds to produce, and we may use it for 5 minutes, but it takes 500 years to get disintegrated or to get degraded rather. So it remains 500 years. So what is the problem if it remains for 500 years or 1000 years? It causes enormous damage to the soil, water and its ecosystems. That is the issue. So we use it for 5 minutes or 2 minutes and then we just throw it. So that remains, and if we manage it properly, as I mentioned in the beginning, there will not be much problem, but you know that how the waste management goes on into the country and in our country. So higher plastics we use, high we discard, higher the amount you use, higher the amount you discard. If you discard it properly, no issues, but it does not happen. So we discard huge quantity of waste wherever we want, and the problems are more when it is discarded closer to the water bodies, you know, closer to any water bodies. When it is discarded, when it is dumped, the problems are even more in that case. So ultimately all these plastics when we dump goes into canals, rivers, streams, finally to the ocean. Ultimately it reaches the ocean. So marine litter, marine plastics is a very big topic being focused by many countries, right? So all these plastics when they reach ocean, they are carried through the ocean currents and they form huge garbage patches through the, due to the gyres, you know, gyres are the kind of water currents in the ocean, vortex. So it takes all the debris and make huge garbage patches. Is it a pointer? Yeah. So huge garbage patches. There are 5 garbage patches are recognized in the oceans. The Pacific garbage patches is the very big one. So what happens when it reaches the oceans? It remains there as a big island? No. Or it goes down and stays there? Is it, if you see, look at the bottom of the sea, do you find them? No. What happens is that on its way, on its journey from land to the ocean, it gets acted upon by many agents like ultraviolet, wind, wave action and microbes also. So due to which the plastic debris get disintegrated, get fragmented. There comes the issue of microplastics. When the size of the disintegrated fragment of microplastics become less than 5 millimeters, that means half a centimeter, it is known as microplastics. So depending on its size, we classify them as macroplastics. If the size is between 25 mm to 5 mm, that is 2.5 centimeter to 0.5 centimeter, we call them as macroplastics. Between 2.5 to 5 centimeter, 0.5 centimeter, we call it as mesoplastic, and less than 0.5 centimeter, that is 5 mm, we call it as microplastic. When it goes less than 1 micron, we call them as nanoparticles. The lower the size, the issue is bigger. So the nature at which, or the route at which the microplastics get into our environment, let it be ocean or terrestrial, whatever it is, we classify them as broadly 2 categories, like one is primary microplastics, other one is secondary microplastics. So we look upon the secondary microplastic first because that causes a huge havoc or problem. So whatever the plastic waste we discard, as I mentioned in my previous slide, it gets disintegrated and you get the microplastics if the size is less than 5 mm. That is known as secondary microplastic because it originates from a primary source of plastics. No? So this is secondary microplastics. While primary microplastic is something it is being engineered or it is being synthesized for the commercial purposes. They are known as primary microplastics. They are there in our personal care products, toothpaste has, our shampoo has, and many other products has. So whenever you use such kind of products, you are contributing the microplastic pollution of the water bodies or the terrestrial environment. So, primary microplastics are manufactured ones, while secondary microplastics are degraded product of the plastic debris whatever we discard. In summary, so all these items what I have shown here plus many more things contribute to the microplastic pollution. When you discard them unscientifically, when you are not managing them properly, all these sources. So, when we wash the synthetic cloth in your washing machine, so every liter of the effluent has thousands of microplastic fibers, synthetic fibers, they are also microplastic. As I mentioned, the size is lesser, the issue is bigger. So, all these sources provide us all these serve as sources of microplastics. You have our personal care products, we have the synthetic primary microplastics from clothing, from whatever the discarded plastic materials, right. Now the issues. So, what are the issues connected with this microplastic? So, when they are in the environment, what are the issues? I am just focusing on major 2 or 3 issues. One is that because of their size, they are mistaken by the aquatic organisms as feed, as their feed, and they consume it, right, they consume it. So, once the aquatic organisms consume, it gets into the food chain and food web of the ecosystem. Lower organism, benthic organisms to pelagic, then demersal, then it goes to the higher consumer level. Every trophic level it gets transferred, and so the whole food chain or food web is contaminated, and will come to human being also. When we eat seafood, definitely it has. So, we ourselves have done work, many papers are there, you can see in the literature. We have microplastic in the fish, we have microplastic in the prawn or crab or mussel, the bivalves, I am from Kerala, and the bivalve is a favorite food there. So, the issue with bivalve is much more than fish, because the larger fish we remove the digestive tract, we eat only the other part, may not be much contaminated, but bivalve we eat whole thing. After removing the shell, the whole thing is cooked. So, the microplastic in the digestive tract, in the tissue, everything we eat. So, that is the kind of issue we get when we eat, which is contaminated with microplastic. Okay, one may say that I am a vegetarian, I am not taking non-veg, there is no problem, but you are not an escape, because the salt, sea salt, So, we have done a work, we have done some 12 brands of commercially available salts in Kerala, Kottayam particularly. So, we found all of them have microplastics. So, every pinch of salt you take, you also take microplastic. Today afternoon lunch also you might have taken microplastic, thanks to TVR sir. Okay, but salt is there. My problem is salt, not non-vegetarian. Okay. So, the other risk, actually the polymers are not made as pure, they add additives in order to make them for different purposes, Some of them should be UV resistant, some of them should be fire retardant. So many chemicals they add, even colorants, colors are there. So, all these chemicals and the additives like phthalates or bisphenol, all these things are there in the plastics. So, when you consume plastic through food chain, food web, we also take the cocktail of all these chemicals, that is another risk. Third risk is that, as I said, that when the plastic remains in a lake or in ocean for hundreds of years, it is surrounded by many pollutants, When it is a lake, you have pesticides, you have heavy metals, you have POPs, all these things absorb on the surface of these microplastics. Any plastic, not only microplastic, anything they absorb on the surface. So, when it is microplastic, when it gets into food chain and food web, seafood with microplastic, with all these adsorbed chemicals, heavy metals are reported, POPs are reported, there are many such harmful pesticides are reported on as sorbed on the surface of the microplastics, right. So, you take microplastic, its own additive is harmful, microplastic is harmful, plus these sorbed chemicals. Besides all these things, there are microbes, microorganisms, many of them are pathogenic. They also attach on the surface of the microplastic and grow as a biofilm, right. So, along with the chemicals or substances, the microbial film having the microbes also travel to the food chain and food web. They travel as hitchhikers, and of course, we do take them. So, this kind of mobility of pathogens or microbes from one region to other region, the plastics or microplastics help them as a vectors, they carry them. So, these are some of the risks, there are many more, I just highlighted some of them for want of time. And of course, there are reports, papers, you can see that
plenty of papers are available. There are reports what kind of harm that causes to the organisms which consume them. There are feeding disruptions, inflammation, circulatory issues, even carcinogens. By the way I said from the last 2-3 slides, you can understand many of the chemicals are carcinogens. When we take all of them along with microplastic, of course. And there are many reports available that the causes on human being also, because we take a lot. So these are some of the reports which say that these are some of the disorders, or these are some of the impacts on human beings. Right. Now let us quickly take a look on the research publications, how the growth of research publication has taken place last 2 decades. If you see that between just before 2000 there are only hardly 2 papers globally. Slowly it has gone up, and then by last 5 years you see that around 3000 or 4000 research publications have come up in this area of microplastics. Then of course last year also. So together around close to 7000 or 6500 papers are there globally being published just within last 1 or 1.5 decades ago, that much. And then of course globally this much, but from India less than 500 papers are there. Now it may be little old data, maybe 500 it might have crossed. And from Kerala, the state where I work, there are some less than 50 papers are published. Right? These are different areas all these papers talk about. If you see this graph, I just want to draw your attention on this, that out of this many papers, of course this is from India, you say 63% of the papers published on microplastic focus on marine environment. It all started with marine litter, marine plastic like that. So most of the work done on marine, and you have less than 17%, around 17% on, 14% on freshwater systems, then 17% on the human consumable food items like that. So what I mean to say is that the more work has been carried out on marine systems, very less on rivers and lakes and this thing. So estuaries are least attempted, hardly 10 papers or 18 papers all over India on estuaries. Like yesterday onwards we are hearing lakes and estuaries, their importance, all that. So the microplastic pollution in estuaries are focused less. So that may be identified as a gap area, like research gap. So microplastic studies are more in marine systems, less in freshwater systems, still less in estuarine studies. So I just chose that topic for you as the Lake Symposium 2022 to present a small study we conducted on a lake, Vemanar Lake and Cochin estuary. In fact, they are same. The Vemanar Lake is the southern part of the lake, and the northern part is the estuary. It is close to the, it mixes with the Arabian Sea. So we made a study to study their abundance, and then their different characteristics, and then the polymer profile of the microplastic. I will just present you how we done the study. This is the Vemanar Lake, where the Lake Symposium 2012 was conducted, and I don't know this. Yeah. So this is the lake. So there is a bund. Actually, the significance of this lake is that, one is that it is very close to our university, 10 to 12 kilometers from our university, and this has a huge basin. Like this lake receives 5 rivers. They discharge in this lake. So it receives discharge from 5 rivers, and then the water remains here at least 6 months because there is a bund. It's known as Tanirmugam Bund or barrage. It was human constructed for the purpose that when it is monsoon time, all this river discharge will flush the fresh water towards the estuary side. The northern part is estuary side. This is the freshwater side mostly. But when it is non-monsoon month, the saline water will intrude here. So this is a kind of agro-ecosystem, rice bowl of Kerala. Here the agriculture is done below mean sea level, next to Netherlands. So that is the importance of this. So in order to protect the agriculture, they made a bund so that the bund shutters will be closed in order to prevent the saline water intrusion. Now that makes the issue of microplastic more, because the water retention time is for 6 months or more than that. So the rivers drain their discharge. Rivers are all flowing through highly populated places of Kerala. They carry the plastics, and the plastics are dumped here. They remain here for longer time. Only when the shutters are open, they will go out. So that's why we took our study here, 10 locations, and all 10 locations had plenty of microplastics. And also we studied the Cochin estuary side. So I'll just make a presentation of what happened. Is there? Okay. So this is the northern part of the Vemana Lake. You can see that Cochin estuary mixing with Arabian Sea, and then we have some 8 sites selected here for sampling. And this is about this, of course, Ramsar site. Vemana Lake is a Ramsar site, one among the 3 Ramsar sites of Kerala. And then number of sites, 8 in Cochin estuary and 10 at Vemana Lake. And of course, we have done different depth water samples, and we want to see the stratification of the microplastic distribution, and of course sediment using grab sampler. Some of the field photos our students are doing with water as well as sediment sampling. And this is the procedure. It's all very standard procedure we get from any literature. The basic principle is that the water or sediment, we digest it, because particles are important for us, but organic particles also will be there. So we want to digest off the organic particles, then make a flotation, density separation. We make the plastics to float on the top of the high density medium. We use sodium chloride as a high density salt solution, so that the plastics will float on the top. Then we filter the top supernatant on a filter paper. That filter paper is dried. After that, it is taken for visual observation to a stereo microscope. So we can see the structure of the microplastics, dimensions we can measure, color, shape, all that we can count, abundance also. Then in order to know the polymer, what kind of polymer that microplastic has, whether it is polyethylene or polystyrene or polypropylene, we take it to Raman spectroscopy, or micro FTR somebody has, they can use it. So through that we get a spectrum. That spectrum is compared in a library to identify which polymer is that. That's how we do the whole study of microplastic. This is the gist of whole study we do. And that is our stereo microscope, and this is our Raman. So we okay. So that's our what happened. Going reverse. Okay. So stereo microscope and Raman. Raman is a common facility of our university. We don't have it. It's actually a DST facility, so anyone can use it on payment. And the spectrum is compared with the library. Know It All is the name of the library. That will tell us the spectrum of ours with the standard spectrum. We compare and see more than 80% match. We classify it as either polyethylene or polypropylene according to the library. So that was the outcome of our first paper. In fact, on Vemana Lake, that was the first paper in India. It's a first report on microplastics done 2017. After that, you can see 500 papers have come on the area between 2017 and 22. It was our first report on microplastics. These are some of the stereomicrographic view of the plastics. It's a we classify them based on the shape. If it is a thin fiber, we put as fiber. Fragment like that, we classify them. And this is a gist of our findings, right? So in water, you can see that much, how much, I mean, a mean of 26 particles per liter of water. You can imagine how huge a quantity of microplastics are there in the water, and sediment is little more, 200 or 300 like that. And then that was 2017. Again, we have done the same study in 2021. Actually, this is per kg, that was the area. So per kg it has gone up. I mean 230, and then Cochin estuary side you find more. You know, that is that other side of the lake, the northern side. You have 700 particles, 750 or something per kg of sediment. You know, it goes and settles down. The issue with sediment is that from there the benthic organisms start feeding upon them. And the other issue is you can see that the size of the most of the thing is, I think it's not given over here. Okay, it might have been given at the later stage. So this is the spectrum we get. The bottom one is the spectrum we get, and the reference spectrum is that in light green color. So we can match them and find which is the polymer of the microplastics. 70 or 80% more than match is there, then we can classify it as the polypropylene or whatever the polymer is. Right? This is the sediment, same way we analyze. So it's a comparison of many other lake sediments or estuarine studies with our studies. Mostly our studies shows that we have more number of plastics than other studies. So far, whatever we have compared, you know, our lakes and estuaries have more number of
more abundance of microplastics. So, a general conclusion from the study what we have done is that it is ubiquitous, it is highly pervasive, I mean it will spread very fast, and then you have everywhere this, and you see this size, see this is size predominantly between 100 and 500 microns, small size, that is the maximum number we get. That means there is every possibility that it can get into the food chain and food web and get into our food system. The size is smaller, problem is bigger, that is what I mentioned like that in the beginning. And of course, microplastic along with the adsorbed pollutants also go into the system of organisms and human beings. And these are some of the challenges, as I mentioned, the plastics before they reach the water body, if we can remove, that will be easier. Once it goes to the water body, it is very, very, very difficult. There are attempts being made by many countries and many people to retrieve from the ocean, maybe microplastics. Microplastics is very, very difficult. Is it time up? Okay. So, way forward, I just want to, this is more important part, I feel that what should we do, in future, whatever we have done for 50 years or 30 years is done, we can't do anything, we can't retrieve, it is highly impossible to retrieve the microplastic which has gone into the garbage patches of the Indian, ocean bowls, world oceans, we cannot retrieve them, but what can be done? One is that people are trying for large scale cleanup of rivers, lakes, even ocean, they try to clean up, we will see some of the pictures how they do it. Then prevention in future, it is in your hand, future prevention is a better option, that is what we feel. So, of course, realizing that many governments, many nations have initiated many steps, you might have seen now change, we could see that the plastic cutleries have gone, in many places you have the reusable or the wooden cutleries have come in, right, and like that many we see that. Of course, there are people who work on degradable plastics or bioplastics, much has to be done because it is a long way to go in success of that. And the Kerala model, what we do in Kerala, government of Kerala is doing that also is a very good thing that they are doing it. These are all a kind of preventive measures, nothing to do with the already we have done the damage, nothing to do with that, but we are trying to prevent it, we will see what is it. And Tamil Nadu government has come with the Meendum Manjappai. Manjappai is a yellow bag, cloth bag that they have introduced, that also we will see. And all these things when you put together the 3 R principles like reduce the use of this kind of items, right, and then try to recycle. Of course, you have got it, try to reuse it many times before it becomes useless, then try to recycle it. The 3 R principles is one of the options. So, it is a huge kind of cleanup. They try to put huge net and they have vessels, they try to pull, and there will be a middle, there will be a kind of large tail. So, all the plastics, mostly meso or macroplastics, of course microplastic may also be there. So, they will try to converge them, take it to the middle of it, and then they will try to collect them and they will try to recycle it. It is a very highly expensive and very difficult. And interception techniques, they do reverse, they try to put a kind of barrier so that the plastic floating ones can be removed. These are all cleanup attitudes, approaches. You see like this, they collect in the tail, the bin, a large one, from there they will take it to the shore or on board of the vessel, and then they will try to recycle it. That also people are trying. But prevention, in my opinion, is better one. This is the Harita Karma Sena, team of women self-help group have been trained properly to go to each household, try to collect the waste. So, that is what they do, and then each household may pay 50 rupees per month to them. So, win-win, like they also earn, we also do not have the problem of garbage. That is what the Harita Karma Sena does. So, they go and collect the waste and segregate them. 2 categories, degradable ones, other one is non-degradable. So, like that they classify. And of course, the non-degradable one, again they classify them as which are the recyclable plastics, which are non-recyclable plastics. The thermoset plastics are non-recyclable, we cannot do anything with that. Thermocycle ones, we can recycle them, and the thermoplastic, that can be recycled one. So, they classify them as 2, recyclable and non-recyclable. Whatever is recyclable, they will bale it and send it to the recyclers. That is how they do it. Non-recyclable ones, what they do, they powder it, they make it they shred it into small pieces, and then they give it to the furnace, or they give it to some industry as a source of energy, or the tar, road making, I mean that kind of purposes they do. All these are done by the Harita Karma Sena, and there is Clean Kerala company, there is a company, so that is also government owned. So they collect and give to them, they will do the rest of the things. So the collection part and segregation part is done by the Harita Karma Sena people. Right, this is a team and they are trained. They go to each household. You know, there was an initial issue that the household people, they hesitate, I mean they were not willing to pay money. They were ready to give the garbage, but they said, why should we give our garbage, as well as why should we pay for you? But that they have to convince them, and then they bring in awareness, and slowly the situation changed, that people collect in different sacks and then give them this thing. Of course, when you pay, they give a receipt also. Sorry. Again. What happened? Oh, beginning. My chairman won't allow me to go from beginning. And there is something else here, I pressed by mistake. So, I will make it fast. So, they convince them, and then they collect, take it, and they give a receipt also if you pay, and then they take it to a place called material recovery facility or something called then. So, the degradable ones they give it to composting, of course you get compost out of it, and non-degradable again they segregate it, and then they make bales, the recyclable ones send it to the recyclers, other one they shred it and make the granules, and then give it for road making, tar making, whatever it is. So, that is how they do it. And this is the government of Tamil Nadu's initiative, that they have started distributing the cloth bags in yellow color, so they call it as manja pai. This is an IIS officer who is introducing it, the vending machine. So, you put 10 rupee coin or 10 rupee note, so it gives you a bag, you can use it. So, that was another approach. These are all actually we are turning back to our old days. When I was a school kid, I used this kind of bags to go to school. My son is not even known to it, he has not seen it probably. So, we are trying to go back. So, try to remember the 3 R's at the end of this lecture. Try to remember that whatever we reduce, whichever waste, not only plastic, any kind of waste, try to reduce them, it will save our earth, and try to reuse them and try to recycle them. Problems may be global, but some of the solutions can be local. We can think locally and to solve the global issues. Remember, it is highly fragile, we have to handle it with care. And I acknowledge all these agencies because they have given some projects. In fact, the Ministry of Earth Sciences has given me opportunity to go to Arctic, North Pole and Southern Ocean, Antarctic site. Both places I did microplastic research, and the microplastic has reached both the poles. We found microplastic in Arctic fjords, we found microplastic in the Southern Ocean sediment, that is Antarctic sediment, you know. That much spread it has already occurred. I did not have time to go through those slides, otherwise it would have been nice for you. And DST SAFE is helping us with the Raman microscopy, and then these are the funding agencies. And this is my team, the extreme right side, they are postdoctoral fellows, and he is a faculty, other students are PhD scholars. They are all doing this microplastic work here now, and 3 of them have finished, so 2 of them are still there. So, I thank all of you and thank Ramachandra sir for this wonderful opportunity, and I am happy or glad to take any questions.
Thank you, Ramaswamy sir.
Prevention, sir, I mean we may not be able, there are people who are working to degrade it also. There are microbes, so they are finding out to degrade. Maximum that application can be from a point source, you know. If you have a microbe, or if you have a consortium of microbe which can degrade, they can degrade plastic also, they can degrade microplastic also, but where you will apply it, the question. A point source may be, because the sewage treatment plants they treat, you know, sewage treatment plants are good for treating macro pollutants, micro size they are also not able to. There sometime you can, but again it's, you know, that pH, other things are to be very conducive for the microbes to grow. So that is also a thing.
I have drafted as a ban of plastic microbeads onset of microplastic,
Yeah.
I have said need to amend the Water Prevention and Control of Pollution Act of 1974, prohibiting the manufacture,
Yes.
packaging and distribution of cosmetics
Yes.
containing plastic microbeads. Do you
Many-
agree with that?
Yes, many European countries have already banned.
Okay.
In fact,
We
we
have
were,
not- we
we
have
were
not-
using the natural ones, sir, earlier, because the plastics are very cheap, very inexpensive. The product producers are using that. Otherwise, earlier we were not using them.
And second thing I have said that which you have to amend is regulate plastic at source, considering the health and environmental hazards associated with microplastics.
Certainly, yes, definitely.
Okay.
Yes.
Both are agreed, okay?
Yeah, yeah.
Sure.
Thank you.
Now we are rather steeped in waste plastics. Every day, intended or unintended, plastics keep invading homes.
Yes.
All packages,
Yes.
everything come in plastics in different forms. So, and the municipalities and all collect and we religiously give. But they also go and dump, or they are searching for dumping places than for recycling, and ultimately bulk of these get carried into water bodies. So there are, and through water bodies it comes and
Yes.
as human food, like that. So there are, in my opinion, we have to do some sins. One is burn it and then save the marine animals and water body animals. But the sin all of us will share in climate change and all that.
Not only climate change.
Until a solution is found. So now otherwise discarding is a much more big
Dangerous,
problem,
yes, yes.
major issue, and it will kill the whole humanity and water animals and like that. So burn climate change. So let us experience heat and cold and
No.
and cyclone.
That's what I want to say. He is telling.
When you burn, there is a problem of dioxin getting released.
Yes.
And everyone in the vicinity get affected. You know, for their sin of using plastic,
Yeah.
they will be paid
Yes,
for
yes.
it.
So we pay for it. Through
Actually,
our this thing.
CPCB has come
Why do
up,
we? My question is this ethical thing. Why do we punish the innocent animals like that, which are in millions, and God created them? So do we have the right to do it? What is sin? We go to temples and pray, or churches and all that, and throw the plastics like that. So are we going to get any
No.
excuse from God for this?
Sir, I respect your comment, and then I would like to say that it is not only plastics which kill the organisms, the pesticides, the heavy metal, the paint, whatever we throw, everything goes there. So burning is again, it may bring the immediate effects, like 1060 degrees. If you burn it 1060 degrees Celsius and above, dioxins will be destroyed. Otherwise, the dioxins will go out, come back again to us. So that is a problem. So incinerators.
Segregation is one problem.
Yes.
Then the production of refuse derived fuel was suggested, but there are very few examples like cement factories using plastics, but very negligible quantity.
Yes, yes.
The road making and all that.
They are there. They are all demonstrated.
Only
Practice,
hardly 10%.
find 10 kilograms of plastic bottles.
Yeah.
Almost big cities.
Road making 10% of the tar only they can use it, the plastics.
No, actually there is one person, I think Madam also know, the Padma Shri Vasudevan.
Yes.
There is a College of Engineering.
Yes.
He is doing some job of converting that plastic. In fact, he comes and says, you use plastic. I want those plastic. In fact, every time when he comes, I and he has a heated
Basic
debate.
problem is in solid waste in India still at infancy, even in state capitals. Big state cities like Hyderabad, I see some colonies are clean, posh. Regularly the material is taken, but then it will go to landfill. We have 7-8 spots of landfill sites in Hyderabad, tri-cities. So from there, it is there forever.
But are there really landfills? Dump yards cannot be landfills. That's also a question.
They are not managed scientifically.
Yeah.
Yeah, it is only dump yard.
Dump yards, not landfills. Yes.
There are many countries which are incinerating their plastic for energy use.
Yeah.
So what is it they are doing? Is it the temperature that can be very high so that the dioxins are not released into the air? Is
They are
it something
supposed
like
to.
that?
We do not know. They are supposed to maintain, but you know, when it comes to a cost benefit, nobody is going to monitor them every time they are burning it at 1006 degrees Celsius. Intensive. So that is a problem. Actually, many proposals came to Kerala government. I was also a committee, but we rejected it because the company says that you just give us 300 tons of plastic every day and a place, we will do it. When we produce electricity, you buy us less than what you buy from other states. But even then we rejected it because we can't be sure that how much temperature they are going to burn it. If it is less 800 degrees, then all dioxins will go. Imagine tons and tons. When they burn, it will go and come back. What kind of effect it will cause to human beings, we do not know that.
Sir, one question.
Yeah.
Regarding the microplastic and nanoplastics, what dose which cause the like LC50 effect? Actually, there is no. I have seen in the Chinese people have done a lot of this microplastic publication. What dose is going to damage the LC50 dose? That data is actually not available in.
Nobody knows.
Literature.
Sir Upendra did the presentation yesterday.
Okay.
Yesterday at 4 o'clock, 4:30 we had that session. He demonstrated that, how it affects us also.
Actually that the data it is there all telling that microplastics which is affecting. But actually what time is taken, how much on the system it is.
Yesterday evening you are not there. Professor Upendra did this presentation.
I have listened, stop.
The doctoral thesis was on that.
Yeah.
They have,
Abbas, this one.
Lab is there. How it affects the muscles and the neurons and all those things he has demonstrated that. Okay, I think we will thank you very much for an interesting
Yeah,
talk.
welcome sir for your opportunity. Thank you. Yeah. Thank you.
Thank you, sir. I now request Professor Deepika Shetty to carry on with the presentation.
Good afternoon. You have seen a couple of examples of spatial planning and decision making, and he demonstrated how sustainability is at large scale regional level. I will like to go into the smaller stage where each and every one of us, when we are involved in our built environment, how the decision making should ideally be there, especially focusing on sustainability. My first 8 slides will be repeating Sir's lessons, which have guided the rest of the examples. So just to make a point that why do we have a domain called architecture and design was initially to give us shelter, to allow us to live comfortably as a group, as a settlement, and protect us from nature. Slowly we became more innovative, creative, and then how much we could beat, make it bigger, make it higher, taller, became our ambition. So the more innovations we did, the more creative we became, and for us the achievements became, or the landmarks of architecture became, that we should build better, bigger, larger, higher, taller. So all those tallest building in the world, those became our benchmarks. But today when we are looking at the world scenario, our habitat, our life, our health, since this profession was meant to make living a better place, I think we have to refocus our agenda in architecture towards how can we make it a better living place and how it can be more sustainable. So this is the orientation of architecture and architects towards sustainable development goals rather than technological innovations and creativity. Next. Oh, sorry. Yeah. This one? Okay. So this is repetition of Sir, but I think they became my guidelines of establishing limits. This word to word from his, identifying threats and opportunities, improving quality of life. So if I rephrase it in architectural terms, how much to build, how much to consume energy, how much of resources of water and electricity you want to use. So we establish limits. Where to build, how much to build. Second is threats and opportunity. Are we in a eco-sensitive zones? Are we building in the right place? Are we hampering some kind of processes in nature? So all these, and opportunities also will be there in nature which we could use it to enhance the building. Quality of life. Many a times the focus, like I said, was technology in architecture, or using the latest material, building dynamic looking forms. But if we focus on quality of life, we will be more interested in making it more healthy, more, like we know that natural ventilation is better than AC. So can we reduce the use of air conditioning? Can we reduce the use of artificial lights? It's been proved that the cyclodean theory, that if we are in an environment of artificial light 24/7, you'll have physiological impact and your cycles of the body get disturbed. So when we are looking at health, automatically being as close to nature becomes fundamental. Now identifying environmentally sound technologies and policies. So instead of focusing on the latest, the tallest, or the most fastest, now the fast I am going to highlight later, that we consider whatever is fast is the best, but it's not true. So we have to look at what is environmentally strong while choosing the technology, not necessarily the fastest. And of course, improving or at least conserving, using as minimal as possible all the resources. So after that, can I use the key? Can I use the keyboard? It's not working. Yeah. Yeah, okay. So now again, when I talk about equity and preservation, when we say seashore, there was this tourism development plan that resorts should be allowed. I said seashore is already allowed for public use activities for every income group. When we give it to resort, it becomes exclusive to a certain income group. So are we really encouraging tourism, or we are catering to the needs of certain exclusive class? When we expand roads and flyovers, we are encouraging private car vehicles movement. The tax of the country are going on public infrastructure which is not catering to all income groups. Are we increasing public transport? Are we widening the pedestrian streets? So where is the investment going? Any decision we take, is it equity? Is it distribution of natural resources equally? 24-hour supply goes to the higher income group. Do the lower income group area housing get the same water supply and electricity? So natural resources equal to all and should be distributed equally to all. Now ecosystems, I think the natural one all of you are familiar. The man-made ones need to come as close to the natural ones. Actually, we are doing these ecosystems within this framework. So this is what architects need to be aware of, that this is existing and we are going to put our ecosystems of housing settlements in this natural ecosystem, and how much can we adapt ourselves to suit that ecosystem. Of course, you know all this, which is very crucial to maintain the balance in nature, and we also know that there are 4 cycles. Now when I talk to architects, I go more into detail, but I think here my position is this 2 cycles, that is water and carbon, is very crucial for architects to understand, because when it comes to percolation, we are the main barriers in terms of amount of concretization or runoff, increase of runoff that we are doing, and that's leading to flooding and other problems of lack of groundwater recharge. So whenever we do a project, the amount of percolation and the amount of tree cover will ensure the balance of water cycle and how much we can conserve it. Next is carbon footprint. Of course, the main thing will be the energy consumption. Now, built environment is responsible for 30% of world energy consumption and another 20% for transportation, which also combines planning and the built environment. So that means almost 50% of world energy consumption can be impacted with improving our built environment. So in this scenario, the built environment would include the type of materials we select, the type of building form that we select, the type of spaces and the maintenance that we design for it. So a lot of such and of course orientation, there are many other aspects which I will get into. All that will impact the carbon footprint and the energy consumption. So just to give you an idea that from 1750 to 22, the population, if you see, the highest is China, India, Africa, but energy consumption, carbon footprint is highest of USA and Europe, and next comes China. So whenever we give examples of infrastructure development best practices, we give the example of Europe, US and China, but look at their carbon footprint. So are we going to define development in that way? So the best bridges, the best buildings usually are shown in magazines in this way, these examples. However, when what Sir also mentioned, this copy-paste culture is also going to copy the carbon footprint. So what we need to do is understand it scientifically and see whether it's appropriate in terms of sustainability and use the technology very appropriately or suitable for the setting. Now, through my various experiments with environment and reading certain texts in Indian philosophy, I felt that we can look at context. Like I said, we have to do context-based development. So how do we understand context will define how sustainable it is. So first is every physical layer, that is the geological layer, the natural layer which is given to us. We cannot change and it is very essential to remain, make it a balance. I call it the kshetra. Next is the history, because many of Indian soil has living heritage which is more sustainable than the modern technologies. Living heritage I emphasize because they have passed the test of time and they have managed the resources in a much better manner. We don't have ghost towns, we don't have our water source disappearing in our traditional towns. Whereas in the modern towns we have lot of issues of water as well as pollution. So learning lessons from our older towns on how they manage the infrastructure and the resources would give us clues what is appropriate for that land, because I have seen living examples all parts of India, means for every landform ecosystem there are examples of living heritage. Next comes the man-made conditions of political boundaries and so on, which we have to consider whether we like it or not, on how man has defined the systems of governance, of distribution of facilities, of laws and so on. And finally, the aspirations of people in terms of what kind of profession they want to go to, what kind of lifestyle they want, and how much can we satisfy that. So I'm going to demonstrate now quickly examples on how these sustainable goals have been used as guidelines to benchmark good architecture. Now I would like to repeat, the focus is shifting from how good architecture should be judged. So first I made them, like I said, we have living heritage. We were partially in online mode, so my students were spread all over India. I asked them to document one vernacular architecture building with the fittings and document the orientation and the U value and energy performance, And finally, when they came back middle of the semester to in-person classroom, we did the design exercise. So one of the students in Hyderabad documented a temple. So if you see a semi-open space, which is a veranda element, which is there in many of our vernacular typologies, it uses minimum energy for the building itself because material required to construct is reduced. Second is the amount of energy used, especially in hot and humid, where the air is cool, to maintain comfort condition. This is the best form. You don't need any energy to, you don't even need fans sometimes to create a comfort condition in this typology. Next is that for certain activities like public places, you don't need walls and enclosures. Gatherings and get-togethers. Why I say it is that this typology for public places would reduce the energy. Instead of malls, which is so enclosed, we could have public infrastructure for public gathering in this typology, which uses, I will get into the psychometric chart, which defines the comfort condition as per the temperature, as per longitude, latitude, and the sun path diagram. I won't get into details, but basically that tells, and this is the U value, like traditional materials, this is amount of heat transferred from outside to inside. So if inside is higher temperature, less humidity, you will be very uncomfortable, and if it is lower temperature or at least keeping it minimum, then your U value is less. So we did it, how much wall surface is there in which orientation and how much heat is transmitted in each orientation, number of fittings, number of hours that it is used for, and the energy consumption is as low as 22 kilowatts hour per meter square per year. That's the energy. Compare it to any public gathering place of modern technology, and it would go as high as 450 to 500 kilowatt hour per meter square per year. So the difference is huge when we enclose an air conditioner space. Now this is a house again in Bihar, which was made in vernacular typology with the open veranda. Now here when you see vernacular, 50% to 70% of your daytime activity is in semi-open or open spaces. That again conserves a lot of energy because you don't have to build it, hence you don't have to spend energy to maintain it or make the comfort condition. But the buildings around create the comfort conditions for those open spaces. So here we have bamboo and mud wall combination for the structure, and the U value was calculated for it, or in each orientation how much heat was transmitted and what were the fittings and how much energy. So because this is used day and night, and like I said, a living space has more enclosure compared to a veranda, in a household 106. So this is the performance of a vernacular traditional architecture. And this was the range of, I had students from all over the country, so this is the range of energy performance of vernacular architecture. Semi-open 20 to 30 and enclosed 106. Whereas in a city you would not find anything less than 250 to 300. Even the green building, platinum rated buildings use 250 to 300 kilowatt hours. Now this is the site we gave them. They did the documentation of the local, the indigenous species, the terrain, the user group study. I am not showing everything. This is 30% of the work that they have done. However, what I want you to see is they did multiple options and looked at shadow patterns to see that the open spaces are comfortable. Also the size of open space and how the orientation. So morning and evening hours, if the open spaces have shadows, it can be used for various activities. Also the amount of tarred road, following the norms of fire and all those things, how it can be reduced, how you can minimize the paved area in this site. So keeping all those in consideration, the options were evaluated for natural ventilation, natural lighting, connectivity, noise levels and circulation. And I am skipping a lot of steps and going directly to landscape, where if you see the building, a lot of small punctures are there because a big mass of building without courtyards opening would trap the heat and energy consumption will go high. So, and also this is a place of outskirts of Mysore, the village, the Gram Panchayat. So, here we wanted the rain not coming into the usable spaces. So, the veranda semi-open spaces became the activity area and the open spaces became the ventilation and lighting areas. However, in drier areas we can use the shadow to make the activity areas also. And we have play areas also, semi-open spaces and sheltered. So, the orientation of building was made to see that less of solar heat gain was there inside the building. Also the open spaces were sheltered and the shadow, the landscape was used with indigenous species. Also certain things like wastewater, could it be treated with banana or some plants which could digest wastewater was also tried on. And of course rainwater harvesting tanks with capacity calculation was done. So all this became integrated into the design. It could be made use as a form, it can be made use as a attractive element. And yes, the landscape was insisted that you have to identify the species. It's not enough, most of our architects just make green circles without knowing the species. I am sure if any architect is here, they will know that, but we insisted that they know which species and how big they grow and what are their conditions required, only then they can propose it in the design. And of course, the hard paved, whichever little they needed, were made, they were as close to natural material as possible, also pervious as possible so that they allow percolation. And certain passive design systems, that means once you construct it, automatically the energy loads go down without the need for continuously using electricity. So double layered roof, the use of courtyard for ventilation, the porous bricks, double stone wall with a porous infill. So all these reduce the heat gain into the building. And this building after design uses around 120, if I am not mistaken, around 100, which came very close to the vernacular architecture. So even very contemporary looking building, if we follow the rules of vernacular architecture and the material, we could reduce the energy consumption. Now, can you press the link? Sorry. We did an overall study of Manipal for its stormwater management. I'll just, the link is not working. Can I pause this and go to the other presentation? This one. Here, this one. Please, can you see the screen? This one. Yeah. I'll quickly run, the link didn't work, sorry. Yeah, go to PowerPoint show. One sec, yeah, thank you. So, this is one of the 5 groups. There was another group doing on green cover as well as infrastructure development, social infrastructure, and finally the projects. But I am just showing one blue infrastructure group master plan where the climate rainfall was studied, the way the topography and the water drainage pattern was understood, and how existing water body and low-lying areas were studied, and how the roads were along the topography, and the existing situation of drains in the city was studied, and whether they had the capacity to take the water. Now, Manipal lies on the hill, but nowadays Udupi is getting flooded due to increase in the developed area. So, if we start reducing the runoff at Manipal, the low-lying areas around will not get the problem of flooding. So, and also Manipal faces water shortage in spite of receiving 4,000 mm rainfall per year. So, it is total mismanagement of water basically. So, what we said was, this is the route going to the river from Manipal, and these are the holding points, low-lying areas, and we thought we will use the roads and the water bodies to, and the policies at private properties to make the groundwater recharge better. So, this was the calculation of existing runoff and how bioswale and permeable pavers increase the population. Also, the problem is Manipal is a laterite hill. So, everywhere, even if it is natural soil, the percolation will not be very high. So, what we thought is existing water bodies and existing drains we will concentrate to increase the percolation, because there would be routes already made to enhance the percolation. Okay, so I will not get into the total design part of it, but basically at every place how we could improve the water quality was explored. Now, when we get into the individual designs, with this background and understanding of the context, one open space play area was designed. Like I said, even in a city level, if open space work well, you do not need enclosed space for human recreational activity. So, all the recreation, if it is done in open spaces, we will reduce the energy consumption of the city also. So, having a cup of coffee in a park is as good as having it in Coffee Day. So, so we thought, how can we improve the open spaces, make it more safe, how child friendly. This was some of the observations of very hard edges, which was not good for children because they could get hurt, lack of segregation of play area between very small children to medium aged children, and lot of problems of unutilized spaces. So, with all this, the strategy was to increase water infiltration capacity, because we had identified it in the master plan, and to increase the green edges. We thought we will increase the soft edges instead of hard edges. So, we created for small children this earth berm with the some mounds where parents could sit with these kids and play rather than go into the park. Sandpit, which is normally considered okay, and we saw how the percolation of could be increased with that. Also, for middle-aged group children, we use the mechanical system to generate electricity, so that the lighting of it would be as long as stored from the play of the children, and amount of energy generated was calculated. Similarly, the seating area for old age, youngsters, adults and old age people with small children going on cycles or tricycles, we kept some sonar trees and normal trees for shade, because shade was lacking in the previous design. So, here also the amount of energy generated and amount of greenery increased was calculated. Similarly, the water harvesting was done to give facilities like car wash. This was in a residential area, and how it could become a place to be in rather than go for a built up area. I think we all know what lakes does, so we won't get into it, but as an architect, when we look at lake, we did the sections and the existing, this is already a used space for various activity, but along with this is where normally architects end. We also documented the species, the migratory birds and their patterns, how many come and when they come, and we said that only 30% of the lake edge would go for human activity, rest would go for the natural landscape, and human activity won't be encouraged throughout the lake. So we of course gave a lot of other recommendation of stabilizing the slopes, of what kind of plants should be there in which position. I won't get into it. Here again, in a 5-star hotel, a resort, we studied the vernacular architecture and their performance and used it to define the open spaces for various activities. So what I meant is, even a very high-end building could look at the same principles which I was talking in the first project. So here also the built space is made minimal, the open space is used for multiple activities, and orientation and the configuration would define the comfort levels. Now other aims could also be reducing vulnerability in the coast. So this is the normal geosciences method of showing the risk assessment of the coast. I won't get into details of this, and you can see that the houses are highly vulnerable in terms of physical infrastructure. They had a lot of saline water problem, that is salination had taken place of their groundwater, and none of the protective systems were there to conserve their natural resources. They were very vulnerable to cyclones and other natural disasters. But their physical and social rating was very high in terms of resilience. So what we thought is, how can we improve the physical resilience and the natural resilience of resource management, and how to stabilize their roof, how to create rainwater harvesting systems so that drinking water, and how they could produce some vegetables with composting, with roof garden, certain new typologies as well as refurbishing the existing typologies, both at cluster patterns were demonstrated. So this was for resilience building. Again, it was not for bigger, better or good looking buildings, it was to build the resilience of the cluster. This is again Thrissur, where new development was proposed in a wetland area, and this was already planned by the municipality, and you know Thrissur faced a lot of problems during 2019. This was exactly after that. So we said that if you really want to convert, we will look at what can be done. One is, we said that if possible avoid building it because it's a good agricultural land, but if you really want to convert, can you go this way where you create the paths of movement of water, and this much is required not only for that area but from the surrounding already built environment, and how it should be rooted as per the topography, and how it should be unlined, like you said, not paved, and this should be the form where there are buffer zones on either side, and the capacity. Now what happened is, because of flood, already the cost of flooding, like how much infrastructure was lost, was calculated. So we said, if you want to prevent flooding, if you invest so much, that cost of infrastructure loss can be balanced. So cost benefit analysis, we proved that disasters, if you avoid, how much you save if you invest in these practices. So we gave them phase wise development of how water management should be done, and how this ponds, there was one pond also suggested at the lowest point where they have already marked it for some truck parking area. So some projects we couldn't shift, but we said next to it at least make this pond so that flooding again could be prevented, and all these resources are from secondary resources. So it was some paper we referred, and we saw that it is valid for that area or that particular space, and then we recommended it, and this was the model proposed. Again, if you see, we have proposed only 30% of the land to be built. Now here again, this a very difficult project, I would say, because it's a built environment in Panjim. It has high polluted air due to coal mining already taking place around it, and the air quality is very bad. So she just had built spaces to intervene. So what she did is how she can increase the land area, how she can reduce the traffic, and how she could maintain more walkable environment was the, and of course stabilizing, increasing the sand dunes and stabilizing the water edge, making it more soft. So again,
last 3 minutes.
yeah, this is the last project. So this project was for tourism development in Diu. Diu is a town which is totally reliant on tourism for its income and economy, and in due to COVID, it lost 90% of its income, and also it was identified as smart city. So this waterfront development, we tried to make it improving quality of life and map it to sustainable development goals. It had lack of groundwater, it scored very low in groundwater management, very low in multiple economies. It has very high fish, fishing is done by outsiders from mainland, but the people of that place are not getting any income out of it. So we said we should encourage fishing as a profession or economy again, and encourage local crafts and cuisines which can be used for trade. So all this was mapped, including cleanliness, hygiene, improvement of water quality and groundwater management. So all this and protection of heritage, which the proposal of smart city was to erase the whole waterfront and build a totally hard edge with a lot of water sports and such things, but right in front of it is the breeding zone of the fishes. So we said that if we look at all factors which contribute to a good quality of life for people, what kind of development, and this is on the site, my student went and documented each and every activity, the status of the site, and then said how it could be improved based on those 3 goals and how it links to various sustainable development targets. I won't get into details, but this looked at social, water and drinking water, and improving the natural resource management. So out of the 13 projects proposed, I am going to highlight the water edge, which was made as a public recreation area for tourism, but soft edge, so that we increase the water, because the hard edge was already there in the existing design. We wanted to make the edges at least soft, and also in residential area we gave a pattern where composting, so better waste management could be done through organic waste composting, and only recyclable waste or non-biodegradable waste goes out of the building. And we also gave cost benefit analysis in terms of how much they spend on vegetables, because most of them are vegetarians. So also cost of rainwater harvesting, everything was accounted for, and a model was developed for housing. So I've just tried to show in every type of project, be it large scale, small scale, how SDGs can become the focus of that design, and how decisions of good design can be made based on that. Thank you.
1 or 2 quick questions.
Hello ma'am. Ma'am, you talked about creating open spaces in the building structures, how it was done in the previous times, but how can we implement that in the urban areas because of the increase in population, shortage of space and immigrants?
I'll give you a very simple example. You know New York City, which has the maximum number of skyscrapers, right? Yes, so if you go for courtyard typology, with the same carpet area, you can have the same built up area with 9-storied buildings. What happens is, when you grow taller, you have to go smaller. You have to give the setback for natural ventilation and fire requirements. So when you grow taller, you're not building more. You're leaving more space on the outside. The problem with that is a thin strip of land. See, the same land, if it is in the center, it becomes more usable. But when it's on the periphery, they don't have privacy. They become leftover spaces for parking or some activity which is for outside, not for the inhabitants. So we have done this calculation and demonstrated. The same carpet area of 102-storied building, if the open space was on the inside, can be fitted, because you get more area to build on the periphery. You understand?
Yes, ma'am.
So the amount of built up area is the same, only the number of stories have changed. So it's nothing to do with population exposure. The typologies and the technologies, if the intention was not to go taller and fantastic, but more to do with natural ventilation and lighting, we can come up with better typologies.
Yes, ma'am, I have a question. Like you talked about increasing the number of stories instead of occupying more space. So
no, I said if we go for courtyard typologies, that is open space in the center instead of periphery, we can accommodate the same amount of area in lesser number of height.
Okay, so the opposite of it.
Yeah.
Thank you, ma'am.
Yeah.
Ma'am, I want for the energy calculations, I wanted to ask what were the references used for unit values?
See, one is we use the software of Design Builder, and we gave the input from there. We also had one faculty of mine, Pranav Kishore, who had this Excel sheet where we fed the area of the building and U value, which gave us the heat this thing. So we used two methods and came up with the energy calculation. One was Design Builder and this Excel sheet.
Ma'am, for my energy calculations, I have used ECBC.
ECBC gives you U value, but when
yes.
you want with orientation and the whole thing, it's a code. ECBC is more of a code where to meet the code, what material to select and how to make decisions, it helps to an extent. But if you want the performance evaluation, you need to use software like Design. I am not an expert, but I can tell you that Rhino is also used with the
it uses Energy Plus simulations.
Energy Plus now I think has become too expensive, but Rhino with one more add-on is there. You will get all right from lighting, wind. Actually, another story, I didn't include all the projects for wind, lighting, performance and thermal performance. All three you can get very accurate data for cluster of building at site level also.
Ma'am, was also special publication 41 BIS used general requirements for functional buildings.
I am not aware of that, but we have for large scale, say city level thing, ENVI MET. ENVI MET again gives wind pattern at sector level, city level and thermal performance at city. So when you want large scale built environment where you are not worried about specifics inside the building, then you can go for ENVI MET.
Thank you, ma'am.
Yeah. Thank you very much. Thank you, sir.
Thank you, Professor Deepika. I now invite Professor MNV Prasad sir for his presentation.
Thank you very much. I thank Dr. TVR for giving me the opportunity and also the organizing team. This is my third time I am participating in the lake. Since it is a lake conference, I would like to spend the 30 minutes, although I am late. The conservation of aquatic resources and ecosystem based adaptation of climate change. Since there are many students, climate change is a buzzword in the contemporary time, but climate has changed in the geologic past several times. There is an interesting phenomenon suggested that we are facing the 6th mass extinction. That means 5 mass extinctions have already taken place and we have physical evidences. Like some of you kids must have seen Jurassic Park, the dinosaurs have extincted. Like that, the climate change, those days also climate has changed, it is in a different way, it may be a glaciation or it may be radiation fallout or it may be a sudden temperature rise and so on. But what we are now concerned is global warming and shortage of water, pollution, and this is what is our concept of climate change, resource crunch and so on. Now, I made a mind map of climate change and you will see so many words: urban environmental pollution, ecosystem based adaptation, aquatic resources, depletion of water resources, agricultural loss. For example, in many African countries, they will not be able to do agriculture because of shortage of water. It is not only water shortage, but quality of the air, pandemics, diseases, human health, and the technological adversities like plastics, Professor Ramaswamy has mentioned, and conglomerations, city expansions, mega cities. So these are all contribute to the climate change. I am showing this because I worked in Hyderabad 35 years in Central University. There is a huge lake. Many of you have visited Hyderabad. There is Hussain Sagar, and this lake has no use. We cannot use the water for domestic purpose. Then what is the use of such a huge water body? To the best of my knowledge, when you are flying on the lake, you will enjoy is a beautiful spot, or from the periphery, the people who have apartments. Only the railways they use during summer carry water by tankers and wash their railway wagons. Otherwise, we can't use this water for domestic waste. Reason is all the industries have discharged their waste over a period of a time. And now we can't use it for domestic purpose. The government had a brilliant idea for any kind of environmental program. Unless government support, we cannot be successful, whether it is a solid waste management or whether it is a wastewater management or pollution, curbing pollution, any such thing, government has to support. Otherwise, the rules and regulations, Air Act, Water Act, soil conservation, everything will be on paper, record, but people will act the way they like. So they will not help us. Now in 2009, the Andhra Pradesh government, at that time is a combined state, they floated a global quotation for cleaning up of the Hussain Sagar lake, global tender, but that was not successful. No one came forward because there were many technical queries on that. It will be cleaned up, but then who will maintain surveillance, and so many factors were there, and the budget. So the matter closed. The lake could not be cleaned. And then the regular problem, periodic problem is every year after Ganesh Puja, lot of debris is discarded in the water body. That is another problem. 1 year estimate was 1300 metric tons of garbage on a one day is dumped. It has all toxic materials, plastic materials, and so many things, lead based paints, etc. Now we can't stop it unless the government is involved and common man is well educated. So these are all the sustainable development goals. All students should know. There are 17 sustainable development goals. Number 4 is quality education, environmental education, particularly high quality environmental education must be implemented, and also in different models, infusion model and diffusion model. Infusion model, that means specialized training, because environmental science in India is very young according to me. We have environmental ministry only in 1985 in India. Before that, we never talked about environment. After 1985, university started, environmental education started, environmental science and so on. So quality education is very important. Like you have here different streams, so many programs. I am thrilled to see so many posters from your group, from Dr. TVR group, and from Center for Ecological Sciences. The United Nations 1992, this is the landmark conference, Rio de Janeiro conference, Earth Summit, and that has the recommendations are, one is on CBD, you might have heard in many lectures, Convention on Biological Diversity, then UNFCCC, that is climate change, Convention on Climate Change. First time all governments woke up and then they started talking about climate change in 1992. Before that also we never bothered, but today it is a big subject. November 6th to 18th in Egypt, COP27 was held, and there were so many recommendations. It was an annual conference. Next year it is going to take place in UAE, and what type of things we have to adopt in a country, including sustainable development goals and climate change and so on. So, lot of insecurities, not only for water insecurity, but we have several problems associated: nutritional insecurity, food shortage, food insecurity, energy insecurity, and environmental insecurity. You have seen nutritional insecurity is iodine deficiency, thyroid, iodine disorder, iodine deficiency disorder. Men and women suffer. So, that means the food that we consume is deficient in certain micronutrients. Now, weather disaster, there is a very interesting paper 2012. In 2011, United States suffered almost a dozen of weather disasters. Each disaster economic loss is more than $1 billion. So, not only United States, but there are many other countries. Luckily, India is not figuring. Pakistan figured, United States, and you can see UK, Australia, and some of the Arabian countries, European countries. Almost every country, all the developed countries have suffered the weather disasters. Now, you can see in the global map, all those red spots are temperature rise, climate change, blue spots are heavy rain and floods, and so on. India is free from, we haven't, we are safe. That is why the sustainable science, sustainable development goal started, everybody, every educational institution is talking about. Now, if you look into the history of sustainable science, sustainability is not a new word. The word was used in 1713 in the field of forestry. Later, industrialization took place, lot of UK and all other countries. Then there was a World Commission on Environment Development, that is what is called Burnt Land Commission, 1984. Then the 72 was Stockholm Conference, that was a landmark conference. After that conference, the Indian Prime Minister attended that conference. After that, in India, the Department of Environment and Ministry of Environment started functioning in India from 1985 onwards. Prior to that, we have only Defense Ministry, Agricultural Ministry, and so on. And then 2015 was United Nations Development Goals, Sustainable Development Goals. 2019, there is a European Green Deal strategy. So, the Green Deal has several important components. That is a very ambitious program. Within 30 years, that is by 2050, they want to achieve all the problems that we talked about. Solve the problems of microplastics, solve the problem of emissions, decarbonization, water shortage, health for all, and so on, including all the smart cities, ultra infrastructure of urban systems, and so on. Now, India, if you take Meghalaya, receives highest rainfall. My beginning of the career, I am retired now, but my beginning, first appointment was in Meghalaya, that was in 80. Highest rainfall recorded was in 1974, 24,555 millimeters annual rainfall. But we have water shortage, we do not have drinking water in many places. So, they boast, if you go to that border, Bangladesh-India border, there is a huge signboard, that is the wettest place on planet Earth, highest rainfall receiving area, that is the border of Meghalaya and Bangladesh, a place called Masinram and Peninsula. The paradoxical situation is that every year we have floods in different parts of the country. For example, you can see quickly, lot of every year, Hyderabad is washed out, several hundreds of cars are washed out last year. Similarly, Bangalore, Chennai, Bombay, all major cities. So, we have water shortage and we have heavy floods, but we need an action plan. How do you avoid this kind of situation, or harvest water, sustainable urban drainage system, reuse them, treat them and reuse them. So, most of the roads are flowing canals. So, wastewater treatment from the urban flood water, we do not have an action plan in many of the cities because of lack of groundwater drainage system and so on. But certain European systems are successfully using the groundwater, harvest groundwater, treat them and use them. Probably the population size, in India we have the population is the major problem. Now there are technologies on plant based systems, they do give ecosystem service and say for example, I have given only 3 examples here. Wetland plants, a group of plants, they grow well, they produce high biomass, they can be used for treatment of mercury toxic waste, cyanide coming from the industries. For example, gold industry cannot avoid cyanide, using cyanide, and also the mining industry. These are all the macrophytes. You can see these macrophytes. Yesterday you have heard Professor Shankar Rao's lecture on Indian flora. We have high biomass producing aquatic macrophytes. A classic example is Eichhornia. Eichhornia, only the problem with these macrophytes is management is required, otherwise they become invasive, they spread to the other irrigation channels. And duckweeds, for example, they are the excellent material for dealing with climate change and carbon sequestration. So, these are all the examples how the aquatic plants treat the toxic waste that we discard either in the water or canals or wastewater leachates, both organic and inorganic. You can see here in this case inorganic, and in the other side of the panel is organic waste degradation or volatilizations. So, in the literature it is documented very well, plant based technologies for cleanup. Now, why plant based technology? Already we all know about biotechnology. Biotechnology of plants should suffice, but phytotechnology means here not only cleaning up the contaminated substrate, whether it is a soil or a water, but it should give us an additional product like an energy or a byproduct. That is phytotechnology. So, cleanup is the one of the objective. In addition to cleanup, the process also should give us an additional product like energy or other material, other composite materials. Now, many experiments are conducted with a plant like Ceratophyllum, which is very common in wastewaters. People maintain aquarium in house, fish tanks. So, they introduce, and we have done a lot of experiment students for various, I will not go into the detail. So, one of the technology developed in India using macrophytes, we have so many processes for wastewater treatment, activated sludge and stabilization pond or rotating biological reactors, oxidation pond, fluidized bed and so on. These are all wastewater treatment technologies. But Karnal is a place in Haryana, they have developed a technology using macrophytes, high biomass producing macrophytes. This is the cross section of the Karnal technology, where there are ridges and furrows, wastewater, sewage water is let off, and then you have plants, some of them are ornamentals like Kenna, you can see, and then microbes in the root zone system, and they treat, and the treated water is released for irrigation purpose. So, this is a very famous technology developed in India, that is what is called Karnal technology. Now, it is not only the water treatment, but the sludge is also very important. Lot of materials can be generated from sludge, including energy and with several byproducts. Is another area, because this is mostly water, aquatic resources, so I will not go into the detail. But in India, I want to show some of the giant industries. A national aluminium company, Asia's biggest aluminium smelter in India, located in Orissa, they use for treatment of wastewater coming from their industry using macrophytes that I have shown in one of the slide pie diagram, Eichhornia, Pistia and so on. So, all the they have a huge power plant, captive power plant plus smelter, the bauxite smelter. So, toxic waste coming from those sites is treated in the constructed wetlands. So, all you have here it is duckweeds, lemna, typha and so on. So, this is how in the laboratory experiments for students like the gold processing, that is cyanide leaching. Eichhornia is very efficient for degradation because it has an enzyme for detoxification, some enzymes, it has enzyme. Also salix, many plant enzymes can degrade. So, and biomass is also tested in these digesters for gas. These are all Indian shots, what is called canna, which is very important. It is used in large scale for decolorization of dye industry effluents. These tiny plants are the smallest angiosperms, lemna, wolffia, spirodela and so on. They are very important for example, in carbon sequestration, and also they accumulate nutrients. As you can see, people eat if they are grown in a clean water, but if they are grown in a contaminated water, they cannot be consumed or they cannot be recommended for animals. But there are also ways of bioabsorption, taking away the toxic component, take the extract, nutritious extract and use. So, there are biofertilizers produced from the macrophytes growing in a sewage water. These are all azolas in waste in rice paddies. There are different species, 2 species. Azolla is very important nitrogen fertilizer. It provides for rice paddies. You can see it is a very simple technique, very commonly practiced in Andhra Pradesh, Krishna, Godavari districts. So, the term ecosystem based disaster risk reduction, this was introduced in the CBD CBD was introduced in 1992 in Earth Summit. We have so many models, concepts, nature based solution is one, EBA adaptation, urban labs and coastal living cities. So many concepts are coming because we are now facing so many perils of climate change, floods and so on. The nature based solutions, take for example agricultural effluent. These are the kinds of benefits the nature based solutions to treat agriculture effluents, because agriculture demands a lot of fertilizers, pesticides and so on. If there are large area or sometimes plantation crops, so many types of agrochemicals they use, all the effluents have so many contaminants, toxic contaminants. We have so many example sites in India, highly contaminated sites. So, that is one of the classic example of nature based solutions for the problems. Now, that is the sustainable development goal on the left hand side, right hand side is the European Green Deal, but there is a commonality. See, both are very ambitious programs. 2050 European Green Deal wants to achieve all these 8 programs, where in sustainable development goals also there are 17 sustainable development goals. For example, if we take no poverty and zero hunger and so on, here also zero pollution ambition, and then farm to fork, that means the food that we harvest from the field should be free from contaminants. So, terminology is slightly different, but the overall matrix is the same between Green Deal and sustainable development goal. Now, this is the slide which I want to pay attention, which Professor Ramaswamy talked and all others have talked. European Union proposed one mission, what is called Mission Starfish. By 2030, these are the ambitious programs. Now, filling the knowledge gaps, regenerating the marine and freshwater ecosystems, decarbonizing the oceans and seas, revamping governance. This is very difficult in an Indian situation. We cannot change the norms, whether it is urbanization or transportation or emissions, whatever sector it is. And zero pollution, net zero. See, one of the buzzword of the COP27 is RTZ, zero transmission, which is impossible. Zero transmission can we achieve in our situation, but this is ambitious plan of the European Union. By 2050 they want to achieve through Mission Starfish. There are many documents and so on, and this is built superimposed on circular economy, from the waste, regenerating the useful material from the waste, and zero emissions and zero waste. Thank you very much. I now stop here. Thank you for your patient hearing.
We can take one or two questions.
Very inspiring, and in fact these were the things we need in terms of management of waste, and like you said, achieving SDGs, but also my concern is resource access to resources and classification. Like, say I am not from the domain area of environment science, and I want to use the understanding
infrastructure. Architecture is one of the major
infrastructure.
Urban
So
infrastructure.
when I say I was choosing the plant material for phytoremediation, I was proposing, but I don't know which is the right one. So if there was some repository which gives me those recommendations without making a mistake, because that would have been very useful for us.
We have two models of education. One is a diffusion model, the second one is infusion model. Say for example, all my decades spent using plants and dealing with pollution and so on, but I don't know anything about the architecture or other aspects of it.
Okay.
So, but it is available in the literature. Many are freely available. I myself have written one book for the Ministry of Environment on remediation of contaminated sites. You can download. It gives some preliminary information, but more advanced lot of information is available in the books. You want to deal with, for example, PFAS, they are forever chemicals, which we don't talk now in India about it. Huge volumes of literature is available, and they are there. There are so many types of carbon chemistry, etc.
I think I need to build a library and make a resource, at least in the institutes of.
Yes. So thank you very much. Thank you, Dr. TVR, for giving me this opportunity. I enjoyed this conference.
Okay, thank you.
Thank you, sir.
Okay, we will move to the next session. So we will have tea break later. Okay. So I think I request J.R. Rao to coordinate the session with Prasanna. Prasanna. So Akshay has. So what we will do is, J.R. Rao, you try to finish 2 presentations before 5 o'clock, or 1 presentation. I think after 2 presentations we will take a break. Okay. So it's not necessarily 5, even 5:15 is okay. What is the time I have given? Half an hour for each. Okay, you can do that. Yeah. Please, you have given your material? Okay. Because some of the people told me the lunch was so heavy, they said that why don't you postpone the tea?
So nearly 8 speakers here, and I request Dr. Akshay Chakravarti, please.
The students here, there are many surveillance cameras in the campus, including within the hall and outside. So if you have gone outside, don't think that we will not know. We will know, because I saw a bunch of youngsters sitting there and chatting in the outside when there was an interesting lecture of Professor Prasad was happening here. See, these lectures were organized mainly for you people, youngsters. You have come here, otherwise some other student from some other part of the country would have come. So you should take advantage of that.
This is the button, this is forward. Yeah, not required, but since you insist, many people they insist. Okay. So, respected participants, young biologists, the impact of climate change is the greatest challenge that we are facing today. Wetlands are no exception. Wetlands are vulnerable to climate change. They are highly sensitive. And when we say wetlands, we cannot confine our discussion only to wetlands, because wetlands are a part of the planet Earth. So, the communities of wetlands do interact with terrestrial communities, and there are cycles of nutrients, there are cycles of gases, which encompass all the habitats globally. So, therefore, for the purpose of discussion, we may confine ourselves to arthropods, but in aquatic system also, apart from arthropods, we have a whole lot of other organisms, like we have fishes, like we have the ciliates, like we have the microbes, and there are so many other biotic and abiotic components with which all the biotic communities interact. So, the thing is that wetlands and climate change, they are very closely related. And you may ask me a question, a basic question, why we need to give importance or emphasize wetlands. Friends, we know that 1/3 of the carbon sequestration is done by seas and oceans. The other 1/3 of sequestration or carbon reduction is done by the forests. So, it is very important that we preserve these two kind of habitats, and if we preserve these two kind of habitats, the other habitats get automatically conserved. So, that is why the oceans, the seas, the wetlands are important. Secondly, in this changing climatic conditions, the global gases, wetlands are the habitats that cool the earth. So, this is also very important, because we need to have some natural resilience of cooling down the earth's surface, and this is performed majorly by the wetlands, obviously because of the water. So, the water dependent ecosystems are very vulnerable to the climate change, and the communities which also inhabit these wetlands also are vulnerable to the changing climatic conditions, because they have very less resilience power to the changing environmental conditions. Now, one of the most obvious result of climate change is the rising sea levels. The water levels, they rise in the wetlands, and as a result what happens, the wetland gets contracted, the wetland gets constant, the water flow gets restricted. So, these are some of the changes that occur with sea level rise and storm surge. Now, storm surge is also very important, because all the benthic communities are not well adapted to the conditions which are improvised by the storm surge. And so, it is very important that we value the wetlands
but do not use them as dumping yards. So, you must be knowing that in most of the urban towns and cities, what we are and how we are abusing these wetlands, and it is very timely that sir has taken this initiative from past so many decades to emphasize the need to conserve the wetlands and make them sustainable ecosystems. Now, these the important species of wetlands also should be recognized. Now, it is very pertinent, and it is being very heartening that recently the global organizations have recognized 47 Ramsar sites as important in India. So, earlier few years back this was not the position, but today we are happy to say that we have 47 Ramsar sites, and the latest one came from UP. So, it has also been added. So, the people in India are becoming aware of the importance and the need to restore wetlands, including the 75, sir. Okay. Yes, sir. So, they have further increased. So, it is like that. So, that means we are recognizing the importance of wetlands. So, 75 is really a good number for a country like India. And the another important thing is the blue carbon. Now, what is blue carbon? So, we know that the carbon is black, but blue carbon is the carbon which is stored in the seas and the oceans. So, that is a term given to it, and it also plays a very important role in the sustenance of communities in the wetlands, including the oceans, the seas, and the coastal ecosystems. So, they play an important role in the adaptation, migration, and biodiversity conservation. Now, the aquatic arthropods are of two kinds, which are adapted to fresh water and those which are adapted to the saline water. So, their physiology, their behavior has different mechanisms, and their structures are different. Their morphology and anatomy and physiology is so developed and adapted that they get adapted to these two kinds of waters. And in both this kind of wetland ecosystems and the water, the anthropogenic pressure, that means the interventions of man has been very much felt in the freshwater wetlands. Okay. So, equally in saline like oceans and seas. So, the aquatic arthropods, it includes insects, it includes crabs, it includes prawns, it includes scorpions. So, they do inhabit the freshwater habitat, and they find an important component in the food chain. Now, this is especially very much needed for the higher taxa animals like the birds, like the fishes. So, these form as a prey for most of the higher taxa animals, and these arthropods are highly sensitive to temperature variations, because their niche requirements are highly specialized, whether it is in terms of substrate, whether it is in terms of completion of life cycle, whether it is in terms of resilience and adaptation. They are highly sensitive, and they do indicate the state of environment in these wetland ecosystems. And now, most of these arthropods, they undergo a lot of metamorphic changes, and these metamorphic changes are multi-stage, and one form of the arthropod does not resemble the other. Now, this is especially very much specialized in case of the insects, because insects forms the dominant group as far as aquatic arthropods are concerned, and they also have lot of turnover of energy and nutrients in the aquatic ecosystems. So, in order to maintain the functions of wetlands and balance, we need to conserve or maintain or sustain these arthropod communities in aquatic ecosystems. So, the changes which lead to the impacts on arthropod communities are so many. Okay. So, it may be in terms of physical, it may be in terms of biological, or it may be in terms of the chemical. So, they and these in turn affect the primary productivity like the aquatic plants, and this in turn affect the in numerous ways the arthropod aquatic community. Now, the aquatic arthropods are also indicators, the absence or presence are indicators of the health of the wetlands. So, this is one of the ways in which we can determine the status biologically of the health of the wetlands. So, the attributes such as the species richness, the species diversity, the vertical distribution, the horizontal distribution, okay, and the web food chains and food webs. So, these are all some of the parameters that we can document in order to know the arthropod communities under aquatic ecosystem. So, this is a simple flow chart that how the global warming is affecting the aquatic insects. Now, what are the major determinants in determining the species composition, distribution, and the structure and function of the arthropod communities, mainly the aquatic insects. Now, these are some of the aquatic major orders of insects. So, we have the stoneflies, we have the mayflies, we have the dragonflies, the damselflies, the odonatans, we have the trichoptera, we have the plecoptera. So, these are some of the orders of insects which inhabit aquatic habitats, and they are there have been some studies to determine their tolerance to climatic variations. So, some are moderately tolerable, some are less tolerable, and for some other groups of the aquatic insects, it is yet to be determined. And you know, they have also given the substrates they use, the rock beds, the boulders, the sand, the gravel, okay, and the riffles. So, these are some of the specialized niches the insects prefer in the wetlands. So, if you deprive them of some of these things, then most of the insects will not be able to survive. Now, one of the major determinants of the aquatic insects is the rich oxygen in water. So, if the oxygen level in the water is not sufficient, then most of these insects perish. Then aquatic insects, they also prefer food. Now, apart from the substrate, they need the specific food. So, if the specific food requirements are not there, so this is also one of the major determinants of the aquatic communities, especially the arthropods. So, changes in chemistry, changes in temperature, changes in their microhabitat conditions, they are very sensitive to these changes, and they do not survive if something is drastically changing in their habitats. Now, the arthropod communities also have their adaptation abilities and they also undergo a regular life cycle changes. Okay. So, each life cycle changes will have to bear with their restricted ecological niches, then their adaptability traits, and their adaptability to also overcome the adverse effects. Now, most of these insects, for example, they have a stage which is called as a pupal stage. So, this is the resting stage. So, where there will not be any physiological activity, active physiological activity. So, these are the stages which need certain requirements, certain microhabitat niches without which the arthropod communities will not be able to survive. So, the accelerated rate of human disturbance or intervention in aquatic ecosystems is gaining lot of importance. So, as you know, the trade and as you know, the ability or the anxiousness of the countries to share the waters, okay, the regions is also very much mounting in the Asia Pacific region, and many of the countries are vying for taking a lion's share, and the Himalayan region has also been considered highly vulnerable to these climatic conditions. So, the aquatic communities which are inhabiting these kind of habitats are also under great pressure. Now, so what are the mitigation measures? So, we have told some of the pressures that are impinging on the arthropod communities. Now, what are the mitigation measures? So, how to resolve this issue which is occurring at the global level, and what India can do in this context? These are some of the points. So, we need to identify those sensitive wetland areas which are prone to climate change. So, this will be one of our first task. Okay. So, how rapidly a wetland is changing, which is no longer able to support rich biodiversity of the aquatic communities. Then there need to be detailed investigation on the impacts of weather and climate events on water quality, because water quality is the ultimate and the basic parameter on which the aquatic communities sustain or inhabit the aquatic ecosystems, and there should be intensive explorations in fragmented regions because of the urbanization, because of the climate change, because of the alterations in forest structure and function. Most of these wetland habitats are getting fragmented. Habitat destruction and habitat fragmentation has been the second or the third most important factor impinging upon the aquatic communities. Then there also has to be studies on cryptic species. Cryptic species are those which have similar niche requirements and which appear physically to be similar, but physiologically they will be distinguishable. So, the assessment of aquatic arthropod community resilience, their adaptive capacity and respond to climate change has also to be determined. Now, in this direction we need to work and need to have a very holistic and comprehensive studies. Then the most important thing is that we may be focusing on aquatic arthropod communities. We need also to know what is happening to birds, what is happening to the mammalian species which are aquatic in nature, and we need to see that how their migration patterns are affected, because if the arthropod communities are adversely affected, definitely the birds, the fishes, the mammalian species will also be very much affected. And because of the rapid trade and the world is becoming smaller and smaller, the invasive species are also threatening the indigenous communities in aquatic ecosystems. So, this is a very important that we need to identify the invasive species, and we need to see that how their impacts can be regulated or lessened, especially on the indigenous species. Then the vector-borne diseases are also there. So, you know that how many kinds of human pandemics we are undergoing today. Okay. So, this all are vector-borne, and water plays a very important role in the transmission of these vector-borne diseases. Then the physiology and behavior of arthropods, their life history, their ecology and behavior need also to be studied in detail in order to understand the ecosystem services and functions which are provided by the arthropods. Now, these are some of the very important ecosystem services, the goods and the processes which are provided by arthropods. So, on the slide I illustrate the group of insect communities. So, when we see insect communities, we find that nearly 20% of the ecosystem services in the aquatic ecosystems is offered by the group called as the Hymenoptera, okay, and then by the Lepidoptera, and then by the Coleoptera. So, Hymenoptera means bees, Coleoptera means beetles, and Lepidoptera means butterflies and moths. So, these three orders of insects, they play a very important role in determining the balanced system of the aquatic ecosystems, and the other players are also there. Okay. So, apart from these three orders of insects, we have Hemiptera, we have bugs, then we have Blatodia, termites, then we have Isoptera, the termites. So, they also play a very critical role in supporting and sustaining the aquatic ecosystems. Now, these are some of the anthropogenic and climatic events that are detrimental to the arthropods, and their mechanisms, in what way they operate, the temperature, the precipitation, the snow melting, okay, the thawing of snow, the temperature of water, the chemistry of water. So, they all interplay in the sustenance of aquatic communities. So, these are some of the impacts especially on the arthropods. So, how they impact the arthropods. So, there may be a change in their sex ratio, there may be a change in their body size, there may be change in their metabolism, there may be a change in their ecology and behavior. So, these are some of the what you call mechanisms by which the climate change impacts the aquatic arthropods. So, this slide indicates how the range shifts occur, especially in aquatic communities. Now, these are all the different components in an ecosystem that matter for species distributions. Now, this has a very profound impacts on the arthropod communities and the species composition and their distribution, especially the climate change, the CN ratio, the CO2 and the other gaseous exchange. So, even the relationships, the parasitic, the mutualistic, the antagonistic, the symbiotic. So, all these kinds of relationships which the arthropods have within themselves and between other communities also get altered due to increased CO2 or due to the rising temperature. So, these are the other aspects. There will be a mismatch in most of their aspects in their life history patterns. So, in their physiology also it affects, and there are also a number of microorganisms which actually influence the life, the sustenance and their normal well-being. So, these microbial symbionts, what we call, are the gut microflora, what we call, or the endophytic organisms, what we call. So, these are the terms which are being used in different contexts. So, the microbial activity in the aquatic ecosystem also gets altered, and they in turn influence the other taxa, like the primary productivity of plants, aquatic plants, okay, the leachates that come out of the plants, whether they are metabolites, the digestive compounds, whether they are antioxidants, whether they are toxic substances. So, these are some of the things which occur with a change in the microbiology and microbial communities of the aquatic ecosystems. Thank you.
So, any questions? I can take one question.
Thank you. Sir, in Manipal, or this region where I come from, they've identified large number of species of butterflies and moths, moths especially. So, our campus and built areas are doing large-scale mosquito repellent fumes.
Okay.
And I think, as far as I know, I'm not seeing the species which I used to see every morning, especially moths in the corridors. So, is it true that they are killing the moths in a large scale? Is it very bad? And what would be your suggestion to control mosquito breeding in an alternate way, which will not harm the way you have explained?
Yeah, it's a very good question. Usually, the fumigants are used to drive away the mosquitoes, and we have a lot of gaseous repellents also. So, these fumigants and gaseous repellents, they will kill everything, madam. Especially the moths and butterflies are very sensitive to this. So, they cannot inhale oxygen, and naturally they suffer from high mortality. Now, there are volley of methods which are in practice to manage the mosquitoes menace. Now, number one is that we have very important two species of fishes, like Gambusia species, okay, and there is one more species. So, these two species of fishes, most of the mosquito larvae they devour, okay. Yeah, on the land what we can do, you can use very sparingly these fumigants, okay, especially during rainy season when the mosquitoes emerge, you know, the larvae and the pupae emerge and they go to the air, okay. Adults are airborne, but all other immature stages are waterborne. So, that time we can spray under the indoor conditions, but we have many physical methods also, like using the mosquito nets, using the when we sleep the nets, okay. So, and we have also plants which repel mosquitoes, for example neem, and this can be this neem baits or the neem candles can be prepared at home by any one of us. So, roads. Naturally, are you doing on a daily basis?
Once a week and in rainy season once a week and sometimes once in
Yeah. So, what I suggest is that you can increase the frequency of such fumigating the entire environment, number one, and number two, you can use biological and physical devices. Yeah, we can discuss during the tea time. There are many other methods I can tell you, and most of them can be made at home only, by the school premises. No need to purchase or bring outside. Okay, we can prepare number of plant baits So, when you burn them, the fumigants which emanate, they repel very strongly the mosquitoes away. I will tell you. Okay,
thank
yes,
you
sir.
very
Okay.
much.
Yes, sir.
Thank you, sir.
Thank you, sir.
So I request Dr. Srinivas Singh to
from your place.
Ellargu namaskara. I will be talking about two things. Wheat, Triticum estivum, Bodhi Gira.
Which one? Oh, okay. Yes.
It's in your pockets.
It's about selection, how to select.
I can bring this to you.
Okay. So it is a multi-criteria selection, and let me tell you the whole thing in story mode. One of my student from Bihar, he collected data on wheat, and he told me to analyze it, and he did not know what to do. So I analyzed that data, told him to write like this. Then he told me to write the formula. I am not from math background, but slowly I started reading and wrote this formula. So in wheat we have evaluated 40 varieties on 11 parameters, and using this formula we get a preference order of varieties. So we can recommend farmers that you can grow top few varieties, and on other government side we can tell government that you produce certified seeds of these varieties to give it to farmers. So wheat is a self-pollinated crop, hence you usually use pure line selection to make pure line varieties, or make many pure line varieties and mix a few top pure lines and make a multi-line variety. Or if you handle segregating generations in pedigree method, bulk or by class method, you get some variety and release. So selection is integral part of any plant breeding. If you have a lot of options, you have to do selection. Otherwise, if you don't have option, suppose only one variety, you will have to grow that only. So we plant breeders provide variety, many options to plant breeders, and there is a fight between plant varieties and its insect, pests and diseases, and we plant breeders fight from the side of varieties and develop new improved varieties. So while doing all these things, new ideas come, and we suggest new things, like you might have heard about Borlaug method of crossing in wheat. So, you cut florets of spikelets halfway and remove anthers and pollinate. But while doing all these things, I saw the drudgery of students. Then I suggested that you plant varieties in crisscross situation and synchronize the flowering fruiting, and whatever you want to make cross, you take 2 years, do that Borlaug method, cutting halfway, and don't remove anthers. Without emasculating, you just cover in a single enclosure, and you will get P1, P2, F1 and its reciprocal cross. So, that is what I expect. So, one student tried, but he could get only F1s, and that too he made a cross between black wheat developed by Nabi and many female varieties, 10 varieties of wheat. He got one all black F1s, and he got selected in NBRI event. He has taken seeds also with him. So, we could not plant F1 in our college. I suggested him to plant in pots in NBRI. So, while working only, you get new ideas. So, these are 40 varieties we evaluated on 11 parameters. So, this is a small experiment done by this Utkarsh Tiwari. So, small experiments we can handle in college. We do not have much facility. For bigger experiments, we tie up with NGOs or do at our own farms. So, this fellow can he was doing at his own farm also. Sometimes I put in my farm. So, after doing that exercise, I am recommending these top 5 varieties for cultivation. If we evaluate a large number of varieties, we can recommend more. With more varieties, you have ecological security. Otherwise, sometimes minor pests and diseases become major pests, and you see crop failures. In this example, you will see that kernel bunt in wheat, it is specific to kernel area, but now it is making inroads towards Gorakhpur, Devariya side, and out of 40 varieties screened, only 4 are resistant to kernel bunt, and there is ecological environmental predisposition during flowering time. In March, when it rains, when flowers open, then only kernel bunt develops, otherwise it won't develop in eastern UP. So, ideas about suitable genes to be looked for. So, from this kind of data, we can get idea of from where to look good genes to further improve the improved varieties. And usually we look for critical difference. Here in this selection method, we can think of improving bit by bit and many characters together, and we can expect a huge jump by improving many characters together. So, this crisscross planting I suggested, and last year we did it, but see, in experimental designs we follow replication, randomization and local control. There were 3 replications of 40 varieties, and data were taken from 5 plants. So, in each replication mean was taken, and these are mean of 3 replications. So, by using this formula, just see for selection you will have to develop some selection index, but see test weight is in gram, spike weight is in gram, yield is maybe in gram, spikes this is pure number. So, effective tillers pure number, plant height in centimeter. So, when parameters having different dimensions, they can't be added. So, you go for data transformation, and we did ranking. So, this is original data of average. In 2 tables, since there are 40 varieties, while presenting you get small fonts and backbenchers can't see it legibly. So, 2 tables. So, in this table these are ranks, and when you sum up you get cumulative rank and normalized cumulative rank. Normalized cumulative rank divided by minimum cumulative rank. So, the best variety will get NCR value 1, and the worst variety will get CR max upon CR min. So, the NCR will range from 1 to CR max upon CR min. So, here you can see this one HD 3117. This is new top performer. Initially, when I joined there in 2001, that area was growing PBW 343, PBW 343 as a standard check variety. Most of the farmers used to grow that, so breeders use that variety as standard check variety. The yield potential of that PBW 343 was up to 45 quintals per hectare. Now it has gone down to 25 quintals per hectare, and this is due to some climate change also. During March season, while flowering fruiting, you get sudden rise in temperature, that is called terminal heat, and at that time farmers irrigate the field, and whole field doesn't develop doesn't set seed. So, farmers call it Farra disease. So, we are facing that consequences of climate change. So, after sorting the whole data set, you get this preference order, and NCR value 1 showing SD 3117 as top performer, BHU 25. Any wheat variety released from BHU will be given HUW Hindu University wheat. In Hindi, it will be Malviya Gehu 25. But students have managed the material from pipeline. They have not followed what is being practiced in IPR issues. So, whether we understand rules or not, but Indian system works, and students manage to get the material. So, this way you get for ease of presentation, I thought of merging two tables, that original data and rank data. So, this is merged data, and for poster presentation we can reduce paper, and single table will do, single table. So, इंक्रीजिंग ऑर्डर में स्टार्ट कर देंगे, काम हो जाएगा. और कोरिलेशन कोफिशिएंट डेटा, yield per plot and yield per hectare, you get high correlation. Since yield per hectare is derived from yield per plot itself, so you get near 1, correlation coefficient near 1. So, this way you can reduce feature criteria of selection. If you reduce one, only 10 characters a student has to evaluate. So, this way you can reduce features of selection. So, descriptive statistics you can see, and find out maximum, minimum, average, everything. And see, this is graphical comparison presentation of top two good performer varieties and ideal plant types, crop idiotype. So, this ideal plant type you can see, you can visualize as in cricket you have term all-rounder, and in partners you see, you look for sarvagun sampanna. So, this is imaginary, and first variety is close to it, and we can further improve that variety by crossing other varieties having first rank in that parameter. So, this way we get idea of from where to get good genes. Summary and conclusions. Based on critical examination of 11 parameters of 40 wheat varieties, it could be safely concluded that top 5 to 10 varieties along with 4 kernel bunt resistant varieties could be recommended for cultivation by farmers of this region. If meteorological department predicts rains during anthesis in March, then resistant varieties must be given priority, 4 resistant varieties. So, references on this line we have published many papers, and a lot of students have worked, and thanks. And see this anthers, you are seeing pinkish color, and unless variety it is. Now I will tell about other plant, Edensonia digitata. Edensonia in India, problems and prospects. Let me tell you something in story mode. Trigger of mind for working on this plant comes from roaming in South India, mostly Karnataka, Kerala, Tamil Nadu. I do not know where did I see this plant. I have forgotten, ನೆನಪು ಇಲ್ಲ ನನಗೆ ನೆನಪು ಇಲ್ಲ, ಮರ್ತು ಹೋಗಿದೆ. ठीक. But when I went to Ranchi, some NGO people asked me, come and see two trees are there beside a road, and government is widening the road but not cutting. Forest department is not allowing to cut. When we went there, my mind recalled, and I told it is Edensonia digitata kalpabriksha. When I went again back to Devariya, I heard about Devaraha Baba. He has one ashram. I went there. I saw Edensonia digitata 2 plants planted, and one new plant was coming. So I came and again we saw newspaper report about Edensonia. We went and purchased. I purchased 3 plants. Dr. S.K. Singh purchased one. 501 each plant. Planted at 3 places. But after 1 year, we felt cheated. When it was seedling, we could not recognize. After 1 year, when it started flowering, when buds appeared, my mind thought that literature says it has long vegetative phase, and within a year it is flowering. So I checked at all 3 places, everywhere it was flowering. At home, in my pot, and in college. So I looked at Amazon and ordered seeds and oil, thinking that something edible is there and I will drink or eat. But luckily 16 seeds came, and I used the hair oil, and that is anti-aging. Out of 16 seeds, we divided in 3 parts. I gave 5 to Dr. S.K. Singh. I planted 5 in at home, and 6 in pots at home. So only huh? Not audible. Ready हो गए. Color the leaf.
You want this? Shall I give this?
Okay, I will speak loudly. So these are the seeds that came from Amazon, and see, germination. Only one seed germinated by chance. At that time, I had no idea of its biology. Germination. See, if you play, you will see some insects. So no problem. So when it started growing, it was growing very fast. Earlier, my mind was thinking it will be very slow growing, but I thought I should not maintain in plant and pot, and I should not make bonsai. Let me see it full grown. So we transplanted, and involving many people works better. See, it started growing, and I started observing and taking data. See the plant, that is purchased plant that 501 rupee, and after 1 year it turned out to be that Rauwolfia serpentina, not Edensonia. और उसके 1 साल बाद ये लगाया गया, इतना तेजी से बढ़ रहा है कि आप देखिएगा. ये राजस्थान में रारी में एक प्रोफेसर साहब लगाए हैं, और VC साहब को पता नहीं था कि ये क्या पौधा है, बेकार का चीज़ उनको लग रहा था। ये देवराव बाबा का है, जो देवराव बाबा ने लगाया है। और जो ये प्लिंथ आप देख रहे हैं ना, हम 3 लोग मिल के तोड़ दिए। वो उनको कन्विंस कर दिए थे वहाँ के बाबा जी को, तो उनको भी अंदाज़ा लग गया कि बिकॉज ऑफ दिस प्लिंथ इट इज़ नॉट ग्रोइंग फास्ट, तो हम 3 लोग मिल के इसको तोड़ दिए। और ये रांची वाला पौधा है जो हम लोग देखे तो तुरंत पहचान गए, और ये साउथ इंडिया में घूमने का ही फ़ायदा था कि मैं टैक्सोनॉमिस्ट हो गया। और ये देवरिया जेल में हमने लगा दिया है, एक देवरिया जेल के अंदर एक बाहर। और ये एक डॉक्टर BN सिंह जी हैं जो हमको काफ़ी सपोर्ट करते हैं व्हीट और पैडी ब्रीडिंग में, तो उनके रिसर्च फील्ड स्टेशन पे लगा दिया है। और ये ऑन्टोजेनेटिकल डेवलपमेंट, इफ़ यू study and see the pattern ontogenetical development, you can differentiate 8-9 species of Edensonia genus. That is what I did it. See, first 2 cotyledonary leaves are simple and opposite. Next 13 leaves are simple and seemingly alternate but cyclic. Next 5 leaves are compound with 3 pinna and alternate. Further onwards, plants count lakka martara idare, and sometimes they multiply, means they remember multiplication table. See, and both we should try both type of propagation, sexual by seeds and you get genets, and by cuttings, grafting. I have tried air layering, cuttings also, but not succeeded yet. Some people have succeeded, and I am hopeful that I will succeed. So, that is all. And I brought 6 seeds. Today itself I checked that only 2 are viable. I have given to my taxonomy guru Vishnu Mukherjee, and I hope Ramchandra and Subhas and Vishnu will succeed in germinating. There is only one problem, only one big problem. It has hard seed coat, and because of that it has seed dormancy. Unless you break that testa, water will not percolate. So, but you must know, and there are a lot of videos and you can many things I can tell you which you won't get from internet or other sources about this. Since last 5 years I have been working on this. Thank you.
Okay, he was my batchmate when I was doing PhD. So that is where our friendship goes. Okay. Now we will break for tea. Before breaking for tea, tomorrow there is one small session. Students need not worry. Okay. This session would be coordinated by Dr. Anandi Subramanian. This will be outside in an open area. So we will have an open discussion in open area. So the members of that team will be the Professor Kumar Swamy, then Professor M.D. Subhash Chandran, Professor M.N.V. Prasad, Professor E.V. Ramaswamy. Ramaswamy has to leave at 11 o'clock. He said that he will give session before 11:15 and he will leave. Okay. Then Professor Deepika Shetty, Professor Rajshekar Murthy, then Professor Narsimhaya, then Professor Aruna and Professor Netravati from Maharani Ammani College. You all know her, no? Them? Okay. You please tell them that. That tomorrow at 11 o'clock there is an open discussion. Anyway, I will talk to them. Then our R. Rao, G.R. Rao, then Chandan. Okay, yeah. So Chandan, you please be with madam and help her in this one, in this open area. Okay, arranging the table, chair and all, you take care. And also the intellectual input also is required in addition to the Shramadhan. Okay, the tomorrow at 11 o'clock. 11 to 1 there is a session loaded with a computer knowledge. So I thought this would be better environmental knowledge. So softwares and algorithms and all, so that you can in open area you can discuss. Okay. With this we will take a break. Now it is 5:15. We will try to come back by 5:35. Okay. If you come early, you will go home early. If you come late, you will go home late. Don't blame me. Okay.
And instead of me standing here, I was more or less actually I always told that I am a jungle man or a wild man. So instead of if I am not here, I would be normally be in the dense forest of Western Ghats or Western Himalayas, and that privilege was given by Sir Dr. TVRAMACHANDRA, and I just roamed throughout the Western Ghats, and that was the biggest privilege for me to study the forest for more than a decade. So and and now basically I'm associate professor Jain University. So my topic, an insight into the world of plant endemics in Western Ghats. So mainly, as I told, endemism. So this is one of the very important topic actually, because the endemism is the one which filters all the unnecessary ones, either for the conservation aspects or for actually to know which is a very important part, plant, so either in the plant or animals. So endemism, if you see, so this is endemism is a state of a species being found in a single defined geographic location, such as an island, state, nation, country, or other defined zone. So endemism can be either it can be a endemic which can be seen in a very small isolated areas, or it can be seen in a very large areas. For example, Hopia ponga is found in a huge throughout Karnataka and South India also you can find. But whereas many of the species like Maduka bodiloni, it is found only in a very small selected patches. So this is one thing actually very important thing. So you can see here one of the dipterocarp patches, that is Karikan. So this Karikan is not inside. This is beautiful dipterocarp patch, that is the primary patch, which is it is not that it is found in a very deep forest or something like that. It is found in midst of the villages in Kumta, that is Uttar Kannada. So most of my work was in Uttar Kannada, that is in Karnataka, and part of Shimoga also, which I will be whatever I am telling today. So this beautiful forest hosts one of the dipterocarp forests. So Dipterocarpus, Dipterocarpaceae is a family itself, a primary forest species. So this, like when we say about the endemic species or primary forest species, we have to understand one very important thing, that is actually the primary evergreens and the secondary forest. So the primary forest, what is the primary forest are those which doesn't have been destroyed, or they are undisturbed pristine forest actually. They have not seen any logging or disturbances by the human beings. That is the primary forest what you can see here like this. But whereas the secondary forest, so many of these primary forests, because of the anthropogenic pressures, what happens, they undergo a series of degradations. It can be a small amount of disturbances, or it can be a very huge disturbances. So that lead into the secondary forest. So what we see all around us, actually if you see around Bangalore, Tumkur, or in other areas, we see that actually much of the forests are disturbed. So and we see only some very good forest patches. When you are moving from the Jog Ghat or Western Ghats, you see lush evergreen forest, isn't it? But even in those lush evergreen forest, which is the forest which is, are there any other forest patches in those evergreens which are very important actually? Are there any patches inside those which are more important in the evergreens? Are there any evergreen forests which are more important than the other normal evergreens? So that constitutes a very important, gives us an important term, that is the relic forest. So relic forest is refers to those ancient forest patches which have no history of full scale clearance or major alteration by humans, so that the original composition persists to a high degree. So this term relic is one which are told to have those species which have highest number of endemism, either it may be plants or it may be associated animals. So this in the relic forest, when I see relic, now you have to assume it as a primary endemic rich forest. So this you can get in examples like many of the sacred groves, many of the myristica swamps, which I will be going to show you. So, and this relic forest, what I am telling here, did they simply were there every time, or what is really the essence of these relic forest or the endemic rich forest? So, endemic rich forest, as also I have to mention that these endemic rich forests are also having a very important high value ecosystem services. So, and also the diversity in these also is very high. So, the amount of the high value ecosystem value we get in endemic rich forest, relic forest is very high compared to the other normal forests. So, this relic forest as a so is it actually it was always there? No, actually as we see this relic forest, what is the origin of this relic forest? So, if you want to know the importance of this relic forest, so we have to go back to the time when India was at the not at the place what it is now. It is, we have to go down to below the equator in the South Pole, when it was a huge chunk of Gondwana landmass. We all knowing the Gondwana landmass, that is during the time just after the Jurassic age, when early of the Cretaceous period or the end of the Cretaceous period actually. So, it was just after the Jurassic period that actually the angiosperm, the starting of the Cretaceous period, the angiosperm started evolving. So, the flowering plants, the angiosperms started evolving, and later as India started drifting away from the other Gondwana land masses. So, India started to move all alone. You can see here India all alone, and it came towards the equator, what now actually we can say it as the equator. And during that, when it was in the equator, we see the whole episode of India rafting all alone 150 million years actually, and as it reached towards the Eurasian plate, that is the northernmost where the China it is there now. So, the India reached to the Eurasian plate, that 150 million years was sufficient for it to have its own endemic biota. So, because India, you know, island biogeography thing, whenever any continent or any place actually becomes isolated from other areas, actually it develops its own endemic biota, isn't it? So, that is what the principle has happened when India was all alone rafting, and it reached the equator. So, it was an equatorial regime. So, it was 24/7 rainfall and much of the sunlight. So, that favored the much of the India was in evergreen forest, but as India moved further north from the equator, so it as it reached the Eurasian plate. So, what happened as it reached the Eurasian plate, and here it is not shown, it joined whatever the location it is now. So, the Himalayan belt rose, the Himalayan mountains rose. Once the Himalayan mountains rose, what happens? The monsoon type of climate came in. So, earlier it was the equatorial climate, all around the season rain, but once the monsoon type of seasons came in, what happened? Actually, the number of months of rainfall came down. So, like 4 to 6 months. So, once the amount of rainfall came down from 4 to 6 months, what happened? The overall India became more arid. So, all the wet species, all these species which it evolved earlier when it was an equator, they were all wet species. So, they were all isolated to only wet areas like the Western Ghats or Western Himalayas, Western Ghats and Northeast India. So, like that they became isolated to those areas. So, you can see the India moving, and when India was at the equator, it was equatorial forest, and when it reached the Eurasian plate, this one you can see here, the India had a monsoon type of climate. So, this setting of the aridity forced all the species which needed much of the moisture to get isolated to only certain moist belt, that is like Western Ghats and Northeast Himalayas and Sri Lanka, only in those places. So, much of the other species, wet species in other areas, they all vanished or get converted into secondary other arid, more or less actually less moisture or arid species. So, all those very important rich wonderful species which we got, which evolved from the Gondwana, they were all actually now we see only get from the Western Ghats or Northeast or the Sri Lanka. Such is the importance of these trees actually, or the plants. So, and and even so, even after so much of reduction of these relic species or the endemic species which we got from those episode of Gondwana thing which I told, even after that actually there was a lot of disturbances and more of endemics were lost. That is because one of the what we call it as shifting cultivation. So much of the tribal peoples like the Kumri Marathis, particularly in India, so they went around burning the forest, and patches by patches they used to burn, they used to cultivate 2 to 3 years and go to the next patch. So like that actually they slowly cleared the primary forest, and that is how actually more and more of the secondary forest, secondary evergreen forest or secondary forest became more. So this is how furthermore actually these relic forest or evergreen rich primary forest came down. And even after the shifting cultivation, the British colonization happened, and even the Britishers, they promoted the cultivation of teak. So they thought that actually teak hai to sab teak hai, means the teak tree, if they promoted the teak so much that actually the evergreen forests were bulldozed, and in that actually teak plantations were promoted, which actually it was a disastrous, because teak won't come in evergreen this one. And not only that, for the logging, their naval, their warfare, they again brought on much of these the forest actually particularly from the Western Ghats and other relief forest belt. And after the independence also, the developmental pressures due to which large number of area was brought under hydroelectric power, or much of the logging which was done for the developmental thing. Then the crop revolution which happened, wherein much of the areas came under the crop cultivation. So this is how actually after the developmental pressures also again we lost much of these wonderful forests. And finally after the 1980s, the forest rules become more tight, and with that actually much of the forest already had been lost, and what was actually left was where these relic forests or endemic rich forest remained only in some of the Khan areas, or the sacred groves, what we called all the people worshipped forest, what we call. It was in those areas which they were left, or in a very inaccessible areas like the hilly tracts, or actually in the very Georges and also some of the Sholas also. So it is very in these inaccessible areas actually we see, and the Meristica swamps, if we see in those areas also we find now the relic or the endemic rich forest. And in these ocean of actually large number of areas of these secondary evergreen forest, I am saying actually we see what the scattered these relic or evergreen primary forests. So this is one of the Meristica, swamp. So you can say this is the Meristica fatua and Pinnanga dixoni. And morning also Dr. Karthik was showing you how the Meristica swamp, the soil is very acidic, and due to which actually they have modified a lot of things, they having a roots structures which is having knee roots or stilt roots in order to adapt into those areas. All these species, either it may be Meristica fatua or it may be Gymnocranthera Piscilioneuron, so Vateria indica, Hopia, so many of these are all relic endemic species. And not only that, actually they host the faunal species which are there, either it may be insects or animals, which are they co-evolved with these insects or animals. So though that even those animals like the lion-tailed macaques, if you see hornbills, so Malabar giant squirrels, they are also endemic, which they have no homes except in this endemic rich forest. So this actually, and this is the picture of a sacred grove, and in one of the sacred groves like in Sagar, so you can see that whole area is paddy field, and just in between actually you can see a beautiful evergreen forest, as you can see here in between some patches of evergreen forest. It is again a very important legacy of the people conservation as a sacred grove, or else it would have been long back gone. And this is the spirits actually they worship there, the people worship there in these sacred groves. And So, in order to understand what is the present status of these relic forest patches, so relic species, so I carried out work in the different using different transects in the Uttara Kannada. So, this is Uttara Kannada and part of the Shimoga also. So each they were all transect based studies, and it was I used mainly 20 by 20 meter quadrats, 160 meter transects. So which was with all the trees in the 20 meters were at height, girth and everything, and 5 by 5 meter saplings and 1 by 1 meter hubs. So all these were locations as I told you earlier, as I showed you earlier, all those things, and this is the method. And with all the analysis, with all these different 116 plus transects, what was a very important part is that the endemism is very much correlated with the evergreenness. So as you can see here, this is the graph, this is the regression analysis, wherein as the percentage of evergreen increased. So these are the different transects actually, and you can see that as the evergreenness increased, then the endemism is also increased. So you can see the large number of high endemic transects huddled up in the high evergreen zone, like 90 to 100 evergreen zone. It shows that actually high evergreen forests are very much necessary for high endemism. High endemisms are the ones actually which gives high ecosystem values, including the every cup of water what we drink. Either you take the Kaveri or you take the Sharavati or you take any river. So they all have their origin in some of these type of forest, and these Myristica swamps, as in the morning it was told, they act like a sponges. Many of these relic forests, they act as sponges, and they release the water throughout the year, so that the perenniality of the stream is mentioned. Just mention me any of the other river in the eastern side, in the drier belt of the forest or even drier areas, are they perennial? No rivers are perennial actually. All the perennial rivers what we see is the Western Ghats, and in the Western Ghats, in the these Myristica swamps which I am telling you, or many of the primary evergreen forests like Dipterocarp forest are the ones actually which is giving the water actually. So this is very much dependent upon the evergreenness also. So this is the endemics tend to decline in the wake of fire, logging, grazing and such disturbances, leading to endemic poor secondary evergreen forest. So this is what has happened actually. Everywhere this primary evergreen forest or the relic forest which we got from the Gundavana landmass, they were subjected to lot amount of fire, logging, grazing throughout the ages, due to which now we have the secondary forest which has lower ecosystem services also. So only in some patches like this, they are measuring the Dipterocarpus indicus, that is nearly 70 to 80 meters tall. So and with that actually the evergreenness and endemism distribution chart was prepared. You can see wherever this is the evergreen, these are the different transects, and different colors indicate different percentage of evergreenness. So you can see the highest percentage of evergreenness, where you can see here 90 to 100% of evergreenness here, that is mainly Katlekan, Kumta, Honavara and Sirsi, those areas. And correlating with this, there only you can see highest percent of endemism also, overlapping with the highest percent of endemism. So 60 to 80% of endemism you can see only in those high evergreen patches. So this shows again actually how important the evergreen forest, very properly maintained evergreen forest are. So this is the Pearson's correlation matrix, which also shows the highest correlation between this you can see here endemism and evergreenness. Again the correlation between the evergreenness and endemism is 0.89. Compared to, you can correlate between any of the endemism or diversity or basal area or other height. So these are the different parameters: height, basal area, endemism, diversity. So if you take any of the two parameters, if you combine, the correlation between the evergreenness and endemism is very high, which shows that if the endemism, high evergreenness is there, then high endemism is there. So if you see a high endemism, then it should be having a high evergreen forest actually. So that is what actually you can see from this one, and this is also so that's what here you can see this the percentage endemism is the most decisive factor in conferring higher conservation value also to any ecosystem, because you see in those high endemic forest actually very rare species, relic species, high IUCN category like critically endangered, new species, all those comes only in the endemic high rich forest. So, and having high, so in order to know actually in a small patch also whether the those riparian vegetation, how much it is important in having these endemic species. We surveyed actually the small patch of Katlekan, as you can see here in a we divided actually nearly 2.25 square kilometer grid patch into different grids actually. You can see the grids 1, 2, 3. So, these grids, each grid actually is 500 into 500 meter grid, and in each grid actually you have one stream and also the other non stream forest actually. So, we also had two transects actually. One transect was on the streams which had myristica swamps, and another transects in the non stream areas. So, and when for each grids we did like that actually. So, one transect near the stream and one transect is away from the stream. So, the stream one was called as a swamp forest, and those which are away from the river or a swamp, they were called as the non-swamp forest. And the results was, as you can see here, the results was again showing that actually the swamp forest had nearly 71.3% of endemism, and the non-swamp forest was nearly 51.08%, which shows that actually, even though I am not saying that actually the forest which is away from the riparian conditions or the river, they are not good actually. Actually, they were also dipterocarp forest only, but inside those dipterocarp forest, near the swamp areas, there were more endemic species like many of the myristicas species, then many of the gymnocrantheras, so and many of the other species which conferred to the higher endemism, which shows that actually the riparian vegetations, they confer more, they support more endemic plant species. So, and this is what actually when it was mapped. So, when those whole grid was mapped, you can see this is the stream which the small stream which lead to the Sharavati river, and along each stream in the riparian areas we can see the myristica swamps, and these myristica swamps are some of the species like Myristica magnifica, Gymnocranthera canarica, Syzygium travancoricum, Semicarpus cathlacanensis. All are endangered, endemic, critically endangered, and many were actually, which I rediscovered, that is Maduka bodiloni, which was thought to be extinct. So, recently it was rediscovered. So, all these hosts like that actually. So, this is how, and you can see all these, many of the species like this Dipterocarpus indicus, Myristica fetua, Gymnocranthera canarica, Palaquium, Chrysophyllum, Syzygium travancoricum, Semicarpus cathlacanensis, they represent the relic species. So, when we see that any of the forest actually have these species, then you can say that as a relic or age old forest, which are very endemic high ecosystem forest. So, this is one how you can disappear between the relic species and the other secondary evergreen species. So, this actually, this is because of these relic forest and endemic rich forest, we see that actually all the watershed, either it may be the, you have the Venkatapur or the Sharavati or the Bedti or the Kali river. This is the catchment area of all these rivers. So, the closed network of these catchment were all built because of this endemic rich forest, and in this endemic rich forest have the history of 150 million years actually, which got from the Gondwana landmass. When we think now as to plant, if many times it is told that actually a forest can be cleared and a compensatory plantations or even the forest can be done somewhere. Can they bring these age old forest or the relic forest which has been evolved for such a long period? It is totally useless actual idea. So, whatever we have to preserve it. So, that is the only option what it is there. So, as you can see here, the different areas, if you see only in certain Khans or relic forest, you can see these relic species like Dipterocarpus indicus, Poecilonera and Indica, and in whole lot of all other places you do not find these relic forest, which means that even though they are evergreen species, they might not be relic species actually. So, this is a very important thing actually we should distinguish between these relic very endemic rich forest and the other secondary even evergreen forest also, evergreen forest also. So, one of the other reason, as I was wanted to show, is the fragmentation which is already been told. So, we have lost actually the nearly 69% of evergreen forest, now it has come to 31% actually, which shows that actually the evergreen forest itself is reduced. When evergreen forest it is reduced, the endemism 100% it will reduce, because the endemism is related to evergreen forest, which is really a bad thing which is happening. And also this was shown, and you can see here just in Uttara Kannada the dark patches of green. So, you can see in 1973 how it has been reduced in 2013 because of the onslaught of all agriculture, then monoculture plantations, everything like that. So, this is the Sharavati Valley evergreen, this is a forest in the rivers. You can see beautiful areas where actually having, and this is the Syzygium travancoricum actually, which was newly thought to be extinct and again rediscovered. Then this is the Semicarpus cathlacensis, again a novel species discovered there, Gymnocranthera canarica fruit. So, this is the Myristica fetua coming in the Myristica swamps, and this is the fruit, and again this is the Myristica fetua, Myristica swamp, and this areca and monoculture plantations are right, they are simply hacking in those areas itself actually, because the water will be there. That is why the areca plantations and many things are, many of the plantations are coming there, and we are just hacking down where the water are just originating from there, and where actually can we expect a water later actually if we hack the what do we say, the origin of the rivers. And it is not here, even a well protected forest like Yana, which is a reserve forest, even there like a cancer everywhere actually this encroachment is rampant. And I do not know whom to approach actually those. We prepared a report, we submitted also, but it is not happening as much as it should happen. And this is a Halsoldi swamp forest, a beautiful forest patch, and if you see under, it is really, and this is Dipterocarpus indicus carican, and you can see the Dipterocarps growing 60 to 70 meters tall, and these are the my novel species. So, my which I discovered from Uttara Kannada, and this also a coastal species, and this is also another Eriocolon caravalens, a new species which through with other team actually discovered in the that place 1 hour near in the Uttara Kannada, which shows that actually there is no dearth for novel species also, and there are a lot of scopes to work on this. And you can see here why I am showing this, can you spot actually sir actually MDS sir actually standing. So, we had been to, so we can see he is here, actually you can see here, and you can see just the tree, such a huge tree is there, and unfortunately they were all being cut down for the coffee plantations actually. So, this is how everywhere it is happening in the Tirthalli region, everywhere. We sit comfortably in Bangalore and we think that the forests are being protected there, but unfortunately it is the opposite. Everywhere the rampant the forest destruction is going on. So, there is one very big thing which is happening, and I do not know how. And not only the endemism we can see there, also we can endemism you can expect in many of the places like lateritic plateaus, because laterite also shares a very common place from the Gondwana as with the Western Ghats. So, that is why even the lateritic plateaus in the coastal Karnataka, so there you can see in the monsoon season with a valley of flowers like this, and many of these like Eriocolons, then Atricularia reticulata is the insectivorous plant. So, many of these insectivorous plants and Eriocolons, many of them are endemic, and so many new species are being discovered in that. So, endemism actually is a concept actually where if left for a long time, many of the places they have their own high percentage of endemism. We have to protect it, but this even the laterite plateaus nowadays actually they think that it is a barren land in the summer season, and they let it out for many other residential plots or many things, and these are also rapidly being vanished. So, this is the fate of critically endangered species, and I do not know what actually more thing has to be said, and yeah. So, thank you. I just wanted to tell you that actually one thing what we have to prioritize when we are doing any projects or funding granting is that to look into the quality of the forest, either it may be working with the faunal species or the plant species. If you see that any of the it is attached with the relic forest or if we attach with the endemic rich forest, first we have to give the highest priority for that, so that actually then those when if they are conserved, then only actually we can move to the next this thing. So thank you. So any, yeah, another thing, any questions are there? Yeah.
Thank you, Dr. Rao. Beautiful presentation, especially the way you showed the Earth's history and how the angiosperms evolved. And I have one question. What is the area, the general area of the relic forests in Western Ghats?
Yeah, so this is a wonderful question also, because I have seen this relic forest as small as even maybe a half acre or something like that, which is a part of a sacred grove, and which is also protected by the people there. I showed you in between the paddy fields, and as big as actually it can go to many kilometers also, like in Katlekar and many areas along the riparian streams. So it can be, and large dipterocarp forest also.
Oh,
So,
that's
but
great.
yeah, but they are all not continuous. They are scattered in the whole large areas of the secondary forest actually. Like that.
Thank you so much.
Yeah, please. I think
Sir, you said that a lot of the forest land is encroached for monoculture, and trees are being logged for man's greed. Is there anything that we can do as students to fight against this? Like,
yeah, that's why I also came from Uttar Kannada to here, because I felt that actually I am just sitting there actually brooding over that it will not happen. It is you students actually, when you see here or anything like that, so you can write on that. You can also come up with actually your own school level, college level, university level studies. So go to those places, report, and make a inventory of it, and show to the government that actually even you people understand that they are not understanding actually. So this is one very important thing actually, which everyone has to understand that, and come forward and join their hands and do. One person or two persons can't do it. Already we have tried, we have submitted, it's not going to happen. Even the people who in the Bangalore, they need to know what is the fate of the forest which is giving them water. It is going through actually there. Maybe that children they may not even see also actually. So this is what happening. Everyone, they join hands and say about it to the government, then only it can happen actually.
and the people who actually make decisions with regarding to environmental issues, they have to have a minimum eligibility to get to that post. Like, what is the point if they are the ministers but they don't have the basic knowledge?
Yeah, you go to any of the forest department, ask how many plants they can identify. Then you will know. Not even one plant they can identify. And forest department itself is a big joke. That actually not even one person in the forest department can identify any plant species. And how do you suppose that they can say which species has been cut down? So it is good that actually the people who know about the forest, who know about a plant taxonomist or insect taxonomist or faunal people, actually they have to be inducted into the IFS or the forest department, which is not happening. It is only the administrative people sitting there and rolling whole thing. Yeah, so that is what actually.
They changed the entire the system of allowing engineers because they wanted
more. Yeah, engineers.
You can't expect engineers to have the same kind of sensitivity.
Yeah, of course. That is the thing.
So, do Myristica swamps or relic forest have any special role when it comes to things like carbon sequestration or something?
Yeah, very good question actually. That too, the Myristica swamps, which are very near to the water, you just see the bowl actually, you see the stem, they are really very huge actually, and I showed you how much the big huge trees are there actually, and just imagine how much of the carbon is sequestered in that. And if we just say that here planting one or two trees, we are sequestering so much of the carbon just beside the tree. And there in the forest actually, that too swamp forest actually, they are packed with these trees actually. And just imagine how much of the carbon is sequestered in those areas actually. And if you just remove those and plant with areca and other things, just imagine how much of the carbon dioxide is released. That is tremendous.
One more question. Are they somewhat similar to like mangroves and like, things like mitigating the impact of cyclones or something? Are they similar in any sense?
These are inland.
Oh.
So mangroves are very different from these myristica spams. So
This is a gold mine, okay? That's what even Karthik was evolutionary and ecological point of view.
Okay, sir. Thank you, sir.
Thank you, Jiro.
yeah. Thank you, sir.
So the next you will call, no? Yeah. Who is the next person?
I request Dr. Nasimaya to, yeah, please.
Good evening to all. So, respected chair, receivers. So, my presentation is dietary composition and feeding habits of fish, Jerus filamentous from Mangalore coast. So, the Mangalore coast, this fish, it is a common name, it is called as silver biddy. Jerus filamentous is an important commercial fish. Local fish they consume very much in locally, because the vernacular name of this fish is Paya Mino. Madam knows, she is laughing here. So, she is from Mangalore coast. The diet composition of fish indicates many important ecological factors. So, that includes behavior and condition of the health status, that is condition, habitat ecology and energy intake, interaction between the species in the estuary or in the water body or in any wetland. So, the present, it is a great demand locally. So, that is why the exploratory survey, it is reported from the Department of Fishery, it is indicated that 0.7 lakh tons of gerried fishes were captured in the Karnataka coast, especially in Mangalore coast. So, this in the light importance of this commercial value, the present study was aimed to investigate the dietary or feeding habits of fish and what it is going to be feed in the estuary, that is Netravati and Gurpur estuaries. This is the study area. So, both qualitative and quantitative analysis was carried out to analyze the food and feeding habit. So, this is the estuary. Okay. Light pointer. Sorry. So, this is the where Gurpur estuary is entering, Gurpur river is entering to the north side and Netravati it is south side. So, this is the area, the estuary, that is Gurpur Netravati estuary from Mangalore. So, based on observation of 1773 individual fishes of Jerus filamentous size ranging from 7 to 30 centimeter total length maximum size. So, out of this 951 males and 882 females, fortnightly samples were collected from the Mangalore estuary, that is mainly fishing land and market, the fishes were collected and which is analyzed for both qualitative and quantitative analysis. So, laboratory observations has made the fish, that is this is the fish, the Payamino, the total length and standard length are and weight as measured and morphometric measurement was taken, and later that is for all other the study for food and feeding habits and other related biological parameters are studied. So, then later the fish was the stomach was cut open ventrally. This fish is a narrow flattened fish. So, that is why ventrally we have to dissect out and identify the maturity stages, both male and female. This is a fish is 3 genders are there, that is a male and female and third gender is there, that is very difficult to identify without cut open the stomach, and we have to notate the cut open the stomach. So this is different feeding stages are there based on the size, age and sex. So then the stomachs were preserved in a 5% formalin for further analysis. The qualitative analysis was carried out by for the identification of food organisms encountered in the stomach. The identification is done by using compound microscope and with the standard literature, and food items were present in the gut, which is the advanced stage, we cannot possible to identify. So that is which is treated as a semi digested food in the present study. So the feeding intensity of different seasons, month and all we have studied. So that is based on the degree of fullness of stomach in relation to the size of the fish, which is classified full stomach, 3 by full, and half full, 1/4 full, and little are traces of food, and where stomachs are empty, which is considered as a empty stomach, and fish full stomach with 3 by full and half full was considered as active feeding intensity, and the stomachs with 1/4 full and little were considered as a which is a poor feeding. The percentage occurrence of stomachs in the different conditions which is for whole period was calculated, and the quantitative analysis was done by using the points volumetric method by Heinz 1950 and the TVR Pillay 1952. So the points were allotted based on the food relative size and volume. So these are the results and discussion. So that is you can see here the which is the large points which is there in the which is the semi digested food, because most of the stomachs, so what we observed, that is semi digested. So in next which is 18 food items were recorded, that is mainly amphipods, gastropods, copepods, isopods, crustacean and its appendages, prawn and its remains, crab and its remains, and the gastropods are there, and bivalves and its shells, fish and polychaetes, and semi digested fish and its remains, foraminifera and sponge spicules, etc. All we can see that polychaetes in all the both male and female fishes of 2 year study, the polychaetes is a major food items, followed by prawns and its other parts, and also fish and it remains, and mollusca group. The least which is there sponge spicules, but semi digested which is showing higher data here, but which is because it is mixed group you cannot consider as a highest food. So this both female, almost both female and male, all which is shown similar. So this is the percentage occurrence of food, usually based on the size. You can see the lowest group in the polychaetes, you see the highest food items which is there, and in the developed stages also we can see higher sizes also the food percentage is high, which is similar, which is there female and male in both the 2 years. So this is same data which is graphically. So based on the data, the feeding intensity of both the sexes of Jerus filamentous was found vary with months considerably, and males and female which is a proportion of fish which is had a highly active feed was highest in November month, and which is you can see the lowest in the April month. So earlier studies in the other estuaries which is reported by the Gulikatte, one of the fishery biologists reported in 2000 stated that the sequence of feeding intensity can be correlated with the reproductive biology of Jerus filamentous, that feeding activity was moderate during the pre-spawning, so that is March to June, and low during the spawning season, that is most of the fishes in Mangalore coast or Arabian coast, it is monsoon is the spawning season, so that is why fish banning is there. So the which is low during the spawning season and high during the post-spawn season. So the poor feeding occurred in Jerus filamentous during the spawning period in the study area. So it is attributed to the greatly bulky gonads are present in the body. So that is why the gonads were large in size, fish may not consume much food. So which is the, so that is it is agreement with the our data. So conclusion, the percentage occurrence of food items in the stomach content in both the sexes were found to be vary in different months considerably, and that is it is based on the food items of sand grains, mud, amphipods and benthic organism, especially polychaetes, which are the benthic organisms or burrowing organisms. So this fish, which is anatomy mouth of the fish, it is a protrusible. So it is a retracting and protecting mechanism there. So that is why it is able to feed conveniently whatever the food items present in the smooth bottom of the coast or the estuary. So therefore, it is a feeding on plant matter diatoms also there in the food. So that is why it is the fish which is considered as a omnivorous fish feeding, and the presence of sand grain, detritus, benthic organisms, which indicates that, so this is a bottom feeding fish. Thank you.
Any questions?
So my question is regarding the consumption of fishes like half full, 3 by 4 full. Did you record the time duration according to that, the way we will feed the fish? Like if it is 3 by 4 consumption, the duration should be this particular hour to this particular hour.
No, this is not a laboratory study. So this is we have collected the fish from the commercial catches. So that study may not possible because it is a estuarine fish. We have to bring it estuarine condition to the lab, then only which is possible to study that. So already this fish, the CMFRI people, the hatchery technology recently they have developed. So in future this fish may come for the aquaculture industry. So there is a huge demand is there in the coastal area. So because of a white meat and it is very tasty fish.
Okay, thank you, sir.
No, estuary we can adapt for freshwater also. So the already the CMFRI, the laboratory hatchery technology is available. Yeah, so this is a migratory fish. So major portion of life spent in the estuaries. So for breeding and all, sometime it is go away not long distance, short distance to the ocean. So the juveniles come to the estuary, they grow up, then again same cycle it will repeat.
And they go to the freshwater also.
Yeah, so monsoon because of more freshwater flow is there.
They get into the rivers.
Yeah.
Upstream.
Not very long,
Very far.
so that is also short distance like 2 kilometer. So that reports are there. Thank you, sir.
Okay, thank you very much.
Thank you very much, sir. Thank you very much. Yes.
Sudarshan, yours will be the last presentation. If I allow you now, you will run away. Okay? Yesterday you did that. Being a part of lake committee, you ran away. Okay? So now we will have Manoj.
Thank you, sir. Thank you so much, sir. Yes. Okay, good evening everyone. From last 2 days we are talking about that we are facing problem, water scarcity, and how forests are helpful and how forest and watershed goes hand in hand, the relationship goes hand in hand. So this is a kind of solution to all those problems which I am bringing, This is Jal Shakti Mantralaya's work which is being done in Jal Shakti Mantralaya, and Ministry's work which has been done in Chhattisgarh, and by God's grace I was there, I was given a chance, and this is the work which I am presenting. This is Nakti Nala watershed, which is a product of NARVA. NARVA is soil water moisture regeneration work which is being carried by Chhattisgarh State Forest Department, now Chhattisgarh's Forest and Climate Change Department. Okay. So, that is an introduction to the slide. This is my introduction. Introduction to Nakti Nala. Why this particular thing came into existence, why NARVA came into existence? You see, food is the one thing which makes you do work, and when you come to this Western Ghats, the amount of water which you have here is 5000 millimeter, I think if I am correct, 5000 mm which was told. 5000 mm of rainfall is there, but in Chhattisgarh it is only 1207 mm. So, and the geography, the lithography of that particular place is, it is on the Gondwana and the igneous rocks are there. So, the water whichever it fills, it runs off. There is nothing which stops it in that particular area. The forest cover we have, it is around 44.421%, but the dense forest is very less, it is around 11% only, which is towards Telangana and your Maharashtra region. Okay. So, when we thought about this, this is something which was thought about the ministry also, and we are doing that work. NARVA, the word means rivulets, okay, your small streams, brooks which are ultimately becoming a river, So, this work is done in sub basin of one river, that is your Hasdo, which is a main tributary to your major river, that is your Mahanadi. Okay. So, Nakti Nala is a catchment of 4,304 hectare of land, forest land. This is a forest area. The catchment is the same. The treatment which is done. So, when we were developing this thing, it is a ridge to valley approach we are taking, and we are trying to see wherever there is a chance where we can stop the water in the forest so that it can percolate inside. We are constructing or doing some constructions like what? Not concrete constructions, but digging up contour trenches and other things with which the water percolates deep inside the soil gets the water and it is able to percolate into the catchment. So, the current this particular drainage line is 47 kilometers long, and what it affects, why we have taken this is something which is very close to your tribal areas, and also some villages are there. So, the current usage of this drainage line is irrigation. It talks about irrigation since tribals does not have, and the deep forests are there, you do not have electricity, so that we can run away with we can run this electric pumps and other things. And forest, if you talk about Chhattisgarh, Chhattisgarh's major revenue comes from rice production. It is the rice bowl of India, and it has 20,000 species, 20,000 varieties of your paddy, 20,000 varieties of paddy. So, to help that revenue also, we are doing this. Structure of Nakti Nala, there are these three different type of structures we are making: erosion preventing structure, water holding structure, and moisture containment structures. These are erosion preventing structures. All are, maximum of them are non-concrete, so that water can percolate inside. These are water holding structures. These are moisture containment structures. The main thing which we are focusing is that the maximum water which runs off should goes inside this this catchment area only. The waters, these are the Nakti Nala structures which have been done through NARVA. This is the entire catchment. I think color will be clear on your LCDs, which will be much more clear in that. So, what we are saying is first degree, second degree, third degree, and then main Nala, the main catchment, the main drainage line. So, we are trying to see wherever there is a chance we can stop the water in lower spaces, we are trying to stop it over there. LBCDs, gully plugs, stop dams, staggered contour trenches. So, what I have done for CGFCC is that I have prepared a all inclusive database, geodatabase. And why we have concluded this? Because many of the times people say that forest department is not working. That's true somewhere, but what happens is we are not able to document things. Majority of the time it is that we are not able to document things. So in this we are trying to document, we are trying to make a geodatabase under which we are trying to see every single thing possible that this particular project can give to our tribal people or also the local people which are there. So this one geodatabase, which the one work which I am presenting is only post monsoon work. This is done on pre-monsoon also and then monsoon also. So it is 1.58 lakh data points into 3 times. It is only in one watershed. We are making 33,000 watersheds like this. 33,000 narvas are identified, and structures and these small preventing structures, these 3 kind of structures are being developed. Okay. So project 1 which I have made for them is baseline and forest resource assessment. This forest resource assessment is done by our deputy Shri Venkatachalam sir, and baseline is also created by him. So this second project is what I have created for them, that is a soil and water profile for Nakti Nala, which is a pilot project which I have done, and this will be reciprocated in the entire state. This is Chhattisgarh. Chhattisgarh has major basins. Basin is the biggest one. Okay. Likewise, you have water tower in Western Ghats. We have water tower in Chhattisgarh. That is a Bakunpur. That is the Mekala Hill ranges. That is 2700 feet from where your majority of your watersheds start. So we are trying to stop water wherever is possible, because water scarcity is a big problem there. This is entire India's waterways that I have created, and Chhattisgarh, this is the place where I am working. This is the Korea division of CGFCC. That is, if you are able to see this, this is the Sarguja circle. It contains 4 division and 6 district. So my work is now constrained to this. This particular line which is going on, this is the Hasdo river, which is the main contributor to your Mahanadi basin. So I am trying to see what these watersheds over a period of time can give to this particular river, because that is the main aim which we are aiming. So with one arrow we are trying to shoot down so many things. This is stack layers which are developed, and these are 58 criteria which are there for producing this geodatabase. Second project is your soil and water profile. This has around 22 stack layers. Okay. Maps and details. So Narva is a very comprehensive study which we are doing, and we are trying to see all the possible faunal. We are trying to assimilate all the possible faunal and floral information into our geodatabase. What things which I have added into this is livestock and human population, and also all the water outlets which are there in that particular catchment. That is, even if they are working or not working, your water draw points, bore wells, pipelines, everything which is there. So these are the water draw points which I have taken. Faunal traces, grasses, herbs, faunal sightings, crop composition, and this is the entire Nakti Nala model. So this will be clumsy because everything is there in this. Project 2 maps, we are testing these soil parameters, okay, and we are doing water parameters also. We are testing water also. That is something different, because we were first trying to see what is the quantity which we can give. Now we are trying to see what quality we can add up to. So we are doing that also, and everything like your borewell and all we are doing, because the depth of water over there is around 400 feet. So 400 feet when you go, the fluoride and other things comes into picture. So that is not good. So we are trying to see what this will have over a period of time what Narva will affect into. And the water test, the water which I have tested is tested against this particular brand, because this was something which was available in forest. It's deep forest. You will not be, it's 400 kilometers from your last airport. So it's deep thing. I am doing this work over there. This is the water testing kit. 3 parameters I have taken: turbidity, conductivity, TDS, because these only can be tested with this organoleptic compounds. So water turbidity in that area. So you see that there are 3. One is your main watershed, 1 kilometer buffer, 2 kilometer buffer and 3 kilometer buffer. So I am trying to see that. In 2 kilometer buffer only I got these samples, so I have represented only 2 here. Then your this water TDS and your conductivity. Then we have done the 13 parameters which we have taken for soil, soil magnesium, soil moisture, because this is what is actually meant when we were starting with this project. Then soil boron, soil nitrogen, soil sulfur, molybdenum and soil carbonic carbon. So if you see 33,000 Narbas, if there are watersheds and we are able to do the carbonic content for every single thing, we will be able to write something for GCF also. That is the long term plan for the department. Naktinala soil conductance which is going on, and some future projects which can be done is seeing not only the soil carbon content but also the content which is there in your forest stand. So we are doing that also, and we are trying to take data from your standing crop also. So 18 tree species has been identified, 7 dominant species are there. These are statistics like which is fuel wood, what is which is an good wood, because actually that is a resource for us. This is a girth class in which these are the local names which are written: Kikar, Parsat. Kikar is your Acacia nilotica, Parsa is your Butium monosperma. Okay, Sida is the Legistromia which is there, and it is the hardiest species, so it's surviving over there in less water, and also you will find it in abundance over there. Over the girth class, every single tree species is recorded, and this is a soil test results. So potassium and nitrogen is in good amount, but the thing is we are lacking in some of the things. So the soil tests were done by a government agency, and we have soil report card for every single data point. So the data point which we have is intensive. We will not leave anything when it comes to soil and water. And slowly, this is only 3 parameters which I have taken. Now we will be going into all the parameters which are there. Around 50 we will be trying to do. Not entirety of the watershed, because that is a big thing, but at least from one division, one Narva. This was Kinley which I have done, and this is the turbidity, conductivity, TDS in main Nala and also in the catchment areas, which has been represented over here. And this was the discussion which I have shared with my campus CEO also. The thing is, every single Nala or watershed which we are taking is not entirely into that forest land, it is somewhere in revenue land also. So the data of the trees which are there is not in exact condition what is there in your working plan. So forest department works with working plan, and that is the data which I am showing, that it is 4.68 cubic meter per hectare, but the real value in the working plan was 34.45. But how did it happen? Because this Narva has some part of area in revenue land. So the revenue land is not us who is managing, and that's a degraded forest, or forest. I will not be calling it forest. So it's the water in main Nala. The water quality is very close to in very close proximity to ICMR and BIS standards, which I have showed. There is one SP3A, that is a sampling site which was there. It has water. TDS is less than your this particular brand of mineral water. So that is that amount of clear water. My wife is sitting there, she drank without knowing that that is a sample which I have collected, but nothing happened. So that shows that water is safe to drink. Okay, and that was a good joke even in the department when I presented this thing. Okay, so the range of limits is in standard, it's very close to the limits only, it's not going away. But when I talk about soil, when I talk about soil, soil somewhere has no, it's in shortage of something. So the test results which we have gone through for under the government agency, they have recommended some of the things which are there. That is, the vermicompost is needed to be added, neem cake powder, biofungicide, azadirachtin and trichoderma. Inference is this local milli watershed which is lying in 4304 hectares, is taking care of your 10 villages which is lying in its 3 kilometer buffer, 5,000 human beings and 3,000 domesticated animals. But we have still to wait for our tiger census which we have done, our elephant census which we have done, our small faunal census which we have done. So the amount of water it is giving to the wildlife also, that is, we are still we have to go through the data. Recommendations which I have given to the department at that time when I was there as a researcher and now joined. So these are the recommendations, and they have accepted most of them. Most of them they have accepted, and they are now we are coming with the labs also, water and soil testing labs, and I have recommended good system also, because working with that much amount of data, now my system for the first time it hanged and I said you give me new system, and they have provided. So they are in that way, they are very much. The future works are going like this. We are doing vegetation mapping, that is NDVI. We are doing MNDWI, which sir been knowing, because otherwise I was first doing NDWI, now I am doing MNDWI, that is water surface analysis, water surface coverage analysis. And environmental flow is the last thing which I will take help of EWRG, TVSR and NSR in a long term. Hopefully sir, we will see you there soon. Acknowledgement to my CEO Campa, Srinivas Rao sir, and to all the division members which have helped me in this. Thank you.
Yeah, any questions?
Hello sir, initially in your presentation you showed us some pictures about different shapes and ways of creating a depression in the grounds for holding the water. So was there any prior study done to like study the direction and flow of the water during monsoon to decide what kind of
look, this is only a pilot project which I have done for project assessment. Okay, the main work which is done, my deputy is actually not present here because of APOs which he has to file in ministry, but they have done entire work, and this is NRRC who are they are in contact with, so they are doing that.
Okay, thank you.
Yeah, just I had one question actually. What was the total area you told actually?
That was 4,304 hectares.
So in that only 18 species were there, trees actually.
That's only what has been documented. Okay, that's what I am saying. Over a period of time, we will come with the data, because
saying that you invite him so that